Hello everyone. I welcome you all for the Snowflake and DPT live training demo session. So let us start our today's session. So I have muted everyone to avoid the background noise. So I will take all your question and answers. So after 30 minutes. So let me start the demo session. So I will give you the walkthrough of the Snowflake demo session. And after that, I will take all your questions. So if you have any specific questions now, so you can chat with us. Okay, so you can ask your questions through chat. So I will answer every now and then. So once again, thanks for everyone, and let us start our today's session. So this particular live training, I'm going to take Snowflake as well as DBT. So both I'm going to take. So right nowadays we have a lot of opportunities for the Snowflake and as well as DBT combinations, and also for other cloud platforms. So now everyone is looking for the cloud platform, a skill set, as well as A and ML related skill sets. So definitely for if you want to survive next 5 to 10 years in IT industry, yes, definitely we need to focus on these cloud platforms as well as A and ML. So artificial intelligence and ML related skill sets. Okay. So even if you are going to work, if you are willing to work in A and ML related projects, so definitely you start with cloud platforms, right? So definitely we are the data providers for A and ML projects. So where they will train the models and they will do A and A and ML related projects. And even so we are going to work with business intelligence project as well. So where we will load the data into Snowflake and do the transformation logic, and then it will be used by the business analytics team. So this is the agenda for today's session. So first we will see about myself, and about the course, and what is the prerequisite for this particular course. And so we will see that what is Snowflake and what is DBT, and scope for both Snowflake as well as DBT. So what is the scope and what is the job opportunities we have, and how it differs from other cloud technologies. Yes, we have Azure, we have, so right, data, we have the Databricks is the competitor for Snowflake. So if you learn Snowflake, then Databricks is very easy. And if you are already working on Databricks, then learning Snowflake is very easy. So both are like similar kind of the day-to-day responsibilities, roles and responsibility we will perform on these two technologies. So we do have other cloud platforms like AWS, Azure, and GCP. So how it differs, and we'll see that as well. So whenever we are going to work on this Snowflake environment, yes, definitely we will work on other cloud platforms as well. So we need to have some basic knowledge about other cloud platforms. And in addition to that, so how are we going to practice the Snowflake and DBT and any other platforms, right? So along with the DBT or Snowflake, so how are we going to practice this? So how are we going to set up the models in our Windows machine? Everything is a cloud, so on cloud. So that how are we going to create a account? So what is covered in this particular training, I will take one by one. And I will take all the question and answers. I will take the questions. So from participants, I will answer it. So if you have any specific questions during the session, so please feel free to ask your questions through chat. As of now, I have muted everyone to avoid the background noise, and I will take, so first is I will explain all the concepts, then I will take your questions one by one. Okay, so this is about me. So myself, Chandrasekhar. So I'm a real-time senior BI consultant. I do have 16 plus years of experience in information technology. So I completed my Master of Engineering in the year of 2009 at PSC College of Technology, Coimbatore. And I have totally 16 years of experience, and out of which 10 plus years of experience in in, in offshore. So from 2014, and I worked different projects like banking, insurance, life science, and telecom domains. These are my uh, the different domains I worked so far. And so this is my offshore and onshore experience. I worked 13 years in offshore, and last 3.8 years I'm in onshore. I'm in Canada. So I'm working for currently I'm working one of the insurance domain client. So you should have already seen my YouTube channel. I have 1,24,000 subscribers as of now. And so I worked different projects like a development, production support, technical lead roles, as well as data architect role for Informatica as well as Snowflake. And so now I'm working with Snowflake and AWS and Databricks and Azure platforms. Okay, so one of the A&ML projects. So we are the data providers for that particular team as well as data analytics team. And this is my skill set. So I started my career with SQL and PLSQL, and I moved to Informatica Power Center, and I have worked in Informatica Cloud. So I started from the Informatica Cloud. I started journey with the cloud platforms. Then I worked with Snowflake because IaaS and Snowflake is the data cloud data warehouse where I started with Snowflake. Then I worked with the different cloud platforms like AWS, GCP, and now Azure as well. And even I worked with the reporting tools like uh, Power BI, Tableau, and Teradata. So migration, I worked on Teradata migration. So from Teradata to GCP migration and Informatica Power Center to IaaS migration, and even a lot of SQL Server to Databricks migration. I worked already. So different project I worked. So this is my skill set, and I have already completed my certification on this IaaS as well as AWS. Previously, I completed Tableau, and now last July I completed my Snowflake course certification. So this month I have already registered for Databricks certification. I'm going to write it. So this is about me, myself, and I'm a real-time working professional. Okay. So about this particular course, I already completed 27 batches for IACS already. But for Snowflake, I already completed one batch for weekend session. I completed. So now we are weekend session. I'm taking this DBT. So this is my second live training batch for Snowflake. So weekday batch. This is the first batch I'm going to take, and so I have already completed all the topics whatever we have for Snowflake and as well as DBT. So we have. And this is the training batch from Monday to Friday, morning 7 a.m. So this is the time. So we'll take this particular time. And if you are in Canada or USA, then this is the timing. Okay, so 8:30 p.m. EST, Sunday through Thursday. So this is what we have the timing. So as of now, this is the timing. Later point of time, I will take weekend session. So both for IACS as well as Informatica Cloud as well as DBT. And later next year, I will start taking Databricks as well. Okay, Azure Databricks. And so this particular Snowflake with the DBT, so both we have 70 plus hours of training I planned. For this weekend, almost I completed 70 plus hours of training already. And so this is the same content I'm going to take for weekdays as well. And so this is about daily 1 hour session. So I'm going to take 1 hour lecture and 15 to 30 minutes the questions from the participants, the learners. Okay. So this is what the plan. So daily I will give you the exercise. So I have complete exercise, everything for each and every folders. I'm going to take the session. I will give you the exercise with the different tables and different the use cases. So you have to complete those exercises. If you are completing all the exercises, so definitely you will master in Snowflake. So you know, right? Already we have a lot of opportunities for Snowflake as well as DBT. So a lot of migration projects, a lot of data engineering projects are going on. So you can check any job portals like Naukri.com or LinkedIn, or if you are in US, Canada, or different job portal, you can check it. And here I'm going to give you a 120 days Snowflake trial account. So this is the trial account. We can use it. So I already created this particular trial account, and students also created this trial account. They will use it. So I already posted this video on YouTube, so you can check it. So this particular account we will create. And similarly for DBT, so here we are going to take a DBT cloud setup. So this is also for 14 days trial account we can create first, then we can use it for any number of days. So there is no expiration for DBT cloud. And similarly, I'm going to give you this along with the DBT and the Snowflake. So I will tell you how to create an account with the Fivetran. So Fivetran is nothing but or any data extraction tool. Like this is one of the data extraction tool. So I will give you that how to create an account, but it needs business email account. And also I will give you that so how to create IECS account also. You can create it so you can explore more on this the projects because whenever we are going for any projects, right? So if you have multiple skill set, so definitely they will consider you. So you have to have multiple skill set nowadays. So one single skill set, so we cannot survive on this eh, cloud platforms, right? So multiple skill set we need. And this is what, so I'm going to cover, right? And daily exercises, yes, definitely I will give you a lot of exercises if you are completing that. So you can complete Snowflake certification as well as any interviews, you can clear it. Okay, so troubleshooting session. So that is the advantage of live training. So because if you stuck somewhere, so we will have some troubleshooting sessions. And so definitely you will not get any questions because so that is what I used to take. But if you have any questions setting up or any questions, so definitely you can ask on daily basis. And if you want to share your screen and take it up some troubleshooting, yes. So I welcome for this troubleshooting session as well. And question and answer session, yes, we will have 1 hour of lecture and 15 to 30 minutes of question and answer every day. Okay, so Monday through Friday we'll have, and separate WhatsApp group will be created for batch members, and we'll be there in the WhatsApp group. I'll be sending reminders about all the updates for this particular training batch. So what I'm going to take today, and I will give you that whatever the announcement I will give you on this WhatsApp. And then, so we have the learning portal access. So I will give you this learning portal. I will walk you through this learning portal. So all the recordings, notes will be there in this learning portal, and you will get a lifetime access for this recordings. Okay, Snowflake as well as DBT. So whatever we are having, it's similar to Udemy. So how you have the Udemy access, right? Similar to this, you can anytime you can watch it from here, and it's more convenient. Okay, method to access my course materials. Okay, and after that, so most of them will ask for, okay, so can I get the projects, right? So how can I explain the project? So are we going to explain the project? Yes, I'm going to explain the project. So how we will be using our use case in our real-time project. So what kind of reports we are creating and all this I will explain. And project, the architecture, and so what roles and responsibility play, and agile methodology. So how we will deploy the code, like integration Snowflake with integration with GitHub, and as well as any GitHub actions to deploy the code or Jenkins. Okay, so any one of the deployment model, I will explain it. And GitHub and everything, I will show you practically. This is the same model we will use in our real-time project as well. Okay, so with that, if you are going to explain everything with your interview or if you are practicing it, so definitely you will get more knowledge. And if you are going for any interview or not only for interview purpose, so if you are going to work on the real-time project, there definitely you can show your presence. So that I can give you 100% guarantee that definitely you can explore more on this. So project exploration sessions. So I will give you some uh, mapping sheet. So I will ask you to create some projects, okay? Like starting from extracting ingesting the data from the files to Snowflake to the transformation logic, either in Snowflake procedures or some SCDs or notebooks, as well as DBT. So how we are going to do. So that kind of projects I'm going to explain. So you will also do that. Okay, so this is what you are going to make it. And if you ask me, so what is the prerequisite for this particular training? Okay, Snowflake, I'm going to learn. So what is the prerequisite? So whether this Snowflake, if I'm going to learn, okay, you are spending some time, you are spending some money. So how are going to get back those money or the time, right? Or whatever you are spending. So next 2 months, you plan it for this particular training, like November and December, please focus it. And definitely the next year, new year, right? You will get, you will plan it for job change or career change. So role change also, you can plan it. Because if you are planning for any uh, job change, you're planning for higher package or anything, so this is the right time to learn it. So for this particular Snowflake, this SQL knowledge is very, very important. Okay, SQL knowledge. And if you want to go for nowadays, we have the Python, right? But we have Copilot or Copilots are integrated with Snowflake as well as GenAI is integrated with Snowflake. So you can get some help from assistant from this Copilot, and you can make use of that Copilot to create Python code as well and SQL code as well. But SQL knowledge and Python code, basic knowledge is enough to, we need these knowledges to work on this particular project because SQL knowledge is very, very important. Okay, so but basic Python knowledge is enough. And basic ETL knowledge we need. So how are we going to extract the data? And so EDL is nothing but enterprise data lake. So where we are going to do the curation, data curation, and then so how are we going to consume by the business analytics team, right? Business analytics as well as intelligence team and the ML models, how they are going to run the models on top of our data. So that's what, so we are going to explore more on that. So A and ML, we are not going to see, but you are going to work with that particular team, business analytics team, as well as A and ML team. And basic power center knowledge is not needed for this one. Okay, so I'll just remove it. And basic cloud knowledges like AWS, GCP, Azure knowledges we need. So what is AWS, what is GCP, what is Azure? Because these three cloud platforms, we are going to create the account in our Snowflake training. So we'll explore more on this because Snowpipe will create based on this one, and external stages, external tables. So everything we will create on these cloud platforms. So you will get more knowledge on these platforms. So if you know something like IACS or any uh, ETL tool, so that is also added advantage here. Okay. And so if you go to any projects, right? So how are the real-time projects, so how the source systems and how the Snowflake and all the cloud platforms will be there in real-time project. Yes, I can explain this. Okay, this is what the project we are going to see. Okay, so we are not going to see all the data loader, all the cloud platforms, because in real-time project, any one of the cloud loaders, data loaders is enough, and any one of the platforms. Okay, so we'll work on that. And data consumers, it's a different team. So if you see this one, data sources, if you go to any projects, we might be getting the data from heterogeneous sources. It will be our own in-house applications or third-party vendors. So vendor applications will be getting the data. It may be the on-prem data or cloud platforms or live streaming data. So streaming data from Kafka or Spark streaming or any streaming we are getting are cloud platforms. We may get the data from third party as well as the other cloud platforms. We can get applications and API also. Some APIs we may get the data, and RDBMS, Relational Database Management System. So ingest the data to this Snowflake so that we are going to perform. So how are we going to ingest the data? So we will have data loader. So different tools are available. Either we can use any one of the tools, we can use it. So Fivetran, Stitch, Airbytes, Matillion, ADF, Azure Data Factory, or AWS Glue. So any one of the tools we can use it, and just a data loader. Okay, extraction. If you take IACS, it will extract the data, that is Informatica Cloud, extract the data, transform the data, and load it into this cloud platform, right? But here it's just a data extraction tool. So even click replication, you can use it. So I worked in one of the project where we were using click replication. It will replicate the data from here to here. Like we will connect with the service now. So we'll take all the service now ticket informations and load it into the Snowflake, and it will be consumed by different reporting teams. And similarly here also, it's not only with ServiceNow. So a lot of APIs and a lot of source system we will have for the projects. And these data loaders, right? It will extract the data from the source system and load it into the Snowflake. So mostly we will perform the ELT logic. ELT in the sense extraction or load, just to load the raw data. So after loading the raw data, we will perform the transformation by using the DBT. So either we can use DBT or even Snowflake itself, we can use transformations by using notebook. So nowadays, Snowflake incorporated with the notebooks, similar to Databricks. So where we can apply SQL and Python related codes, and then we can schedule it also. So which is very similar to Databricks, right? So I'm working both Snowflake as well as Databricks environment, the Azure Databricks environment. So I know how the real-time projects will be. So I can explain the same kind of project architecture, and I will give you more business use cases. Okay. And after loading the data into the raw data into this particular Snowflake, so we'll be using the data build tool. It's nothing but DBT here. And this we will create a models, right? A lot of models we'll create. Models is nothing but, so here we are writing everything on the procedures and the task we will schedule it, right? Similarly, our notebook we will be creating. Similarly, here we will create SQL models, .SQL file. So a lot of models will be created. It's a modularity. Different files will be created, and it will automatically do the testing, documentation, and even orchestration. We can integrate with Airflow or any other tool. So that as well I will explain on this DBT here. So DBT, we are going to see complete one, and what we are going to cover in DBT or Snowflake, I will explain. Okay. So Snowflake, we are loading that and use the DBT or Snowflake procedures, or a lot of tools are available. You can use, if AWS, if you have data in AWS S3 or GCP GCS, okay, Google Cloud Storage or Azure ADLS Gen 2. If you have any file system, you want to ingest the data, you can use Snowpipe. So just use the Snowpipe, or even you can use stages, right? External stage. So you can just use it and ingest the data to Snowflake. So after that, do the transformations by using Snowflake procedures or DBT or even SQL here, notebook. You can use it. So DBT, it's a platform agnostic tool. It is not only going to work with the Snowflake. If you learn this DBT, so yes, definitely some project they will use DBT with Snowflake, some project they will use DBT with Databricks, some project they will use Amazon Redshift with DBT, Google BigQuery with DBT. So anything is fine. So only thing is the DBT transformations, everything is same, but only thing is the underlying platform is different. So after that, raw data we are going to convert it by using SQL. So SQL is the main language here. We are not going to use Python in DBT, just SQL only. Then transformed data will be loaded here. So after that, it will be consumed by different business reporting team, right? So this is the actual project team we'll have. And if you go to any banking or insurance or any client, right? So there you'll be using that. Okay, so you need to have business knowledge as well. So what kind of tables you will get the data? So what kind of source data you'll get? So how are we going to do the data lineage? So if somebody is coming, your reporting team is coming to you and then asking that, okay, this data is not loaded correctly, the report is not showing the correct data. So then we have to backtrack it, right? So how are we going to backtrack? So DBT, we have the data lineage graph. So it will automatically tell tells you that, okay, so this is what the data lineage, right? So how the data is being populated from raw database to the transformed database, and it will give you everything. Similarly, Snowflake notebook also, we can do the troubleshooting and everything. So that business knowledge we should have. And this is the data consumers and raw data. So why are we going for, instead of ETL, why are we going for ELT? So because nowadays we are not going to work with only with this reporting team, right? business analytics is not only the project. So nowadays, business analytics as well as A and ML projects are coming up. So A and ML team, so they will ask us, okay, it's a complete project, not only for business analytics, business intelligence. As the project architecture is designed such a way that, okay, so you extract all the data, ingest all the data. It's like a structured, semi-structured, unstructured data to the Snowflake environment or Databricks environment or any other cloud platforms. After that, okay, if this business analytics team, they need the data for business analytics, then do they will do the transformations and they will take the data from here. If they need to train the models by using A and ML models, right? So then they will take the data from raw data from here and they will use it. They're not going to take the dimension table or fact tables from here. So they will take the raw data from here. They will train the models. So that's a real time use case. So why are we going for this raw data? And then after that EDL. So extra this enterprise data lake come into picture where the curation will happen. That lot of curations like dimension fact tables, transformation logic will be applied and it will be loaded into this particular tables. So this is the complete architecture where we will apply our business use cases as well. Okay, so that use cases, yes, definitely I will explain later in our live training. Okay. So if you want to contact me after this particular session, you can contact us through this support at nicitacademy.com to this email, or you can contact to this number. Okay, it's a WhatsApp number because I'm in Canada. So you can contact through WhatsApp and I will be answering all your calls. Okay. And you can go to the website also we have the contact numbers, so you can contact here. Okay, so if you take, so this is the Snowflake account. Okay, so 120 days trial account, so 74 days left out, and I have consumed almost $400 of US dollars of credits they will give us. So almost $280 I have already spent, and so this is the 74 days left, right? So here this is what we are going to learn it. Okay, so whatever we are going to learn, so everything databases we can create and we can do a lot of uh, explore. Okay, so it's not, I'm not going to tell you that okay how we will use the Snowflake, because so everything we will see in our day-to-day live training sessions. Okay, so how are we going to use this particular tool? So every day I'm going to give you some exercises, so you have to complete those exercises. Okay, it's not, I'm not going to give you the, so this one I will give you. Okay, so how to connect with and how to create a database, schemas, and the roles and responsible. The roles are back and everything. Okay, it's not only with this one, and so everything we are going to see that internal stage, external stage, the cloning, and everything we'll see. And so all this whatever we have options here, so that we will see one by one. Okay, so monitoring, marketplace, catalog. So now Snowflake they changed. So previously it was like a data, right? So now it's a catalog because it's a competitor with Databricks. So because if you go to Databricks, so they change it to this name as catalog. So here also they change a similar way with the Databricks, how we have similar way we have. So notebook, everything they are bringing. So nowadays we previously we had worksheet, but now they're going to remove this worksheet. They're going to place workspace, right? They're going to bring us workspace because they were not going to use worksheet. And also the notebook they're going to bring, and we will explore more on this notebook. And in notebook also they're going to bring A and ML. Okay, so this assistant, co-pilot assistant, it will be there in the real-time project, but here since it's a trial account, we don't have co-pilot. Okay, but in real-time project, yes, definitely you'll have this co-pilot. So whatever the SQL or the Python, okay, as of now, Snowflake will support SQL and Python, right? But Databricks will support Python, SQL, and different R and Scala it will support. But here it will support two different languages, Python and SQL only. So see, it is very similar to how we are working on the Databricks environment. And I have integrated this Snowflake with Git, right? GitHub, and it will be So you can see this. Okay, this is the addition. New file has been added here. And this is something like, okay, so you have something and you can create a pull request. You can pull the data from here and a lot of branches are available. Okay, so these branches I created from the GitHub environment, right? So you can see that I have already created the GitHub here, and GitHub also you can make use of this. I will explain this GitHub also. So how to create this GitHub pull request. So what is commit, right? So actions and everything we will see later. Okay, so how to create a pull request, get it reviewed, and merge the code into the different branches here. So we will create a branch and we will do that. So this one will do how we are going to do it in our real-time project and in DBT also. Okay, so this is the DBT account, okay, the environment. So where we can create DBT models here, and this is our studio, right? So you can create, it's very simple SQL only. So we have to do this SQL, okay, SQL only, where we will perform all this on the SQL. It's a model. So, okay, we will create a models here. So you can see the models, right? And a snapshot. Snapshot is like a taking the, like a tracking the history. So that we will take the snapshot and we'll write the macros for reusable one, and test we will create, and we can do the run, and so we can create run here, dbt run, or from here also you can run. So this is the UI one, and this is the dbt. You can see that. So how are we going to run the models, right? So that we can run it from here, and we can perform all these activities on dbt as well. Okay, so because everything is there in dbt, so I will explain that. So it's a practical session. Okay, so dbt also. And in Snowflake, so what are we going to cover in Snowflake if you ask me? So let me take this particular Snowflake one. So just to give me a minute. So I'll go to that Snowflake. So this is the content I'm going to take in the Snowflake. So everything content is ready. It's like almost, so this is the content. Okay, it's not 35 days. It will be more because each topic, some topics will go for 1 or 2 days. So this is the architecture. Okay, so first introduction to Snowflake, then Snowflake trial account, Snow site. So this particular the URL UI, we will call it a Snow site. Okay, so this is the modern one because previously we had the classic site, that is classic one. We are not going to use it. Now they changed it UI because last July or June we have started. So that was different. Now so everything they changed it. Okay, so because every now and then Snowflake or Databricks, they will change it, the UI, and that as well you can explore more on that. So we will see that as well. Okay, and if you see the Medallion architecture, so Medallion architecture that I will explain, and so load data from local files. That is the internal stage. I'm I'm going to explain. So we have the user stage. So different stages are there that I will explain user stage, stable stage, and so different stages are available. So that I will explain, and named stage, right? Validation errors, different table types. We have 9 different tables. So all the tables we will see one by one. Okay. So retention, data retention and time travel, fail safe, zero copy cloning, right? Task, how to create different tasks, change data capture and streams, Snowflake data types, constraints, and select statements in Snowflake. Okay, so clustering and micro partitioning for performance tuning and data masking, right? And AWS free trial account and also Azure free tier account and GCP free tier account for this to create external stage, external table, as well as Snowpipe. Okay, so working with Snowpipe, so working with Azure, working with GCP. So that I will take, and slowly changing dimensions. Like we have the type 1, type 2, and type 3. So all this I'm going to take. So all the types, as well as I'm going to give you exercises also. Views, materialized views, stored procedures, and UDF. So user defined functions. So I will give you exercise. Okay, so for each and every topic, I'm going to give you the exercise. So exercise will be, okay, so you'll be completing. So if, for example, a stored procedure exercise, So I'll ask you to take exercise like this for each and every topic. I'll ask more questions here. So you will complete all the exercise. Okay. So you will do that exercises here. So each and every topics I have already taken the exercise every now and then. So I will update these exercises. Okay. So Python and notebook, data sampling, data sharing, performance tuning, and Snowflake data AI cloud. So what is that? Snowflake nowadays it's called Snowflake data AI cloud, right? So what is that? Then we'll go for ETL mapping sheet. So how are we going to use in the real-time project? So that I will explain here. And interview questions and answers. Okay, so I have part one, part two now. Then sample resumes. So I'll give you 5 years and 10 years, both resumes to you. So you can take. So Snowflake and Databricks comparison. So both comparison I'm going to explain. Snowflake certifications, right? So if you are planning for certification, I have sample questions and answers and a different certification also. I'll explain that. And project level sessions, Snowflake quizzes. So I have taken a lot of quizzes. That quizzes I'm going to give you. So each topic has quizzes. Okay. So SQL's here, and I already completed my Snow Pro certification. Okay. And if you go to any particular topic, yes, definitely I will give you a lot of exercises, quizzes. Okay, each topic will have quizzes. So every day you have to complete, okay, at least topics. Then if you are going for quizzes, then you will get clear idea. The quizzes will be there in the website itself. You have to take, and you can verify your answer here. And exercises, yes, this is what each and every topic I will give the exercise. Okay, so no, don't worry about the exercise. I'm going to make you more hands-on, because you need to do the hands-on. If you do the hands-on here, so then it will be very easy to work in real-time environment. Okay, so retention, okay, fail safe, so time travel, so everything is there, exercise, right? So exercise are there, so you have to complete those exercises. So every topic has exercise I have already completed. So DBT also, so I have put all this DBT also. This is what I'm going to take. Okay, so DBT, so introduction to DBT, so DBT setup, and DBT with Fivetran. Fivetran is nothing but it's a data extraction tool. So we can take ADF also, Azure Data Factory, because I'm going to explain Azure also, right? So that you can create it, and models, materialization, macros, seeds, snapshot, hooks, and so project, right? Interview questions, quizzes, and Snowflake with DBT resumes. So that I will give you. Okay, so how to make DBT setup, right? So if you ask me, so yes, each and every topic, I'll give you the materials also. So this is what about the training, and so this is the tool we are going to use it. So this is a Fivetran tool. For example, this is one tool we are ingesting the data from Google Drive to Snowflake. So it will be like just a data integration. Just we are going to replicate the data. So I will tell you that, okay, so how to use this Fivetran tool, and it just you can do this sync. If you're manually, I'm just doing the sync now to show you that, but it will be automatic scheduled. So auto scheduled. So every now and then you can do the sync here, and this is the same kind of tool we were using in our real-time project also. Okay, and so in addition to that, so GitHub and DBT, so everything I will explain, and everything is like a hands-on. So you are most of them from my Informatica background, Informatica batches also, about the training, right? So how I will take the training. Similarly, I'm going to take. Okay, is this class we will learn Snowflake ETL or DB? It's a both, everything. Okay, Snowflake ELT. Mostly we will do the ELT. We'll extract the data from source system, load it into the Snowflake. After that, we will perform the transformation logic in Snowflake. So that by using notebook as well as procedures and cloning, all this we'll do that. Okay, so that ELT logic will perform here. And if you ask me, so how you will give us the materials and everything. So you can go to the student login here. So you can log in with your credentials. After that, I will give you that. So you will create account here. Then with that, so you can access it. So for example, I will show you that. So how I have given this one. for Snowflake first batch. Okay, this is the batch. You can see this. So each and every batch, they will have this way. Okay, Snowflake quizzes and so recordings here, right? So week one, week two, this is the weekend training. So this way they will have. Okay, so for example, I want to go for this one. Okay, this particular topic. So this is the way you will access the content. Okay, everything is online. So anytime you can watch it, any number of times you can watch it, and this is what you will have. This is what you will have the session. Okay, like this, you will have the daily sessions. So everything I'm going to explain in this way. Okay, like a complete practical session. So you need to understand the Snowflake, right? So completely. So you have to practice. Okay, Snow CLI. This is nothing but a command line interface. So that I will explain it for this Snow stages, right? So that how to do that. So this is streaming, zero copy cloning. So AWS account. So this is up to 10 sessions. Then we have this one. Next sessions 11 to 20. So lot of almost 70 plus hours I have taken. Okay. So this is the data sharing, right? So everything. So how to do this data sharing. So what is data sharing? And I have explained in the tool itself, right? The Snowflake itself. And if you go to this download, right? So downloads where you can find the materials, right? So for example, I want to know the SCD. So I'll go here, SCD, slowly changing dimensions. SCD type with MD5, UDF, stored procedure, and everything I have explained here, right? So this is what you will have. And so any number of times you can watch it. So this is the one. And so below to that, you can find download materials. You can go to that. So you can access all the materials. For example, today I completed. So that is yesterday. I completed this TBT. So if you go to this one, right? So you can go inside, you can get the materials here. And similarly, for example, I want to go for, so this one, right? Any one particular topic. Okay, so here I'll go here. So what is zero copy cloning? So I'll put all the content, exercises and everything. You can download it from here. So you can watch it. So this is lifetime access. Okay. At least 1 year you have to watch it once, at least once in a year. You have to watch it to gain the access. So otherwise Google, they are removing the access. That is the policy we have. So once in a year you at least you have to watch it. Okay, so that is the one prerequisite for this. Then you will have lifetime access. Okay, Snow Pro. So what is that different? A lot of topics I have taken. So this is for this one. Okay, so DBT today I have taken. So that is for yesterday for India. So you can take this one, right? So what is DBT and everything I have taken here. So practically account setup, GitHub integration, models, run models, and even I have taken the quizzes. Okay, so so what is that quizzes also? So I used to take, and I will give you some quizzes also here. And if you take, this is the DBT one, and I explain them. Okay, so what is that DBT, and so how are we going to use it? So this is what you will have day-to-day activities, and so you will so so what is DBT? So how to set up, how to integrate with GitHub, and everything I explained here. Okay. So you can always check this particular link to get the materials and everything. So that will be more convenient to you, right? You can download the materials, you can practice it anytime. So this is what the training program for all this Snowflake as well as data engineering, like Azure data engineering. So next year onwards, January onwards, I'm going to take Databricks, Azure Databricks. So for Databricks also, I started preparing the content similar way. Okay. So next year I'm going to take. So before that, I will complete my certification on this one. So are you going to cover SQL? So SQL, I will take Snowflake SQL here because Snowflake we need SQL and DBT also we need SQL. But SQL, I'm not going to teach you that. Okay, so what is select statement? All this, what is joins? So because SQL is the prerequisite for this, You can search my YouTube channel. I will give you the SQL, okay, SQL videos. You can watch it. So I'm working on Power Apps, okay, and Power Automate. Yeah, Power Automate, yes, you can work on that automation. I have knowledge on SQL, but not on ETL. So ETL, you can learn it from here. Okay, so ETL, you can learn it from here. And also, I will give you videos on ETL. You can learn it. Okay, so if you learn Snowflake, then learning Databricks is very, very easy, I can say. If you are from Databricks background, then learning Snowflake is very, very easy. Okay, so what is your YouTube channel name? Okay, so channel name is NIC Academy. So you can search it, Nick IT Academy, then you will get the channel. Okay, Nick IT Academy. So, or you can go to the website and you can get from the website also, you can get this YouTube link also. Okay. So you can search with the NIC IT Academy, you will get the YouTube link. You might be coming from YouTube, right? So you can take a YouTube link also. Yeah. And so ETL videos, everything is there on YouTube itself. So you can take. So this is the weekday batch, and the weekend batch I will start later. Okay. So weekend batch I will take later, but this is the weekday batch. And if you have any questions, you can connect with me on this WhatsApp number. And also this is about the training. Okay, so this is about the training. And so this is the weekday training. Okay, so Monday to Friday morning 7 a.m. IST, and Sunday through Thursday. So this is the time. Okay, this is my second live training batch for Snowflake, and I already completed 27 batches for IACS. So this is the weekdays training. So weekend training I will plan it later. Okay, so because most of them are looking for weekdays, I already completed weekend. Once weekend that completed, I will start IACS as well as Snowflake, right? So this is about the training I already explained. And weekday batch, yes, correct, exactly. So which job role I get Snowflake? So do Snowflake, it's a data engineer role, data engineering role, data analyst role, data architect role. So based on your experience, so data architect role and everything. So all these topics are included in self-paced training also. Yes. So if you want to take self-paced training, so even you can go to this particular self-paced training as well. So you can take this one also, right? So self-paced training also you can take. So you can put this one courses.nicitacademy.com. You can go to the self-paced training. There you can find all my training programs. So like Informatica IACS, so Informatica Power Center, complete training module, and CAI production support, so admin production support, Tableau I have taken, and Snowflake data engineering. So this is only Snowflake, but I'm going to add DBT also as a separate one, and Databricks and Power BI. Power BI taken different trainer. Azure data engineering and Databricks has taken different trainer. So later point of time, I'm going to take Databricks and I will add that as well. Okay. So if you are not able to take this weekday training, then you can take the self-paced training. But self-paced training you have to take yourself. Okay. So you have to allocate your time and you have to start learning from here. Okay, by yourself. So this is more on Snowflake or DBT. Both. Both I'm going to take. Okay. So that's what I explained already, right? So Snowflake, these topics I'm going to cover. So once this is completed, and I'm going to take the DBT here. So DBT is like 20 hours of training, and Snowflake is around 50 to 60 hours of training. So that I'm going to take. And this is about the training. And if you want to join it, so I'm going to take. So what is the timing, right? So timing, it's a 7 a.m. IST. So they same time. So whatever we are seeing today is 7 a.m. IST, same time. I'm going to start from Wednesday. Okay. So Wednesday, I'm going to start. That is 5th November, right? So 5th November, I'm going to take. So real-time working professional, I can share more on this real-time use cases. Okay, so contents are same for live training and self-paced training. So whatever you are comfortable, you can take it. So both contents are same. Okay, so Snowflake live training as well as self-paced. But only thing is self-paced, you have to take care. You have to allocate your time and you have to take care by yourself. It's very similar to Udemy. So how you will take, right? But live training, I'll be there to take your questions and I will answer all your questions. Okay. On Azure Data Engineer path, so what other tools or technologies I can, yeah, so after this DBT or Snowflake, yeah, Azure, if you are planning for Azure, I would recommend you to take Databricks. So because a lot of projects are now coming with Databricks, okay, I could see in our real-time project as well. So a lot of openings are there for Databricks. Okay, in the the company itself, I can say a lot of openings are there. Okay, for Databricks as well as Snowflake, both are like competitors. Azure data engineering, yes, a lot of projects are there. AWS DevOps, Azure DevOps, a lot of projects are there. But everything on the cloud platform, you need to take that. Okay. So this particular session, if you have any questions on this session, like about myself, so I already completed about myself, right? So this is the introduction about myself, and I have already completed all this about the course prerequisite. I have explained. If you have missed out, so please watch my recordings. It's already there on YouTube. I already put it there on YouTube live, so you can take from YouTube also. So when is the going to complete? So session is going to complete. Snowflake is going to complete by December, and January I'm going to start with the DBT. Okay, so DBT. So because 2 months I need for Snowflake and 20 days I need for DBT. Okay, so both I need. So it's a 3 months program. Snowflake. So both you have to learn completely. It's not, we are not going to just, we are not going to rush up and then complete the training. Okay, because the end motive is, so definitely you need to have complete knowledge on Snowflake as well as DBT. So that is the uh, agenda here. Okay, I am new to SQL. Okay, I'm into DevOps. Should I join this day after tomorrow? Yes, you can join. Okay, you have to enroll for the course and you have to join and you start learning. Okay, so you are spending some money, you are spending some time. Definitely that will pay you, right? So because of the skill set, so I got a lot of projects here in Canada. Okay, so because of the skill set I have, right? So similarly, you want to survive the in the IT market, definitely you need to have different multiple skill set on the cloud. So after completion of this batch, is good time to switch in January 2026. Yes, definitely I can say. So if you are planning for any career switch, right, company switch, this is the right time to learn it. And January by Jan mid, because December most of the company they'll go for a vacation, right? So after that we can utilize that particular time. You can learn it completely Snowflake and this DBT and plan it for your job change next year. So definitely that will work out. Even later point of time, 1 or 2 years after that, your company is moving towards on the migration or any other opportunity you are getting. That time you cannot go and uh, go and learn it, right? So immediately we cannot go and learn. So utilize this particular time and learn it. Okay, so that's what I can say. So Snowflake versus Azure Data Engineering, which one you suggest? It is completely up to your choice. Okay, so I cannot say that it's a it's a two different platforms we have. Azure also a lot of projects are they are using. Snowflake also they are using. So that is up to you. So whatever you are learning, learn completely. That's what I can give you. Okay. So I'm working as a PLSQL developer. I and no knowledge of Python, whether I can switch to data engineer. See, nowadays, Snowflake as well as Databricks, we have Copilot Assistant. Okay. So even I don't know complete Python. I know basic Python, but I'm writing codes nowadays on Python on my Databricks as well as Snowflake notebook because we have the Copilot. So whatever we need for our but troubleshooting purpose, we need Python knowledge. Okay, because without Python knowledge, we cannot survive. but troubleshooting knowledge we need. But nowadays we have assistants, right? So that will help you. So you can learn it. Don't worry. And so sorry, I couldn't take all the questions. You are giving the questions on this question and answer also. If I missed any questions, so I will request you to raise your hand. I will take your questions through. I will unmute. Okay. On Azure Data Engineer, so what are other tools, technology I can take? So DBT, yes, you can take DBT, you can take Snowflake, you can take Databricks, right? So Azure DevOps, it's a different one. Azure Data Engineering is different one. ADF, so Databricks, we have a lot of opportunities nowadays. You know, right? You can search it online. If you go here, you can search uh, Snowflake with, so you can search Snowflake, right? Sorry, give me a minute. So you can search here Snowflake developer. Okay, so developer, so Naukri profile. So you can check it here. So a lot of projects are there. Okay, so you can go here. You see how many opportunities coming up, right? So we are not going to look at all this, right? But a lot of projects are there. So 4 days ago, EY, so they posted 1 week ago, then 1 week ago, right? So 2 days ago, PwC, Infosys 5 days ago. So 2 days ago, a lot of projects are there for Snowflake. Snowflake, yes, I can say that a lot of projects are there. Exaware, Infosys, 5 days ago. A lot of projects are there. See how many projects are coming up, how many of them are put at 34,000. Not all these are related to Snowflake, but some pages at least. You will have thousands of opportunities, right? So if you are planning for any switch, right, Mindtree. So you have this 5 days ago, they put Snowflake, Snowflake Databricks here. They are asking. It's very similar to our projects. So what we are using, data lake, data ETL, IACS, PySpark, Snowflake. It's very similar. DBT here, Snowflake data warehousing 3 weeks ago, right? A lot of projects are there for Snowflake developer, data engineer, and a lot of projects are there. So that you can search it. You can do. Okay. So are you going to teach DBT integration with VS Code? No, I'm not going to teach with VS Code. So instead of why do we need VS Code? This is just I'm going to take this SQL, right? So you can start learning, you write SQL here, or you can write SQL in Snowflake, take that SQL, create a models here. Okay. So in DBT, we are not going to perform any Python, only SQL we are going to do. So that SQL, you can write it here itself, models. But if you take Snowflake, yeah, notebook, if you want, yes, you can use some IDEs, separate IDEs. There you can use Python code and develop it and take that code here. So that you can take. Snowflake use AWS, GCP, Azure. And then why client not use directly AWS, GCP, and Azure? Yeah, good question. So that's what I'm going to take in our training session, right? So Snowflake will use, so this particular account I created on AWS, right? So AWS Canada, I have created here. The Snowflake will use that. Okay, so Snowflake architecture, if you see, so it will use we have three different platforms like Azure and AWS and this one, right? GCP. So on top of any one of the platforms, we can create the account, right? So this is the GC Snowflake architecture we have. And if you take, this is this particular storage, right? Storage where we will store all the data on this cloud platform only. So that is what it will take. Snowflake will use this cloud platforms for storage and all this cloud services and virtual warehouse and the compute, right? Compute is nothing but virtual warehouse cluster. So it will take that cluster here, it will run all the SQLs, and that is what the Snowflake will do. It's a decoupled architecture. Okay, so if you take Azure or AWS, yes, AWS we can use Redshift. In GCP we can use BigQuery. In Azure we can use Snaps Analytics, right? But the thing is, so this is what even I'm going to take that in our session. These questions I will take in our session itself. So we have three different platforms. Then why do we need the Snowflake, right? So that's what the advantage. It's a decoupled architecture where computation and storage is different. But here, AWS Redshift or BigQuery and everything. So you cannot decouple cluster as well as the storage. We cannot decouple here. But in Snowflake, we can decouple it. So that's the one thing. Advantage of the Snowflake. So even in Databricks also same thing. Okay. And so Databricks also same, right? On top of AWS, on top of Azure, on top of GCP, it will work. Okay. Sorry, I couldn't take all your questions in the chat. And I think I have explained it. So I'm working as a ETL tester. If I want to move Snowflake, so what I need to learn? Okay, so for this one, I can say, so whatever you are in ETL side, that will help you on the Snowflake as well. And definitely we can completely, you can go and learn it and you can make your resume as Snowflake developer and you can search for good opportunities because tester, so I can say that okay, you can move to developer, okay, like the Snowflake developer data engineer role because data engineer is nowadays more wanted one, right? If you have any questions, please raise your hand. So I will unmute. So you can ask your question through chat as well as this one. So I have unmuted. If you have any questions, you can take. So meanwhile, I'll answer.
Yeah, yeah.
Minimal
Hi.
knowledge of Informatica. Yes, minimal knowledge of Informatica is enough. Yeah, please go ahead. Sorry.
Hi. This is Raj.
Yeah, please go ahead, Raj.
Yeah. So I'm from testing background, not from ETL or something. Uh, I have experience in UI testing and API like that. Okay. So I just want to transfer my career into data. Okay. So like even I don't know SQL, I have to go through. So my question is like parallelly, I can learn SQL and this goes parallelly. So how can I catch up?
Yeah, you have to learn SQL completely because for this, whatever the role we are going to play with Snowflake or Databricks or AWS or Azure, right? So everything is related to ETL and SQL and Python, right? So Python knowledge, basic knowledge we need. SQL, we have to learn it completely. So that I will give you some SQL notes and SQL videos. Already I posted a lot of videos on SQL on my YouTube channel. So that you can watch it, you can enhance your knowledge. Okay, so that I can give you. But this is the right time to switch your career to data engineer role because if we want to survive for next 5 years or 10 years into this IT market, definitely we need to enhance our knowledge. So otherwise, a lot of AI and ML projects are coming up. So if we are not enhancing our knowledge, we will not be there in market.
Okay. So, and one more question. Okay. So, other side, if you see there is big data, Hive and Apache. So, like how it differs actually from Snowflake.
Yeah,
And
actually, in my previous project, okay, so two projects they have decommissioned this Hive and Apache Hadoop projects because nowadays everyone is moving towards on Azure, Snowflake, or AWS projects, right? GCP, these kind of platforms. So now no one is, I don't think most of the companies move to this Databricks or Snowflake because this AI and ML projects are coming up, right? So that's why. Two
okay.
different project I have seen practically there they decommissioned Hadoop and Hive projects. But everything is same concept only. So I cannot say that okay, if you are working on this Hadoop or Hive, so that knowledge also will help us here because everything is ETL and we are handling big data, right?
Okay. So, and last question, like, so we used to practice it, right? Because it is the online mode, of course. Okay. So, if in between we might have some queries. Okay. So, how to resolve it? Is there any team is there to help you then and there?
I will be there. Okay. So I will be there.
Okay.
I will be giving you the complete. Okay. So whatever Snowflake you are, for example, today you are I am completing this file system, right? So I will give you some exercise. So you have to complete this exercise. Okay, so I'll give you some exercise here, right? So instructions, I'll give you one by one. So whatever I performed in the session, that I will give it to you here. Okay, so you have to do it. And if you are getting any doubts, next day you can connect. Even sometimes Saturday and Sunday. So I will conduct this troubleshooting session. So where you can connect with me and you can ask your questions what you are facing. That's what normally I will follow in our IACS training as well and Snowflake training as well. Most of them will
Okay.
complete because you have to put some effort to learn it.
Yeah, hi. Sure. Brijesh this side. So, what will be the fees for this training session?
Yeah. So for fees for this one, for Snowflake data engineering, for this all this training materials and everything, right? Snowflake, I'm charging 15,000. Okay, so if you want only for Snowflake, if you want only for DBT, so I can charge this. This is the amount for 5,000. It's Indian rupees. If you need both, yes, I can. So I can give it for 18,000. Okay, this is the final charge. So there is no negotiation on this. So because everything I'm going to give you that online portal and I'm going to take next 2 months, 3 months program, right? So this is what the final amount. Okay, this is the fees.
Okay, so class will be start from 5th of November, correct? Means
Yes,
day after
correct.
tomorrow.
Yeah, day after
Yeah,
tomorrow.
okay. And what about tomorrow? Means we will connect or there's no class?
There is no class for tomorrow. So tomorrow just I'm giving for registration. So we will do the registration and we will make it like in the portal. Okay, this NIC Attack Company portal and make it everything ready. Then we'll take the session from Wednesday. Okay, some people will they will say, okay, don't start on Tuesday. That's the reason I'm starting from Wednesday. Okay.
Okay, okay. Good. Thank you.
Yeah. So I have received one more question. Are you going to take Databricks from Jan 2026? Yes, exactly. So I planned. So next week I'm going to try my Databricks certifications. So after that I will completely prepare the materials and I will take Databricks live training session from Jan 2026. Okay.
So, do we have any specific this certification for Databricks or how it will goes like
Yeah,
if
yeah,
you
we
can
have
elaborate
Databricks associate certification, separate
for
certification.
Databricks?
Yeah, Databricks alone we have.
Only one certification we have in Databricks,
No,
like
no, no, lot
or
of certification, role-based certification, lot of certifications are available. I will give you the walkthrough on Databricks side. Okay.
okay, sure.
So can you hear me, Chandra sir? I couldn't hear you. Can you hear me now?
Yeah, yeah, I can hear you. Please go
Yeah.
ahead.
So I just wanted to know, like I know like you are covering DBT live training sessions, right?
Hmm.
So when you say DBT, like so once data get ingested into Snowflake, right? So you'll be like showing how you're going to transform using DBT and then create an automated pipelines like automated test and as well as the execution.
Yeah, yeah, yeah. Everything I'm going to teach you on this DBT cloud. So this one.
Okay, DBT.
Yeah.
Okay, okay,
So DBT. So we are going to ingest the data through this Fivetran also. Okay, by using that.
okay.
From
Yeah.
any of our platform to Snowflake raw data, we are going to ingest it by using just ingestion tool we are going to
Yeah.
use.
So I know
Mm.
like DBT, when you say like it won't do a data load, you use any other ETL tool or any tool to load it into raw layer in Snowflake, and then from there you do
Yeah,
like all the transformations, right? Like so when you say DBT, right, you also show us like the automated CI/CD, how we are going to deploy it as a real time project, like how we are going to implement it in DBT. Say for
yes,
example, if
yes,
you have a
yes,
raw data coming in, really you transform it and you apply data quality checks, lineage, and everything are going to show.
exactly. So I'm going to show you that project as well. So this project architecture, I'm going to explain complete architecture. Okay.
Okay.
So getting the data from the source system. So we can go for this Fivetran tool or ADF, right? So Azure Data
Yeah.
Factory,
Yes. Okay.
and you can create a material
Yeah,
or any
matter. Yeah.
other tool you can create it, or even I explained yesterday, I explained for our weekend batch Informatica Cloud to extract the data from the source system
You mean?
on-prem to Snowflake. After that
Okay.
DBT we are going to use it and integrated with GitHub, and it will be loaded into the transform layer here.
Okay.
Okay,
Fine.
everything.
Okay, fine.
Chandra, Uday here. Can you hear me?
Yeah, please go ahead.
Yeah, you said like a 70-hour class and Snowflakes and DBT is 50 hours. So the 20 hours is for database. Is that included in all the package, like 18,000? I'm kind of confused over there.
Yeah, everything. 50 hours for Snowflake and 20 hours for DBT. So
Oh,
yeah, for
okay.
both we have. Yeah, SQL I'm not going to take because Snowflake itself I'm going to take SQL, right? So everything Snowflake SQL only. So that every now and then we are going to take. But basic of SQL you need most of them from SQL background only, right? But if you are from non-SQL background, I recommend you to watch my SQL sessions. But this is the fees for both DBT as well as Snowflake. It's a 3 months program. Okay, so both will be a 3 months program. It will complete. Snowflake will complete by December, and January I will start with the DBT, and both will be a 3 months program.
And what about Databricks? Databricks
Next
is
year I
not
will start. Yeah, next year I will start. This is a separate training.
separate training.
Yeah,
Okay,
yeah.
gotcha.
This is a
Okay,
separate one.
okay, okay. Thank you.
So if we need to take Databricks also, so will it be like DBT and Azure Databricks? Will it have overlapping or how?
Yeah, that's what I planned. So Azure Databricks with the DBT because it's very similar. Snowflake also. So I can take here 10 hours. That's more than enough because so whatever here we are performing, only the platform is different. But in our
Okay.
real-time project, what we are working, so we don't have DBT. So Azure Databricks itself will create everything on the notebook, and it's a temp table. We'll create temp views. We'll create and modularity. That's what we will perform and load it into the data lake, and it will be consumed by the reporting team, the Power BI team. That's what the team we have. So weekend class,
Okay.
I will plan it later because weekend class just I'm going to complete next week. This DBT one, I'm going to complete this by 9th, and after that I will start the weekend session. So weekend session I will
Okay.
take later because just now I completed weekend session. And
Okay. So for the weekday session, all 5 days, is it 1.5 hours every day? Is it?
yeah, correct. 1 hour of session, then
Okay.
30 to 15 to 20 to 30 minutes for questions and answers. So if you have any
Okay.
questions like this, you can always connect with me and ask your questions daily basis.
Monday
Okay.
through Friday, is it?
Yeah, Monday through Friday, India time,
Okay.
morning IST,
Understood.
7 a.m.
Okay. Got it.
So if you are planning for registration, please connect with me on this WhatsApp number. Okay. So I will give you
Where?
the instruction. This WhatsApp number, you can connect with me.
Okay.
For anyone, if you want to register it, please connect with me because online I have only put Snowflake alone as of now. DBT, I will add it later. But if you want to register it for both, so please contact with this number. I will guide you. And I got one question. Are you going to take Snowflake admin? Snowflake admin, I'm not going to take because Snowflake admin is different. But here we will do some kind of admin activities also because we are the admin here. We will take, but it is not a admin course. It's for development course, data engineer role course. Okay. So admin, separate admin, I'm not going to take, but so how to create the data warehouse, compute, RBAC, right? The role-based access and control. So that I will teach here. But so separate admin, that I'm not going to take. Okay, it's a data engineer role. So will certificates available after the course completion? Yes, certificate, course completion certificate, I can give you. No worries. So that we are, right? So we are registered firm and we have the GST number and whatever you are paying that. So we are also paying for the GST 18% to the government, Indian government. Okay. So we can give us you the so course completion certification. Okay. So we are authorized to give the course completion as well. Sorry, I couldn't take all the questions because I got a lot of questions here. Um, so basic knowledge of admin I will cover. So that is there already. So you can learn it. So I'm fresher SQL and PLSQL developer choosing Snowflake. Yeah, if you are from fresher, like at least 2 years of experience you need in IT to switch this Snowflake and this one. If you are from freshers, you are already working on this SQL or PLSQL, I recommend you to learn this. Okay. So whatever the time and whatever the money you are paying, definitely it will pay you. Don't worry on that. So now we are learning. So because of the learning, so even I paid a lot of money for learning. I have taken a lot of Udemy courses. I have taken live training. I have put some money for certifications to enhance my knowledge. So okay, so that's what I will get more. I will get more projects, right? So that will help you. So if I want to get this particular project, that particular time I cannot learn. So whenever you have some time, just to learn it. So whatever we are learning today, so that will help you tomorrow. Okay, so don't worry on that. So how many years of experience I can claim the Snowflake? Yeah, good question. After completing this, at least you can claim 2 to 3 years of experience in Snowflake and DBT. Okay, so because not more than that, previous experience you can use your whatever you have already working on SQL in ETL testing or whatever the experience you are working on that you can claim. But after that you can put Informatica or Snowflake or Azure Data, Databricks or anything. So that you can add it yourself. So 3 years, 3 to 4 years you can claim that I can say. So that's what the knowledge I'm going to give you. So ETL tool is not required to have this. We are moving ELT model. Yeah, ETL tool. So now we have Informatica Cloud we have. So Informatica Cloud with Snowflake also some projects they are using. So it's a combination. Informatica IaaS with Snowflake, Databricks with Snowflake, right? So Snowflake with the DBT. So like combination they are using. So they will, so different project, they will go for different skill sets. So, and if you have any questions you want to ask me, so please raise your hand. So I will unmute it and you can ask your questions.
Hi, Chandra. First of all, thank you for establishing this platform. I
Sorry,
have
your voice
tried.
is very feeble. Uh, your voice
Hello?
is, yeah, please go ahead. Your voice is very feeble. Yeah.
Yeah, 1 minute. Yeah. First of all, very thanks to you to establish this course because I had tried in Hyderabad so many courses, which is not good in terms of content. And I observed so many openings. They are asking Snowflake, PySpark, Databricks, and one ETL, SQL, Python.
Yeah, this is the exact skill set. A lot of projects are there nowadays because one single skill set, so we cannot go with. Same skill set, I'm working on the real-time project for one of our client, uh, this in insurance client in Canada. Okay, so all this skill set, whatever you have, you put right. So all this skill set, I'm also working on that. In our ETL environment, right? So how we will have the Snowflake. So why the companies are moving towards on the Snowflake? So because Snowflake, they are going to use it for data AI cloud, right? So they are going to use this one for data AI cloud. This is the Snowflake. So where we will load our data, right? So we are going to load our data here. So why companies are moving towards on the Snowflake? Because they want to make their platform to withstand all the queries, AI related queries, right? So that's why they are moving towards on the Snowflake environment. So this is, they will have in the data warehousing side. So they will make sure that this is the Snowflake here. We have the Snowflake here, right? So it's a Snowflake Data AI Cloud. So that's a name, Snowflake Corporation. They have changed it. And this is why they are using it because they want to go for two different workloads. So one is BI workloads. So BI means business intelligence, right? So we have the business intelligence here. So business intelligence workload here. So business intelligence meaning, so whatever the business report we are taking, right? So that's what we will take the business intelligence reporting. So we'll take all the business intelligence reporting. So Power BI, Tableau, so all kind of reporting we are going to take here, the business intelligence reporting. Then we have the AI one. So artificial intelligence. Another one is artificial intelligence, right? So we are the AI. So AI and ML related project. So two different projects. Mostly our companies are working. So this is for business analytics. Okay, the companies how they want to analyze their business. This is for mostly for user experience. Okay, better user experience. They'll go for AI and it will give the suggestions. All this. So this particular system either they will go for Azure environment or the Snowflake environment, right? So that's what. So here we are the ETL developers, data engineer. So here we'll use data engineering role and then we'll do it. So this is like data engineer role. So we'll perform as a data engineer or data analyst or ETL developer. So we are responsible to create all the business intelligence reporting. We are the responsible person to load the data. After that, business intelligence developer, they will create the reporting here. So here data scientist. Yeah, we are the data scientist, right? So we are the data scientist and they will be doing all the data science here. Data scientists, they can do data science related project. Okay. So who will bring the data to Snowflake? So that's a main task, right? So here we have the Snowflake and we have different kinds of data sources. So what kind of data sources we'll have? So we may have data from any RDBMS. So we may take data from RDBMS, right? Yes, definitely we may have data from RDBMS. So we may have data from any other platforms also. We may get data from cloud platforms. Yeah, it's not only batch data, we may get the continuous data. So continuous data, we may get it from here. So that way we'll get. Another one is we may get data from directly from APIs. Okay, so we can connect our source system directly, that APIs, and then we can get the data. And then we can go for other systems also, file system. Okay, so our customer is third party customer. They are extracting as a file, they are sending to us as a file. So from the file also we have to read the data. So then we have to go for some file system as well. Right? So different way of sources we have. So what are the different sources? So even if you are going to work on this, definitely you'll get RDBMS, Relational Database Management System, mostly like OLTP systems. We'll get the data, transactional database. And then we'll get the data from cloud as well. Yes, we may get data from cloud. We may get data from APIs. So we may get data from the file system. Okay, so file. From third party, we may get file or any other front-end applications. So we may get data from front-end applications also. So what kind of front-end system? Web service. So like software as a service, right? So we may get data from Salesforce or SAP or any other system we may get. So these are the different. So more than that, it's not only for other system also. I put only two. So previously, how we will extract the data from here? So we'll have something like ETL here. So we'll do ETL. So ETL process means extraction, transformation, and loading. So that way we will do it ETL process. So we extract the data and transform it and load the data here. So that way we will make it like only the business intelligence reporting. So here we will extract then so all this we'll do mostly like batch data initially. So nowadays it's not only batch data, we are going to get continuous data ingestion also, right? So structured, semi-structured, unstructured data also. So here we have the ETL tool. This ETL tool will extract the data and then it will load it here. It's not only Snowflake. So we may have previously, like if it is ETL, so what kind of databases we'll use? So if it is ETL, so here it's like we might have used something like, we might have used Teradata, right? Teradata previously. Netezza we have. So Netezza we have. And we might have used Oracle Exadata, right? So different system, Oracle database or SQL Server, different databases. So these databases, it can handle mostly like a structured data. So what kind of data it will handle? Mostly like structured data. So structured data means like data on the tables. So mostly on the tables, like we have the structured data. Yes, Teradata, Netezza, Oracle Exadata, SQL Server, all this will use structured data. So why we are using structured data? Because we need to do business intelligence reporting. So here we'll have structured data, right? So here we'll have structured data here. So we will take the structured data and then create business intelligence reporting here and we'll do it. So this process is called ETL process. So ETL means we are extracting the data and then transforming the data and loading here. So all the transformation logic, we will apply it here itself in this tool itself, ETL tool itself, right? So that transformation, okay, it may have different layers, but all the ETL we will do it here. So it may be like Informatica, so Informatica Power Center, Informatica Cloud, or SSIS. We might have used SSIS or ODI, Oracle Data Integrator. Similarly, lot of tools are there, Ab initio, lot of tools are there. So these tools are used as a ETL tool. But nowadays, so projects are moving towards on the cloud system as well, right? So cloud as well. So because they want to do not only business intelligence, so they want to go for artificial intelligence also, not only Snowflake. So they want to go for other platforms also. Okay, I want to do the Azure. I want to do the data on the AWS side, and I want to do the data on the GCP also. So data warehouse. So if you take Azure, so what is the data warehouse environment is there in Azure? So we have the Snaps Analytics. So we have the Snaps, right? So in Azure, we have the Snaps. In AWS, we have the Redshift. Okay, Redshift. In GCP, we have BigQuery. Okay, so these are the, it's a BigQuery. These are the cloud data warehouse service. If you take Azure, the cloud data warehouse service is called Snaps Analytics. And AWS, we have the Redshift. GCP, we have the BigQuery. So these are the different terminologies. Yes, definitely we'll use it. Okay, so I have this Snowflake here. I have this Azure. So any one platform, yes, definitely we can use it in our real-time project. And some project we will use all three also. If you take all four also will use. If you take Snowflake, yes, we are in Snowflake. So it's a Snowflake on top of any one of the platforms only. We will create a Snowflake account. I will tell you why Snowflake architecture while explaining, I'll tell you. But Snowflake separately we are using as the cloud data warehouse. We might be using some project, they might be using Snaps Analytics. Some project they might be using AWS Redshift. Some project they might be using GCP BigQuery. Even some project they are migrating from Redshift to Snowflake, BigQuery to Snowflake also. That migration also is going on. If you take Azure, in Azure we have, so one service is called blob storage, right? So blob storage, we have this one, or we'll say ADLS. So ADLS is nothing but Azure Data Lake Storage. So that we have. And blob storage we have. So that's a Gen 2 we will call it as. So that we have here. In AWS we have S3. Okay, that's a object storage. So I'll tell you what is the difference between the snaps and blob. And in GCP we have the GCS, Google Cloud Storage. So we have these three platforms like object storage. So we'll call it as object storage. In our Windows machine, how we are storing our files, we are creating a file, right? Folder. Inside the folder, we are just putting the folder and then we are putting the file. This is Windows. So if you take AWS or Azure or GCP, how can we store our file system? Okay, somebody third party is sending the file. Is there a place where we will put the file? Is there a place? So yes, we will put the file in SharePoint, right? Or some other place. That is our normal document. But how to put the data? So as a security purpose, security. So how can I put the data file? So that is called object storage. So we have in Azure, we have the blob storage or ADLS Gen 2. I'll explain that later while taking Azure session or AWS session introduction. AWS we have S3, simple storage services. In GCP we have GCS, Google Cloud Storage. These are the object storage. These are the cloud data warehouse. Warehouse meaning, so how we are querying this Oracle. Okay, just go to this Oracle database. Just we are querying right this way. Similarly, in the cloud, so we have the data warehouse environment. This is mostly we'll do it for OLTP system, Oracle. But on the this one target side, Azure or AWS or GCP, we can use Snaps Analytics or Redshift or BigQuery. Some project they'll use these systems instead of Snowflake also. They might be moving from these cloud data warehouse to Snowflake also because so this one because of the architecture of Snowflake, yes, it will perform very well. So they might be going for Databricks also. Yes, they may use Databricks. Snowflake and Databricks will work very similarly. So how we are creating the account, the Snowflake, similarly you can create account on Databricks. Snowflake also, we can create account on any one of the platform. Databricks also, we can create account on any one of the platforms only. Because Databricks, they do not have that the underlying platform, right? So they will use any one of the platforms and we'll create a framework. So that we'll learn one by one. So think about Snowflake now, right? So we have in the Snaps Analytics. Okay, initially companies they have used Snaps Analytics for the data warehouse. If they are using Microsoft product, yes, they will use okay here all the source system here we have, and then they will take ETL. Okay, so they'll not go for ETL. So nowadays we are going for the ELT here. ELT. So what is the meaning of ELT here? Because this is ETL. So now we are going for the ELT. So what is ELT? It's a extraction, loading, and then after loading it, do the transformation. So first to do the extraction, do extraction from the source system. So all the data, you just extract it from the source system and then do this just raw data. Do extract, don't do any transformation here. First you go and load all the raw data into the platform. It's like put it everything inside data, this warehouse. Like data, it's not data warehouse, we'll call it as data lake. So just to put it all the data as it is, whatever we have here. So that's put it here. For example, we are the data engineer. We need we need to create a business intelligence report. Yes, raw data somebody else has put it here, or we put it here. Just to take the data, do the business intelligence reporting on top of that. Do all the data transformation logic inside the Snowflake by using any other tool. So that is one thing, right? Similarly, other teams are working for data scientist team, right? Data science, they're working on it. So they want to do data science related one. Okay, they want to take the data, raw data. It's not only structured data. So we'll process three different kinds of data. So what kind of data will process it? Structured, semi-structured, right? All the structured data we'll do it. And then we'll do the structured data, meaning most likely the tables like we have. And then semi-structured data. Semi-structured meaning we have the JSON file, XML file, Avro file, Parquet file, different file system. And then unstructured data. So we have the data on the, like we have the log files, cookies, those files, and then audio file, video file, all these files. Mostly like the continuous data streaming, right? So we are getting the streaming here, streaming data, we'll get it. So these were the three kinds of data, different types of data. We are doing it on the this one. So this one we will call it as EDL, enterprise data. Sorry, this one will previously we used to call it as a enterprise data warehouse, EDW, right? So enterprise data warehouse. So we'll call it as enterprise data warehouse here. So nowadays we need to have the system for all other AI related project, right? So this one we need. So it's not only with this one, we need to, the companies wants to modernize their platform for the AI and ML related project. So then it's not only EDW. So then we are going for the EDL. So EDL is nothing but enterprise data lake. So enterprise data lake, just it's like a lake. It's a warehouse. Just we'll put it and then after that we'll perform business intelligence reporting alone. But here we are doing it enterprise data lake. So lake means we are just loading the data here, do all the data processing after that. So don't do any process here. So it's nothing but ELT process. So what is this process is called? ELT process. Extraction, load the data, do the transformation. Okay, so this one we will call it as schema on. So what is that? Schema on write. What is that schema on write? It's nothing but while we are loading the data into this data warehouse, we will create a schema. Schema means like a tables, structure, and everything. We will do that, the structure. Okay, for example, this is the structure, schema. We have the employee ID, first name, last name, email ID. This way, structured, transformed data. While writing itself, we will build it here. Then just business intelligence report, they will take it directly. But ELT process are called schema on read. It means whatever the data we have in the source system, just extract it and then load it here. Okay, you put it here, schema on read. It's nothing but just to put the data here, raw data. So mostly it's like a raw data. We will do all kind of raw data here. So do it all the raw data. Just load it here. Schema and read. Okay. This particular person, you want to do data transformation. Okay, you build a schema on that while reading it. Data scientist, they need the data. Okay, you build your own schema while reading the data, because my job is to take the data from here and then load it here, raw data. So after that, if you need to build some logic, okay, you want to train your model for supervised learning, unsupervised learning, large LLM models and everything, agentic AI, you have to build it. Everything, whatever the use case, you build it. You do all this. You create a schema on top of that while reading it. For example, this person wants to do business intelligence reporting. While creating the reporting, you build a schema. Okay, so okay, I need this data model. This is a star schema, Snowflake schema. I need dimension table, fact table, all this, right? Yes, we will do the schema while reading it. But here, as a ETL developer, I will build it. After that, if you want, you have to create a view only. So that we can have. So that's the advantage of ELT. So ELT means extraction, load the raw data. On top of that, you build the transformation logic. In Snowflake, how we will do the build transformation logic? Either we can use Snowflake SQL, or that is procedure, all this we can use, or we can go for the DBT. So data build tool. So that's what we will use it, or any other ETL tool. So that we will take it later. While explaining the Snowflake, I'll explain in detail about DBT also. Then we have one more concept here, lake house. So sometimes they'll say lake house. So what is that meaning of lake house? Okay. So lake house meaning, so now you are clear, right? What is data lake? So data lake can handle structured data, semi-structured data, unstructured data. So previously this ETL, we used to process only batch data. Batch data meaning, okay, so today is this 13th, right? Report I'm creating here. So up to when we will see the report? Mostly all the reports by yesterday, 12th, we can see the report, right? Still, some of the process are there. If you go to some reports you are taking, so all these are, you will see previous to one day before, whatever the data we have. Sometime they'll say it will take 24 hours to load it, right? It's nothing but everything's like a ETL process. It will take some time. But nowadays, everything like a ELT process. It's not like a 24 hours. Immediately it will be available. So that means they are directly connecting through API, and then they are bringing this, and then they are taking report from here itself. Every now and then, it's immediately it will be available, right? So how they are taking it? It's a real time live data. So previously it was batch data mostly, but nowadays we have both batch process as well as live data also. So live data also. Okay, so here we can have the batch processing as well as real time processing. So real time processing. Now, whatever the data, most of the systems nowadays, they are asking real time data only, right? Okay, so I want to know the result. Now 8:10, can I see report up to 8 o'clock today morning, whatever the business happened? They want to see it. And all the business user, this one, right? Okay, so I'm going to use YouTube. I'm doing a lot of searches, and then whatever the recommendation I'm going to see, it should be real time. So whatever I searched yesterday, so that should not recommend today, right? So whatever I'm searching today, so that should give the real time search here, right? So that we need to get real time all the user experience. So that we are going for the data ingestion. So we'll call it as a data ingestion, right? So it's a continuous data ingestion or it's a batch data ingestion. So both it can support. Okay, so continuously the data will be available on the social medias and everything. We will create some streaming engine here, and then that will continuously ingest the data to Snowflake or Databricks or Azure or any other environment. From there, we will take all kinds of report here. Okay, then what is lake house? So somebody will say like a lake house, right? It's nothing but a system can have both data warehouse and data lake concept. Okay, so that's what I need, something for my business intelligence. I need to have a data warehouse also and data lake also. It's nothing but lake house. So we'll call it as it's a lake house. It's nothing but we have the data lake and data warehouse. So that's what they have taken, lake house. Okay. So it's like a data lake plus data warehouse. It's nothing but lake house. So why they are calling it as a lake house? So because they want to build both data warehouse as well as data lake in the one system. So that's called a data lake house. So if you take Snowflake, Databricks, those are lake house, we'll call it as. So that will have all kinds of, still a lot of concepts are there, lake house. So it will build. So in Databricks, we have the Unity catalog, and it will do all the access and privileges here. So all this, that is different concept. Okay, I'm not going deeper on this as of now, but this is a lake house. It's nothing but we have both data warehousing and data lake in the same system. So that's called lake house. That's the architectural design. If you're going for architect, you have to think all this architectural design. You have to build as an architect, you have to build, okay, how are we going to connect with these heterogeneous source system? We will call it as heterogeneous source system, right? Heterogeneous. So heterogeneous means sources. So we may get data from like different sources, like you will have the RDBMS, cloud APIs, and file system. Third party, you might be connecting through APIs, and you'll be connecting it file system, software as a service, everything you are going to do. So that's a heterogeneous source system here. So you may have batch data, near real-time data, so that we have to take it and we have to build it here. It's for A and ML related project and business intelligence. This is what the role. So data engineer, data analyst, developer, ETL developer, all this. So this is the complete architecture. So what we have, right? And then, okay, in Azure or AWS or GCP, we have, okay, so you may ask question, already we have data warehousing on this Snaps analytics here in Azure. Redshift here we have AWS, BigQuery we have in GCP. Then what is the advantage of using Snowflake and Databricks? So that's what we will see in our Snowflake architecture. So how it differs from other systems. So that we will see in detail. So these are the basic architectural overview of our the modern cloud platform. Okay. So I got few questions. So let me take one by one questions as well. And how can we do the transform in ELT? Yeah. So how we are going to do the transform? So because so you load the data here on the Snowflake. First you put the data. As I'm a data engineer, I'm going to give the data for my business intelligence reporting team. Then I will build a data transformation by using Snowflake SQL queries, notebook. You can use it. And that's what our task. Or you use some ETL tool. You bring the data raw layer and do it on top of that, use DBT here. DBT is for data transformation framework, right? So that way it will do. So we will do that in detail. We will see that you will get clear idea. So if it is ETL, then EDW. If it is ELT, mostly EDL. Exactly, right? So here nowadays all the architecture we are going for the ELT. Okay, so you just load the data because as soon as data is available, you bring it to Snowflake here. Okay, so then only I can build a near real-time report here. I can build a near real-time report in the AI model also, LLM model also, I can do that. So it means as soon as data is available on the source system, that I have to bring it here. So that's what we'll go for ELT. Just to bring it data, continuously ingest the data to Snowflake or Databricks or any other cloud platform, do the transformation logic. Mostly that's what we will do. So is streaming data can handle in Snowflake? Yes, we can handle it in Snowflake. So that we can do it. Okay, so because source system, we are going to use Kafka or Azure also we have the streaming engines, right? So that we can do it. And ETL, which tool are you using? Explain this ETL Informatica. Yeah, we have one session for Informatica. So that as well, I will explain it, okay, in the session so that you will get a complete idea. So how to connect this ETL process as well as ELT process. And ELT process, we'll use Snowpipe here. So that and all we'll see, take this one. So Delta Lake. So Delta Lake is different concept. So how are we going to use the architectural here? So that's on the Unity catalog and how we are going to use that as a transaction, right? So we'll call it as a transaction. Maybe I will explain it in our next session. So you will get clear idea here. Okay, so Delta Lake. So that is on the Snowflake and Databricks we have. That's a concept we have. So any particular reasons why they are using data warehouse and data lake so differently while loading the ELT process. So what is the difference of data lake and data warehouse? So main difference of data warehouse and data lake, A data warehouse can handle only structured data, mainly focused on the business intelligence reporting. But nowadays, data lake or lake house, we need to do for all both A and ML process as well as BI process, right? So just to bring the data here and then do the transformation logic. So that's what we'll go for lake house. If you want to build both data lake and data warehouse on the same system, so then we will call it as a lake house. So that's what we'll go for lake house here. So if you want to do any asset transactions, so how are we going to control it? So that's what the delta lake we'll call it as on top of this data lake house. So we'll call it as delta lake. So why we use Databricks and Azure Snaps both? Yeah, so Azure Snaps is for only for data cloud data warehouse, right? So it can handle, for example, Teradata, Netezza, whatever we are using. So that's what it will use it here. But Databricks is like a unified platform where it's a more advanced platform. And if you want to use it for our ML and AI related loads, workloads, and BI loads, then you want to build a transformation logic, everything, you want to schedule it. So everything it can handle it, the Databricks. So that's what the companies they are moving towards on the Databricks. So instead of using Snaps, because Snaps will do only the data storage, right? But so here Databricks, it will store the data inside the ADLS path or somewhere, right? But still it can handle the workloads very quickly. The performance is very high. So that's why they want to, even companies are moving towards on the Databricks or Snowflake. So whatever we have the Databricks that we are doing it. So Kafka involves the microservices to streaming the data to into the pipeline. And so yeah, that's what. See, Kafka is one of the source system for Snowflake. Okay, so how we are going to connect Snowpipe. So Kafka or any other Microsoft, we have some different uh, streaming engines, right? As this streaming engine, we have any other streaming engine. So that we are going to connect with our cloud platforms. So that will extract the data. Snowpipe will continuously ingest the data to Snowflake. So we will see that one by one later so that you will get clear idea about all these concepts. Okay. And I think I have answered all your questions. And then, so can we have our designation as data scientist? So if you want to go with the data scientist, you have to concentrate more on the LLM, like large learning models. So that you have to concentrate agentic AI. You have to build it on top of the Snowflake raw data. So in the ELT pipeline, at what point do we usually use PySpark for heavy transformation in terms of Snowflake? See, Snowflake using the PySpark on the Snowpark side, AI related project. So if you are going to work on the AI related project, okay, you want to build for this particular company, Gen AI, Agentic AI, these models you want to create it. So then you will be using that PySpark here. Okay, Python code. You'll be using it in the notebook. If you are going to use it for business intelligence, then mostly like SQL, 90% of SQL, then automating. Okay, I want to put automation, right? I have created extract. That extract is nothing but .csv file or data file. So that I have to upload it into user SFTP path, or I have to zip it, or I have to archive it some folder. So those kind of automation you can write it in PySpark, the Python code. So that is applicable here. So that's what normally we'll use different way. PySpark. So here it is called Snowpark. Okay, Snowpark is nothing but Snowflake that we are going to use Spark. So that is called Snowpark. So that is later we will see that. Okay, so I have total 8 years of experience. If I complete this course interview, how many relevant experience you can put in the Snowflake, right? So Snowflake, you can put 3.5 years to 4 years. So that you can show. So both data engineer role or data architect role. So if you are more than 8 years or this one role, so definitely you can go for this kind of role. Okay, architect role. So that way you can put it. Hello everyone, welcome to Nikkite Academy. In this video, we will see how to create 120 days Snowflake trial account. Snowflake offers a 120-day trial account for learning purposes. To create this account, we need one personal email ID and no payment information is required. So normally if you go to this particular page, we will get 30 days trial account, but we will see how to create 120 days trial account. In this particular link, you can add trial equal to student, then enter. So I have given this link in the description. You can make use of it, and you can see this. Start your 120-day free trial account. Snowflake is giving us this particular account for learning purpose, and it's the same $400 worth of resource usage. Just fill the form. So I'll put first name, last name. For work email, so we can give personal email, and this one we can go for learning purpose. This particular option we can select personal learning and development. Just click on continue. Company name, you can provide the company name, and the job title. So you can give a job title here. I'm giving a job title as data engineer. So here we have to select editions. So we can select enterprise edition, which has 90-day time travel. No need to change the Snowflake edition. And we know already on top of any one of the cloud providers, we can create Snowflake account. So just I'm creating Snowflake account on AWS, and we can keep it. So whatever the regions nearer to our location, we can keep it, and you can select this terms and conditions, click on get started. So we will get this particular page. You can just skip it, and we should have received an email to activate this account. I will copy this email username. I'll go to this email. I will check that yes, we got the email. Go to this activate Snowflake account. So this is the link. Okay, so once activated, we can use this particular link, and this is the account. Click to activate, and we have to provide the username just to give the email user itself, and we have to choose the password. So the password should be 14 to 256 characters, and these are the conditions. I have entered the password and confirm password. Click on get started. So welcome to Snowflake. This is the page we'll get it, and skip for now. You can click on skip for now, and this is the page we got. So 400 worth of credits left out. You can make use of this account for different purpose for next 4 months. You can go to the worksheet, you can create new worksheet and start using the Snowflake. If you are looking for Snowflake tutorial, you can stay connected on my YouTube channel. If you haven't subscribed the channel, please subscribe it and click on the bell icon so that you will get all the notification. If you are looking for a complete Snowflake online training, then you can contact me on this number, which is available in the description. Thank you. We will meet in another interesting video on Snowflake. Hello everyone, very good morning and good evening to all. So let us start our today's session. So last week we just started what is Snowflake, so what is ETL and what is data warehouse and data lake and everything. So today we'll start with the Snowflake introduction. So what is Snowflake? So why they have given the name as Snowflake, and what is the architecture of Snowflake, and how it is differs from. So who are all the competitors for the Snowflake? We'll see one by one. So this is the agenda for today's session. So what is the name behind the Snowflake? We'll see that. So what is Snowflake? Snowflake architecture. So if you are planning for Snowpro core certification and all the architecture and everything, you have to learn it. Okay, Snowflake architecture and warehouse sizes and different Snowflake objects. So what are the different objects are available? And tomorrow we'll see the trial account one by one. Okay. So these are the agenda for today's session. And so what is the name behind the Snowflake, right? So who has created the Snowflake? Before that, so what are the different cloud providers are available in the market, right? So if you take in the market, so we have the different 3 major cloud platforms. So one is AWS, Amazon Web Services. Second one is GCP, that is Google Cloud Platform from Google. And then from Microsoft, we have the Azure platform, right? So these are the 3 different cloud platforms are available. So if you take AWS, we have 100 plus services. Okay, I need storage. Yes, we have the storage service. If I need data warehouse, I have the data warehouse service. I need a database, I have the database service. Or networking, A and ML workloads. So everything we have different services are available here, 100 plus services. Similarly, GCP also 100 plus services are available. In Azure also we have different services, 100 plus services are available. Mostly whatever we have in Azure, everything will be there in GCP, and everything will be there in AWS also. But so what are the different data warehousing platforms are available in these three different cloud platforms? So if you take AWS, we have Redshift. Redshift is the cloud data warehouse. So initially they have used Redshift as both computing and the storage, both coupled one. So now since we have the Snowflake and Databricks architecture, so Redshift also they're coming with decoupled architecture. So what is a decoupled architecture? I will explain one by one. So AWS, we have Redshift. GCP, we have the BigQuery. So it's a data warehouse environment. In these cloud platforms, we have the cloud data warehousing. If you are from ETL background, Power Center or SSIS or ODI or any other background, you might have worked on this. Any Teradata, Netezza, these Oracle Exadata, these kind of platforms, right? But here we have the cloud data warehouse. Azure, Snaps Analytics. Okay, so initially we had these platforms only. Companies started using these platforms for our data warehousing. After that, we need the data lake. Yes, we have to store the data. For that, they have used different services. Okay, if you take AWS, we have S3. So S3 is like object storage. So if I want to store as a file, okay, so I can use AWS S3, simple storage service. In GCP, we have the Google Cloud Storage, GCS. We have in Azure, we have the blob storage, or we will call it as ADLS Gen 2. So ADLS is nothing but Azure Data Lake Storage Services. So we have the generation 2. So that's what we have. So these three platforms we have, and companies started using it. But after that, so Snowflake came into picture in the year of 2012. They started 2012. Snowflake came into picture the year of 2012. Okay, so please remember 2012 they started. So after that they come up with some big IPO. Okay, in US. So initial public offer, they put it into the stock market. They got a lot of money in 2020. During 2020 only they made a big IPO and then they started completely commercial. So these these three platforms are cloud data warehouse environment. Okay, cloud data warehouse environment. Our company has started with cloud data warehouse environment. After that, we have the Snowflake, then we have the Apache, we have the Azure Databricks, right? Not only Azure Databricks, we have Databricks. So how they Databricks they have started? The founder of Apache Spark, they started on top of Apache Spark. So they started one unified platform. So that's becomes the Databricks. So, but Databricks also, they need some platform to work on because they need to store the data and everything. So majorly, if you take Databricks and Snowflake, any one of the cloud platforms on top of any one of the cloud platforms, they will create the data warehousing. Okay, so that's what we are going to see now. So these three platforms are data warehousing platforms are available in the market. Okay, how it differs with Snowflake and so what is the comparison between Snowflake and AWS and all this we'll see one by one. So, but why they have the founder of Snowflake? So why they have given the name as Snowflake, right? So if you take the snow, so they want to name it something on the cloud. Okay, so they want to give some name for cloud. Okay, they were thinking, so what name we can give? Okay, then that time snow was there, and then if you take snow, so the tiny particle is like a snowflake. So this is a snowflake here. Normally, this is what we'll call it a snowflake, right? So each tiny particle of snow is a snowflake. So if you take snowflake logo, initially they started with this one. Then after that, they changed to this one. This is very similar to the snowflake. They want to give name like a cloud. So because these are the cloud platforms, right? So they are getting into cloud. And then they started, okay, snowflakes are born in the cloud. Okay, snow is coming from the cloud. Then they started, okay, born in the cloud. And they love snow very much. And then they want to give some name for the platform. Then they have given Snowflake. So each Snowflake is unique, right? Each Snowflake is unique. Separately in Snowflake, so we can have n number of virtual warehouses. So like unique warehouses we can create. So that's why they started giving the name Snowflake. So from that, they named it. The co-founder of Snowflake, the Marcin, he has created one blog. So there he has written. So why he has given the name as Snowflake. This is what he explained. Okay, so we should know that. But if you ask me what is Snowflake, Snowflake is a fully managed cloud data warehouse. So if you ask me what is fully managed, right? So I know managed cloud data warehouse. But what is fully managed cloud data warehouse? If you take Oracle or SQL Server or Teradata or Netezza, these platforms, if I want to maintain my data warehouse initially, I have to contact Teradata or Netezza or Oracle. This way, right? Oracle or Microsoft, we have to SQL Server. These companies I have to contact first. Then they'll give the quotation. Okay, so what is the need and everything? They'll give the quotation. After that, they will get everything and then they will install the server. So they will take physical server and then they will install it. And that particular server maintenance, the company has to do. For example, if you take one client company, some banking or insurance or any company, right? So that particular company has to maintain the server. So maintaining means, okay, data, disk, everything they have to maintain, right? Space, disk space, networking, security, and then patching. So every month, Microsoft, okay, if it is Windows OS, Microsoft will release the patching, right? The version. If it is Linux or any other OS, they will release a OS patching for security purpose to avoid any vulnerability. They will release a new software versions, right? So we have to patch it. So that everything we have to handle it, right? So who will handle it? Upgradation, maintenance, and everything. Okay, today one version is there, Oracle 21C. Later point of time, Oracle 23C is coming up. So who will upgrade it? So that's a cost to company. So company will put some money. They'll go for upgradation, right? So initially we had Informatica mic upgradation, some server upgradation, or they'll go for Teradata. Okay, 15 to 16, 14 to 16. So that way they'll go for upgradation, right? But nowadays on the cloud, we are not going to maintain. Okay, so tomorrow I need some server. So I can create one account in the Snowflake. We can start using it. Who will manage it? So everything managed by Snowflake company. Okay, upgradation, maintenance, security, right? Secure data sharing, and then encryption, decryption, everything. Okay, so how they will compress the data, disk management, networking, security, firewall, everything they will maintain it. So that's why Snowflake, they'll call it as fully managed. Fully managed. Who will manage? Snowflake Corporation. We are not going to manage it. Everything they will manage it. We are going to make use of that. So fully managed cloud data warehouse. It's not only nowadays, it's a warehouse. They renamed this name instead of cloud data warehouse. Snowflake, they have given name as data AI cloud. So data AI cloud. So that can store and analyze all your organizational data in one place, provided as a software as a service, SaaS system. Okay. So one single place we need one particular system should withstand all the database queries. Okay. So some people will query for PI related workforce, right? Workloads. Some people will query for AI related workloads. They will query it. Okay. So they different people will differently query that. So that particular database should withstand. Nowadays, if you take OpenAI and everything, right? So how much query we are just giving that it is generating. Similarly, this Snowflake also should withstand all the queries, right? So all the organizational queries it has to withstand. So that's why it's a one single place. Okay, if you take Oracle or SQL Server and all, it will not take that much the performance, right? So performance, if you go and fetch it, select star from database name or the table name. And then if you put one where clause, then the query will run for longer time. Sometimes it will get stuck, right? So you cannot proceed anything. But if you take Snowflake or Databricks and everything, even if you put select star from the table name where some ID equal to each ID you are using, it will find out data quickly, but it will take some computational power. And even if you use some date, then if you are using it, querying it, it will give you the result. So that's what it will withstand that power. A lot of people nowadays started using BA related workloads, AI related workloads. So that database should withstand these queries, right? So that's why companies moving towards on the Snowflake. Okay, Snowflake mostly focus on SQL related one. Okay, if you ask me on top of which one, okay, on top of which platform, okay, if you take Databricks, Databricks has been created on top of Apache Spark, but Snowflake has been created so with on top of these platforms with SQL only. Okay, so mostly like SQL. We'll see that architecture. Then why we are calling it as software as a service? Because I need something tomorrow. They created a framework. They just created a framework, that software. It will manage the data and we can make use of that. That's it. Software as a service they are providing. For that, we have to pay for that. So we will call it a self-managed service. A self-managed service means, so whatever the three different layers we have in Snowflake, everything is like a self-managed. It will automatically manage scale up or scale down. So I need just one simple table, select start from the table name. So I can just query it. I can go for very small queries and then I can run it. Scale up or scale down. It's based on the compute resource load interface. How much data you are analyzing it, it will automatically scale up. So we can go for two different way. One is serverless and another one is the virtual machine. Okay, virtual warehouse based. So what is that? We'll see one by one. Okay. Snowflake is built on top of any one of the cloud platforms, any one of these cloud platforms. So why? Why? Because Snowflake, they created a framework, so like a software as a service. So they created on top of these platforms only. So whatever the resources we are going to use it, they will take from here only. Okay, so either from AWS on top of AWS, or we can create Snowflake on Microsoft Azure on GCP. Okay, so that's the architecture. We'll see that. So what is architecture and everything? And there is no hardware or software to select. We are not going to use any hardware or software. We are not going to install it. Everything's on the cloud. So we'll just take only web UI based one. So no need to install it, no need to configure it, no need to manage it. It's ideal for organization that don't want to dedicate resource for setup, maintenance and support. Everything Snowflake will take care. We are not going to take care. Okay, what is this AWS and everything? That we'll see one by one, right? So as I have already mentioned, there is no hardware needed to install it from our side. Everything Snowflake will take care. There is no software for you to install, configure and manage. It's a fully managed. Fully managed means all the maintenance, management, tuning, optimization, everything will be taken care by Snowflake. It's a self-managed services. We'll call it a self-managed services. Okay, so what is SaaS? Normally, if you take SaaS, right? So if you ask me what is SaaS, I'll go for this example. Okay. So there are different way of using the cars, right? Car. So I can own my car. So one thing is I can own my car. If I want to own my car, so what I will do? So I have to buy a car. I have to pay finance. Then it will go for a depreciation value. Okay. So today, if I'm purchasing for 10 lakhs or 5 lakhs, then tomorrow it will go for depreciation. So definitely resale value will go down. Servicing, insurance, right? Tax, and if any repair, parking, and everything I have to take care, right? So driver. Okay, if I'm driving or somebody else is driving, maintenance, fuel. So fuel is very important, right? If I'm going to own everything, I have to take care. Similarly, for server, if you have the company, you want to have database server, your data warehouse, then you have to own it everything. So you have to pay for that, right? So even if you are paying that, you have to take care of everything. Okay, so if anything goes wrong, you have to take care. So today you have purchased one car, basic model. Then tomorrow you want to upgrade it. So you have to sell it and then you have to go for new one, right? So upgradation based on your, okay, four-seater or five-seater you have purchased initially. So after that you have to go for seven-seater. Then you have to go for upgradation. You have to purchase new one. This one you have to sell it, right? You have to sell it and then you have to purchase it. So in that case, yes, we have some money, right? So we are spending some money. Depreciation is there, everything. Okay, instead of that, you can go for car lease. So in the car lease, no need to have a car, right? No need to have a car, and everything they will, whoever is a service provider, they will maintain it. Car, finance, depreciation, resale value, everything they will do it. I will take for car lease, I will use it, right? But I have to pay for this. Okay, so driver, fuel, and everything I have to pay for that lease. Okay, 1 month I'm taking that lease, right? So this way, car rental, I can take it for rental. So this is also, I have to somehow I have to use it. I don't want everything. Okay, this one car share or city car. No, I'll go for this one, Ola or Uber, this kind of taxi service. So what Ola, Uber will do? Normally you think whether Ola and Uber will manage any hardware, Ola, Uber? No, right? So what they have done, they just developed a software. They just developed a software. They integrated drivers. They integrated the passengers, right? Customer. Okay, so Ola will not have anything. Only they will pay money for softwares. That's it. Software, they have to go for that. Everything they need to put, A and ML, everything they have to do. All the software upgradation, very high level of software they need to use because lot of based on the demand, it has to fix the amount, everything, right? It has to allocate the drivers, everything it has to take care. That software only they are paying. But who is owning that hardware, that car? So car is owned by car driver, right? Everything they will take care. Okay, if any traffic violation or fuel or parking, right? So everything they will take care. And passenger, what they will do? Okay, I need to book a cab, so I can book it. Tomorrow I need for seven-seater. Today I need only five-seater. I can book it. But what this Ola and Uber will do? They will just take that car. They will assign it, right? The car also from where they are assigning from the car these drivers. That's it. They are not going to do anything. So they will not take any accountability, right? So that's they will give okay. So insurance also they will put on the drivers and everything they have to do. They will give some commissions. So based on the commission they'll take. If they are integrating the same model, Snowflake also. Snowflake, so whatever the framework, the software as a service they created, they will take all the resources from these three platforms only, either from AWS or Azure or GCP, these platforms. And whatever the customer is asking, okay, so I will give you this service. Okay, so I need for data warehousing. This is what my requirement. Then, okay, you take it and you pay for that. Okay, you need five-seater, this is the amount. You need seven-seater, this is the amount. Premium cars, this is the amount, right? Similarly, here also, based on the virtual warehouse and based on the computing storage, everything they will ask us to pay. That's it. So this is what Snowflake they created. Similarly, if you take one more example where we are going for the accommodation, right? So I want to, for example, I'm traveling one country to another country. So I want to have initial days, just 1 month. I want to have my accommodation. Whether I'm going to own my house there, no, right? Or I'm going to take lease, no. Initially, they will not. No one will give the lease, so you have to be there for some time. You have to build all the credit card and everything, the creditability, everything you have to do. Then you will go for rental home. Also, initially they will not give, so you have to go for some hotel stay or can go for this Airbnb, something like booking.com or Airbnb. So what Airbnb, how the business model, whether they are going to have this Airbnb or this booking.com, everything they are going to have any hardware that is any infrastructure, any home, no, right? So what they will do, okay, I want to book a home, then that Airbnb, they'll, okay, list down all this availability, then we will be booking it. They will take some commission, then they will allocate the house, right? So that's it. This is the model. Similarly, this is something like a software as a service. So they have built a software and then they are giving the service, right? Similarly, they will not own anything. Similarly, here also Snowflake also the same way. So if you take Snowflake architecture, this is the Snowflake architecture. Three different layers are available. Okay, so if you take architecture of Snowflake, three different layers are available. One is storage layer, another one is query processing layer, another one is cloud services layer. So what are those three layers? So let me explain it so that you will get clear idea, and then we'll take all the questions. Okay. So I will take three different layers. So so we have, if you take, so three different layers. So from a Snowflake, you take that. So okay, if you take, this is the Snowflake here, and three different layers are available. So what are the three different layers? This is complete Snowflake. You can take. Okay, so this is complete Snowflake architecture. Three different layers. So please remember, this is the basic of Snowflake. So every time if you're going for any interview, you need to have this one in your mind. So what is the first layer? So first layer is, it has to store some data. So where it will store? It's nothing but storage layer, right? So whatever we are taking, that data it has to store somewhere. That is the storage layer. This is storage layer. I will tell you. So what is the storage layer? This is called storage layer. Then what is that next layer? Is called query processing layer. Query processing layer. And then the third one is cloud services. Cloud service layer. So there are three different layers are available. So what are three different layers? Storage layer, query processing layer, and then cloud service layer. Okay. So if you take this cloud services layer, we will call it as, this is the brain of Snowflake. Okay. So brain of Snowflake, it's a top. So top you can remember as brain. And then query processing layer, it's a muscle. Okay. Muscle of the body. And then this one, this is memory, or you can say it's a heart of the system, or you can say it's a memory. Okay. Memory of the, the system. So cloud services, query processing, and storage. Okay. So how the Snowflake has created? So how on top of any one of the platforms. So what is the platforms? We have three different platforms are available. What are those three different platforms? One is on top of AWS. So on top of AWS, we can create Snowflake account, or any one of the platforms only. Any one of the platforms. So while creating Snowflake, we have to, as a customer, as a company, we have to select it. Okay, one. Second one, either we can go for AWS, or we can go for another one is called Azure. Okay, on top of Azure we can create, or we can go for one more platform. So we can go for, next platform is called GCP, Google Cloud Platform. So three different layers. So what are those three different layers? So one is AWS, another one is Azure, and this one. So why we are creating? If you ask me, why we are creating on top of this? Okay, if you take AWS S3, right? Simple storage service. So what is S3? So how we are storing here data in our machine, Windows machine? We are storing like folders. First we are creating a folder. Inside folder, even we can create a folder, or we can put the file. Similarly, in AWS environment, if you want to store data as a file, you can store it in the S3. It's a simple storage service. the storage service. So you can do all this data lake service. We can call it as storage. So where we'll store all the data. It's a storage service. And then here we have Azure, right? So if you take Microsoft Azure, we have the blob storage. So we'll call it as blob storage, or we'll call it as ADLS Gen 2. So now we have the ADLS Gen 2. Nowadays we have ADLS. So ADLS is nothing but Azure Data Lake Service Gen 2. We'll call it as generation 2. This is ADLS Gen 2. Next one is, so we have GCP. In GCP, so what is that service? Google Cloud Platform. This is called GCS, Google Cloud Storage Service. There are 3 different services. Okay, on top of any one of the platforms only, I can create Snowflake. So please remember, while creating Snowflake, it will ask you to select, okay, which platform you want. So how we will select? So based on AWS or Azure or GCP, based on my requirement, based on my regions, okay, if I'm in Canada or if I'm in USA or if I'm in my company is in India, so whichever is location nearer to me and what is the cost. So cost will vary that regions based on the region and based on the platform. Region means we are in India, then Asia Pacific region. If you are in USA, North America region. So if you are in Canada, North America, right? And then we have some Europe region, something like based on the regions and based on the platform. Platform is AWS, Azure, or GCP. The cost will vary. Maybe tomorrow or day after tomorrow, we'll see in detail about the cost management or how it will vary and why we are selecting either AWS, Azure, or GCP. Okay. So in my previous organization, they had created 2 different accounts. One is AWS account and AWS CA, Canada account, and Azure CA. So we'll call it as it's Azure CA is nothing but ASCA regions. ASCA means A is at CA. They will call it as ASCA region. Another one is AWS CA, that regions. They created a POC and then some workloads they created account on AWS, some workload they created on Azure, and then after that they compared. Okay, so today if I have created on one platform, for example, today I created one platform, AWS as AWS I created, then later I cannot change it. If you want to change it, that's a migration. You have to do account migration. If I have chosen that Azure, then later, okay, you started loading all the data and everything. After that, I cannot choose it to a different platform. GCP, I cannot choose it. So based on your need, do some analysis. Like that's what the Snowflake architect will do. Okay, which platform I can go for? So what is the cost it will take and everything you have to do. So storage layer, then query processing layer and everything. Storage layer, how Snowflake will store the data as a file. Okay. So whatever, for example, if I'm going to do select star from the table name, right? So if you take select star from the table name, some table, if I'm taking customer table. So how Snowflake will store this customer data? Snowflake will store this customer data internally. It will store as a file only. Okay, how they are storing, how they are managing it, and that uh, the architecture they will not show us because it's a completely security purpose. They will not show. They will not reveal it. Complaints due to complaint issue, they will not reveal it. But how they will store? As a file system. So please remember, as a file only they will store. So how we are storing here. But what way? Micro partition file. Okay, micro partition file. So if I'm going to send some data, so that they will put it inside AWS S3 or Azure ADLS or GCP GCS, whatever we have selected already. Okay, for example, I I have chosen that AWS S3. So then whatever I'm going to store the data, Snowflake will store internally AWS S3 only. Internally, they will manage it. Okay, so how they are managing that they will not give us information. They will manage it, but we have to pay for that. Okay, if I'm going to use the service, I have to pay for that, right? So they will manage it. Whatever the data I need, I can query it, and then based on that, I'll do. This is storage layer. So storage layer, they will store the data. Okay, on top of that query processing. It means, for example, if I'm going to run select star from the table name, query processing layer only, it will process the data. Okay, so I want to do, it will fetch the data from here. It will show you. I'm doing some insert operation, any DML operations, right? So this query processing only it will do. So it is called a cluster. Okay, so normally we'll call it as in Databricks and all, we will call it as cluster, but in Snowflake it is called virtual warehouse. Okay, so what is it? It's a virtual warehouse. So please remember, so here in Snowflake it is called virtual warehouse. Sometimes we'll call it as a cluster also. So this is, we'll call it as virtual warehouse, right? So this way also we can put virtual warehouse. Okay, so or sometimes we'll call it as cluster computing. Okay, so compute, we'll call it as compute. Sometimes we'll say it's a cluster. So normally if I'm going to do any database, if I'm going to run it, select star from the table name, yes, it will run, and then that we'll call it as a compute, right? So computing backend, it will process the data, it will bring the data. So how it will do all this, we'll see one by one later, but this is what. So this is the brain of the system, right? Snowflake. So what is the brain? Cloud service layer. So cloud services. So what it will do, it's like authentication, security, like infrastructure management, everything this will take care. Okay, so we'll see in detail, but I hope you are clear about these three layers. So what are the three different layers? We have storage layer, query processing layer, and cloud service layer. Storage layer is called memory of the system or heart of the system, and query processing layer, we'll call it as virtual warehouse. So wherever you are seeing the virtual warehouse, it's a virtual warehouse only. It's responsible to fetch the data, to store the data. So compute, it will work. And then it's a muscle of the system. And then this is the brain. Okay, it will take care all the authentication and everything, infrastructure, everything it will take. So you'll see in detail, one by one. So what is the use of this one? They will ask in interview these questions. Okay, so what is this? Oh, so in company, who will create this the Snowflake, right? So as a Snowflake admin and Snowflake architect team, they will be doing some POCs. Okay, they will create one account on AWS AWS account, one account on Azure, or one account on GCP. So whichever is applicable nearer to them, they will create it. For example, I want to do sign up. If you go to the Snowflake trial account, I want to create Snowflake trial account. Okay, so let me go to the Snowflake trial account. I will show you. Okay, first name I'm just filling it. Last name I will fill it. Just I'll put that first name, last name. Okay, we are not going to create. Just I want to show you that. So how it is. So what is that different layer? Okay, so why are you signing up? Okay, I want to learn for my personal learning and development. Just to do it. And if you want to opt out, go for it. And what is the country they're asking? So which country? So based on the IP address, they will deduct, and then they'll put the country by default. So these are the countries are available. Okay, Snowflake. Then just to take it, continue. So company name. Okay, you can put your company name here. So all this you can put. So after making the company name, okay, job title, ETL developer or data engineer, everything you can put, anything you can put. Okay, so data engineer, just I'm making that, and choose your Snowflake edition. Okay, so different editions are there. We will see that all the editions, four different editions. Okay, so there are four different editions, not three. So one is standard edition, another one is enterprise, business critical, and VPS, virtual private Snowflake. So that we'll see that later. So by default is the enterprise edition. Then it is asking choose your cloud provider, right? Snowflake runs on top of cloud platform you are already working with. Either I can select Microsoft Azure, or I can select AWS, I can select GCP. Okay, for example, if I'm selecting Microsoft here, Azure, Azure account. Okay, so for my location, which one Azure account is nearer? Canada Central, Toronto we have, and similarly we have some different. Okay, so if I'm selecting Azure, these are the account. In Asia Pacific, so what is the account we have? So we'll have it here. Singapore we have nearer, and Pune we have, right? So this is a Central India, we have Pune location. So they will they will add it based on that, they will add it here. And I'm selecting AWS. Okay, AWS means different layer, different regions. It's not Pune. You can see we have Asia Pacific, so different layers. Singapore we have, Mumbai we have different regions, because in Mumbai AWS data center is there. In Pune we have Microsoft data center. Similarly, if I'm going to take GCP, so GCP only these locations. Okay, only these locations we have, and we can take nearer to our location, and based on our cost we can take it this one. So this is what you have to select on top of any one of the platforms, we can select it. So this way. So what are the three different layers we have? Storage layer. So what is the use of storage layer, if you ask me? So let me explain in detail about the storage layer. We'll see that. So we have three different layers, right? So whatever we have seen, three different layers we have seen. So three different layers we have seen. Okay, so one is like different layers we have, right? So we have the different layers we have. I'll take this one. So what are the three different layers? Storage layer, compute layer, and query. This is the query processing, that is compute. Another one is cloud service layer. Okay, storage layer here. So what is the use of storage layer? This is the storage, right? You take this one. This is the storage layer. So please remember, so this is the basic of all this, of all our Snowflake learning. Storage layer, compute layer, or query processing layer. Query processing, we can say it's a query processing layer, or we can say it's a compute layer. So anything is fine. Compute and query processing, same only. Compute. Call it as it's a compute only. And we can go for next layer. So what is the layer? Cloud services layer. Okay, cloud services. So what is the use of cloud services? So if you ask me, so cloud service, it will take for this way. Okay, I'll put this one. So first of all, it will make authentication. Okay, any user comes. Okay, we want to first we want to log in to Snowflake. So who will authenticate? This cloud services will authenticate. So authentication and access control. Access control. So based on the role, we'll get it. So here we'll call it as RBAC. So RBAC means role-based access control. So that we will take care in the cloud services. So cloud service layer will take this one. And then infrastructure management, all the infrastructure management. Okay. Infrastructure management and metadata management. So what is that metadata management? We'll see that. Metadata management. So metadata management. Okay. So this way it will take care. Okay. Authentication. Then so SQL query parsing. So whenever I'm running a query, right? If I'm going to run select star from the table name, so it will parse it. Parse it means it will read and it will make the explain plan, that execution plan, right? So it will make this query execution. We'll call it as it's a parsing and then optimization. Optimization. It will make optimization, query parsing and optimization. Okay. And then I'll go for data sharing. Okay. So whatever, for example, you want to share data out of your organization or inside the organization, some other department, you can do all data sharing. So who will take care about all this? Cloud services will take care. Okay. For example, if I am the user, I want to log into the Snowflake. First of all, who will authenticate? This will authenticate. Cloud service will authenticate. Okay. Metadata management. Metadata management means where the data has been stored. Okay. So if I want to select star from transaction table. Transaction table, it's a very big table, right? Where the data has been stored. So it will put all the metadata information. Okay. So if I want to run the same query second time, it will cache it. Okay. It will go and take the same data. It will cache it for 24 hours. Next time, if I'm going to, if without changing any query, if you are running the same query again, if the data is not changed in the underlying database, then it will take the same data. So that is the metadata management. It will make query optimization. So by default, it will do optimization and everything and parsing. That is nothing but the plan. Okay, execution plan. It will make the execution plan. Everything this will take care. Okay. The second one, this is the cloud service layer, first one. Second one, I'm going with query processing, right? So whatever I want to process the data, so this is the query processing layer it will take. So what is the query processing will do? So here I'm taking query process. It's a computing, okay? So query processing means it's a computing. Computing means if I'm going to do aggregation, select star from, insert into, delete, truncate, everything. So whatever we are doing, so everything it will do. If I want to do DML operation, DRL operation, all this it will be taken care by this query processing layer only, compute layer only. It's nothing but cluster. In Databricks, we will call it as a cluster, right? So here it is called query processing layer or compute layer. Virtual warehouse, we will call it as, it's a virtual warehouse. So please remember, this is called virtual warehouse. Wherever we are seeing that virtual warehouse, it's a computing. Okay, we can create some different virtual warehouse. We'll see that. And then I want to do the data loading. I have some data in the file. I have to load it into the Snowflake. So I can create a snow pipe or directly we can load the data. Data loading and data unloading. So please remember, data loading means we are loading the data inside Snowflake. Data unloading means we are fetching the data as a file to outside of Snowflake. So that's a data unloading process. If you go to real-time project, there we will call it as it's a data loading and data unloading. Then another one is workload. So whatever the workload we are giving, multiple workloads, it's isolation. So it will make isolate and then it will perform different way. Okay, one person is running BI reports, Power BI report, some report. Another person is running another report. Another person is running ML and AI report, and everything workload automation will be different. Okay, and then dynamic scaling. Okay, it's a dynamic scaling. It's nothing but scale up or scale down. It will perform. Okay, we'll call it a scale up or scale down. So what is scale up and scale down? That and all we'll see later. It's like a virtual warehousing. We will put it like a t-shirt sizing. Like we will call it as t-shirt sizing. And then, so t-shirt sizing also we'll see later. And then Snowpark workload. So now we have the Snowpark, right? It's nothing but where we have our A and ML related one, Python related workloads that we'll call it as Snowpark. Call it as Snowpark workload. So where we have Python script we can write, and we can write Java code, Scala, and everything we can write here for A and ML related one, and BA also, but where we'll write notebook and everything. So these kind of activities can be done by computing. Computing means mostly like a running the query. If I want to run a query, I have to go for computing. Okay, so please remember this. So computing, if I want to run a query, I can go for computing. So third one, the storage. So where it is storing the data. So we are storing inside the storage layer, right? So how we are storing the data, that's important. So please remember, if you go for any interview, they will ask this question: how Snowflake will store the data? Snowflake will store columnar data storage. Okay, so columnar data storage. So columnar means we will see that. So what is columnar and data storage? It will make compressed way. Okay, so compressed way of data store. So compressed way means it will take 50 MB to 500 MB of each file. Okay, uncompressed. So uncompressed, it will take 50 to 500 MB. So after that, it will compress it and then it'll store. Okay. So compress means it will make a zip copy or something like. So each micro partitioned way of data storing. Okay, and then it will automatically do the encryption. So please remember encryption while storing the data inside AWS or AWS S3 or GCS, right? So it will do encryption. So what type of encryption it will do? So AES 256-bit encryption. Okay, so please remember this is also one of the certification question. They'll ask how Snowflake will store the data, micro partition. If I'm going to give, for example, if I'm going to give 2 GB of file, okay, so 2 GB of file I'm just giving to this particular. I want to store it 2 GB. So how Snowflake will do this 2 GB? So whatever I'm going to give, this 2 GB will be split up into multiple micro partition. Okay, 1, 2, 50 to 500 MB. This way it will create micro partition. How it will micro partition? What data will be there inside? And then everything metadata will be available here. Okay, each partition, what data is available. If I'm going to give 1 year of data or 1 day of data, and inside one day of data, so what kind of data is available? Everything, it will be micro partition, and this partition will get stored inside. If I'm selecting S3, if I'm selecting AWS, it will get as a S3 here. Okay, it will get stored here. So while storing, it is 50 to 500 MB, right? While storing, it will compress it again. It will store it, micro partition file, and then encryption. It will make encryption and it's a columnar. So I'm going to select this particular table. For example, I will go to the Snowflake, right? I want to query this Snowflake. Just I want to take this table. Okay, some table I'm just selecting. Select star from. I'm using it. So we'll create account later, but I want to select something like this. So first of all, if I'm going to run this query, what will happen? It's running sometime, right? So it will give you the result. It is giving the result. So how it is giving the result? Like a tabular format only it is showing, right? So everything is showing this way. But internally, how it will store? It will store as a 50 to 500 MB of micro partition file. Okay, micro partition file it will store. And so what kind of data we can store? So we can store 3 different data. We can store types of data. So what types of data? So one is structured data we can store. Structured data we can store. Semi-structured data, yes, we can store. Semi-structured, unstructured data also we can store. Okay, so these data we will handle it later, like structured file, like a tables, how we are doing it, tables, all the columns and everything, right? So that way, semi-structured, a JSON file, XML file, Avro file, Parquet file, different file format we have. Unstructured data like Word file, PDF file, audio file, cookies, log files, right? Log all the files and everything, it will store in this way. So it will inside S3 or GCS, this way it will get stored here. So these are the different functionality of each layer. So what is the first layer here? The storage layer. Second layer is query processing layer or compute layer. Third one is cloud service layer. Okay. So example, if I'm going to run a statement, select star from one table. Just 5 minutes, I will complete it and then I'll take all your questions. Okay. If I'm going to run this one, select star from some table, customer table. I want to run it. Okay. So which one? We have 3 different layers, right? We have 3 different layers. One is cloud service layer, compute layer, and storage layer. So how it will be executed? So if you ask me, so how it will be executed? First, which one will come into picture? So first, this cloud service layer will come into picture. So first of all, it will check access, whether this particular user has access or not, right? So if you are running a query, first of all, it's a role-based access, right? So if it is a production database, you don't have access to that particular database, how it will show you? So first it will check the access control. Then it will go to the metadata. It will check, okay, whether this table is present or not. So what is the column, right? How many columns are there? Instead of star, if you are making select customer ID from customer, if customer ID itself, it is not there in the metadata, no need to go and check in the storage, right? Why you have to go? So that metadata will hold it. Okay, this is the table, these many columns are there. This is the count maximum, that aggregation values, it will hold it in this layer itself. And here we have SSD. So that SSD only, it will catch it. Okay, so catching it will make, if I'm going to run the same query within next 24 hours, if the customer table, it doesn't change any data, then same record it will fetch. From where it will fetch? It will fetch from caching. It will not fetch from the storage here. It will fetch it. Snowflake will fetch it and keep it here. And whenever you are going to run within 24 hours same query, it will take from here only. It will not go and fetch again here. So that way it can reduce the cost also. So access, metadata, column information, and something like execution plan. Okay, so for example, you want to move from one location to another location, from Chennai to, you want to move Delhi. Okay, you are booking a flight ticket. Very first day you are moving. So what will you do? So you'll put, okay, this is what you have to go to Chennai, then get go to this airport, get bus, and then go to airport, train or something, metro. You put, go to Chennai, and then from there you fly it, and then there you get down, you get again metro, something like that. You'll put plan, right? Okay. So something, first time you are going, second time, again next day you are going. So you need something like that, right? So third time you are going. So if you are doing the same thing again and again, you'll be become a master, right? So similarly here also. So if you are running the same query, it will not go and fetch from here. It will take everything from the caching. It will keep all the aggregation information. Okay, count, maximum, sum, average, everything. It will keep it here in this query processing layer itself. And data, it will keep here. How it will keep? So we have the SSD here. I will explain that architecture also. So that will keep. And optimization. Okay, optimization plan. So everything it will have this here. Okay. So then second one. Okay, we have checked it. Everything is there. And I have to fetch the data, right? So second one, what it has to do? So it has to start the virtual warehouse. Okay, virtual warehouse should start because it will go for auto suspension. So it has to start the virtual warehouse. Okay, I'll tell you. So you'll get one by one later. Virtual warehouse later. It has been started already. Start fetching the data. So from where it will fetch? It will go and fetch in the storage layer. It will go to the storage layer. This cloud services layer, right? It tells that where the data is present and then start fetching the data from here. Start fetching the data from micro partitions, like micro partition from the which micro partitions the data is there. From there, it will fetch the data. So this is the way it will run. Then it will give the data to, again, it will give the data to cloud services layer. So that layer will show us if we do not have access, then even we cannot, it will not go to the storage layer. So here itself we'll see. So then it will display the data here. Okay, it will display the data. So this is the way it will display the data here. So these are the operations that will take place. So please remember, so whenever you are going to run any query. So this is what a layer. So what are the different layers are available? 3 different layers. So now you are clear, right? So if you take Snowflake, 3 different layers, it's a single and integrated system. Storage we have, query processing we have, cloud services we have. Query processing, we have the virtual warehouse. It's called virtual warehouse. We can create n number of virtual warehouse based on our workloads, and each virtual warehouse will have a caching. Okay, it will keep data, and then on top of that we have this cloud services. It will make authentication and access control, infrastructure management, optimization, transaction manager, security, firewall, and everything it will take care, and all the metadata. It means where the data gets stored here. So that information will be available here. How many tables are there? Each table, what is the record count? What is the maximum value, minimum value for each column? So everything it will get stored here. So that's what. So if you're asking select count of star, it will not go here. It will automatically take from here. It will show you. So that's what the Snowflake architecture. Very quickly it will perform. And this is architecture. Just we have completed only architecture. Still we have a lot of concept. So that we'll keep it. So hybrid columnar storage it will do in terms of blob storage. So even a lot of concepts are there. We'll see one by one. Compute engines perform massive parallel processing here. And then third one is, so this is the access control, right? Managing infrastructure, complete infrastructure, access control, security, optimizer, metadata, everything it will take care of this cloud services. Okay. So I hope you are clear of basics of this Snowflake architecture. Still we have many concepts are there. T-shirt sizing and then different object and everything, how it will store the data, what is the virtual warehouse sizing and everything we'll see tomorrow. But this is what the architecture of Snowflake. Okay, I got few questions. Let me answer it. So how can we integrate different sources from on-prem? So that and all we'll see later. Okay, Power Center and all. Just a ETL pipeline you have to create. Go to Power Center, and Power Center will create a connection. Okay, so not Power Center. Power Center we cannot do it directly. Informatica Cloud. So Informatica Cloud, we can create a connection and load the data into Snowflake, or just to export as a file, create a Snowpipe. So those things we'll see later. Okay, so just we will concentrate on the architecture. So this is the architecture here, right? So if okay, this is the architecture. Does Snowflake also store data? No. Snowflake will store only this metadata, caching data, right? So this one only will stay. For example, this is the query I executed, right? This is the query I executed. If you check this one, for every query profile will be created. So I just click on this query profile. This and all in detail we'll see later. Okay. So we got this query. It is going to the scan process. These many bytes has been scanned, and only one partition we have. It has fetched the data, right? So what is the seconds it has taken? 462 milliseconds. So this is what it has taken, 100%. Again, I'm going to run the same query. Is there any changes in the base table, raw transaction? No. Is there any changes in the query? No. Just I'm running it. So what is the seconds it has taken? 100 milliseconds, right? And then if I'm going to run the query profile, from where you are getting the data? Previously, what is the information we got? Okay, it went to table scan and it fetched the data, right? But now you can see this query result reuse. Query result reuse, it means it has already fetched the data. So that data itself, it will take it. So even if you are going for count of star, okay, so count of star, it will not go and fetch from the storage. It will fetch from metadata, 140 milliseconds. You can see this one, metadata based result. Okay, are you getting it? Metadata based result. Where it will go? It will not go inside the storage. From here itself, it will fetch the data. So now I executed 2 queries. One is select star from raw underscore transactions. Second time I executed within 24 hours. So it will take it from there, right? From this cloud services, and I executed count of star, maximum, minimum, and everything. It will fetch from metadata information. It will not go and fetch from here, because while loading the data inside here, it will put all the metadata information, everything here. So that's what the Snowflake architecture. Please remember. Okay. Snowflake has three different architecture. So one is storage, another one is query processing, and cloud services. So it's a brain of the system. This is muscle of the system, and this is heart of the system. Okay, we have so three different layers we have. So how does it knows the table data changed or not? Okay, that's what metadata will information will do, right? So whenever you are going to do update table name, insert table name, all this, again metadata will get refreshed. So that's what Snowflake knows it. So where it is going to store all the data. So it's a very early stage to explain this. So we'll see that later. Metadata information and everything, you'll get to know everything. Why Snowflake has to build on any one of the platform? Already these services has their own warehouse, right? If you want to go for Redshift, so very well go to AWS and create Redshift data warehouse, right? But if you take Redshift, so they are not going to give you data cloning. No, they're not going to give you. Data sharing option is not there. And security is not there. Columnar, they will do it. But if you take the other decoupling architecture, okay, so here query processing and the storage, it's a decoupled. For example, for my table, I have to increase my storage. I can increase separately. I can increase my warehouse sizing. Then I can increase the warehouse sizing. Both are decoupled one, but there it is coupled one. It means I have selected some cluster. So that cluster is coupled with storage. Okay, that cost we have to pay for that. But now they are even AWS or this Azure also, they are coming up with a decoupled architecture. But this is what the decoupled architecture we have. So that also we'll see in detail about what is decoupled architecture and everything. So can we use two cloud providers in one single account? One single organization, we can create two account. Okay, one single organization, we can create two different account. So that's what even these concept we'll see one by one later. Okay, so those things we haven't created this one, right? I'll tell you this one account. So what is account inside the account? So how we will create account, all this we'll see one by one. If you have any questions related to this architecture, I can answer it today. But other questions about this data storage and all this, we'll see going forward. We'll see one by one. I haven't completed this architecture at all. We have a lot of other concept also. We'll see. But if you have any other questions related to how we will load the data, other things, that we'll take it later. Okay. Yeah, please go ahead and ask your questions. I'll answer it.
Okay, so how this Snowflake is unique among the AWS Redshift or Azure?
Yeah, that's we'll see tomorrow the comparison. Okay, the comparison, I have the slide. We'll do the comparison. Okay, how it differs from Redshift and all. I have already taken this one. We'll do that.
And in terms of the architectures, how it, so even that is also covered in the comparison, or
Yeah,
in terms
architecture.
of
Yeah, architecture also.
okay, okay. I think, and before this Snowflake or AWS or all this comes into picture, we do have the Teradata architecture. I do recall the similar
correct.
three layers,
Yeah,
right? So,
yeah.
but with some additional features or some controls to the user in this case, like we can control the services, we can control the dynamic scaling. I can see these differences, but the similar architecture is for, I do see for Teradata.
Yeah, very powerful system. The Snowflake is very powerful. There we are using Teradata, maybe like only for structure to handle the structured data, right?
Correct.
Previously we were using, but
Correct.
Snowflake can handle now structured, semi-structured, unstructured data, all kind of data.
Yes. Mm.
So
So
that's
even the
why,
Redshift, the synopsis, those are also the similar structure.
yeah. They
Structure.
they will also use it, but they will use, okay, if I use AWS, right, Redshift, we can use AWS services. Okay, to store the file, we will use it ourselves. Bring the data to AWS S3. and then load S3 to data warehouse, do the data cleansing, data transformation logic, everything, then load it into Redshift. So that we will do as a by using, if you take AWS, we have the glue, right? So we'll perform this one. But it's a unified platform. Everything you can do it in the single platform. Not no need to go for different services there. Right? That's what it is advantage of Snowflake and Databricks. Both are like a competitor now. If you want to process a huge volume of data, right? So both are very good platform. So very high performance.
Okay, thank you.
Yeah.
Chandra, is dynamic scaling and auto scaling are same?
Auto scaling, dynamically, it will scale up. Okay. So for example, auto scaling means it is scaling up, scaling down based on the requirement. Okay. So if I want to do, but dynamically it will do. For example, already query is running. You have selected a virtual warehouse size, like a medium size you have selected, but you are thinking that this query is running for longer time. You want to increase it to larger size. So you can just increase it, scale up or scale down. It will do. Dynamic means you can go for serverless process. It means we are not going to define, okay, which warehouse needed. So everything you leave it to Snowflake. Snowflake will take care. Okay, so that's why we will call it as the Snowflake architecture. It's a self-managed service. So please remember, we will call it a self-managed service. So what is self-managed service? So everything Snowflake itself, they will manage it. Okay, it will automatically, it will do. So that's what they have created a software. Okay, so still they are improving it a lot. So even a lot of changes they have done it in the last release, the Snowflake, this UI, and now they have integrated this UI with Copilot, and then they have integrated with the Cloud AI and everything. So we'll see that one by one later. Okay, that's the advantage. Snowflake is upgrading this platform like for higher performance. They are checking everything very similar to our Databricks, then they are updating it, this platform. Okay, so we will stop it here. Still, I have to explain that architecture behavior. Still we have. So how it differs from these Teradata, right? As Teradata also will use that shared nothing architecture. Here also will use shared nothing architecture. So we'll see one by one. Tomorrow we'll continue that. Okay. So we'll stop it
Thank you,
here.
Chandra.
Tomorrow we'll continue. If you have any questions related to your account or anything, or how to access the recording, right? You can stay here. I will explain it one more time. And yeah, if you don't have any questions, we can wind up today's session. So thank you all. We'll meet tomorrow, same time, 7 o'clock. So please join by 6:55. So I will start the session by 7 o'clock. Hello, everyone. Very good morning and good evening to all. Let us start our today's session. So yesterday we have started with Snowflake architecture. So where we have seen three different layers in Snowflake. On top of any one of the platforms, we can create Snowflake, either AWS or Azure or GCP. So we have three different layers. So one is storage layer, another one is query processing layer or compute layer, another one is cloud service layer. So in the cloud service layer only, we will do all the authentication, access control, infrastructure management, metadata management. So everything Snowflake will maintain here, optimization, execution plan, data sharing plan, everything this cloud services will maintain. And then query processing or computing, then this will take care all the processing. Okay, so query, whenever we are running the query, this query processing layer will take. So we'll call it as a compute, or it's a virtual warehouse, right? All this it will take. Then we have the storage. So storage, where it will take storage, so underlying storage, either on the AWS or GCP or Azure, it will store the data. How Snowflake will store the data as a columnar storage, and also it will take compressed 50 to 500 MB of micro partition file. So without compression it's 50 to 500. With compression, it will reduce. micro partition, and it will be encrypted file. Also, it will get stored. So how they are storing, so internally that we may not know, but whenever we are running a query here, then we will get all these three different layers. So we have seen this one, right? So what is that? Everything we have seen. So today, go ahead and then we'll see. So why Snowflake? So that's what yesterday also we have seen. So why Snowflake? The scalability and elasticity. So separation of storage and compute. So if we want to increase storage separately, yes, we can increase. If we want to increase compute separately, yes, we can do. So these steps you will see practically in our session, okay? And traditional systems, if you go to any on-prem, like Oracle, SQL Server, or DB2, Teradata, these system on-prem system. So if I need more space or more capability, so I can go vertically, I can expand. So vertical expansion, right? So it will be very expensive. Okay, so you have one server, and if you want to go for more than that, so you have to add one more server capability. So that's what it will go for expensive. And here everything is like a whenever we need, we'll expand to auto scale, pay as you go model. So normally you'll say it's a pay as you go model. So whatever the resources we are using for that, we have to pay for that, right? And support for big data and ML workloads. It can support structured, semi-structured, unstructured data, and collaboration and data sharing. Yes, we have the notebooks also. Snowflake, we have notebooks very similar to our Jupyter notebook or Databricks notebook, and we can do queries and everything. We can share it to our team members also. Data sharing across organization, everything we can do. Across region also we can do. Performance optimization. So here it will automatic clustering. Clustering, pruning, and everything we'll see later. Performance optimization, so that we will get clear idea. So all this we'll see one by one later, then we'll get clear idea, right? So this one we have seen. So how the architecture will be, we will call it as it's a multi-cluster shared data architecture. Multi-cluster. So here it's a multi-cluster, you will say, and then it's a shared data architecture. Okay. So now, if you take, so what is mean by shared architecture, right? Shared nothing architecture. So if you take left-hand side, so we are the node one. This is, so whenever we are going for real-time project, right? So there we'll have, we are going to handle huge volume of data. So there we will keep it multiple nodes. So within the server, based on the capability, we will increase the node. For example, here we have three nodes. Three nodes. Example, here I put only three nodes. So node 1, node 2, node 3. So we can go for node 4, node 5 also. Any number of nodes we can go based on the need requirement. And here we have the storage. This storage, right, is like a disk. So we have the data center, the company will maintain it, and then it will be shared across all the nodes. So if node 1 wants to access it, it has to access it. Node 2 access it. Node 3 access it. This is shared disk. This disk can be shared across all the nodes. So normally this is what we'll have. And here we have shared nothing architecture. And shared nothing architecture means it is not shared. So if node 1 will have separate storage, node 2 will have separate storage, node 3 will have separate storage. So this way it can access quickly the storage and it will give the data. So this is nothing but if you take Teradata or any other architecture, we will have this kind of shared nothing architecture. In Snowflake, we will have this one, shared disk as well as shared nothing architecture. So this way it will have it. In Snowflake also, it will make it in this way. Okay, so however, in today's world, there are data warehouse design that can use both approaches simultaneously, like Snowflake. So Snowflake can use both. Maximum it will go for shared nothing architecture this way. It will access it, it will go and store, and then it will access it like a micro partition. So how the micro partition will work, and then we'll see later. And this is the architecture we have seen: storage, query processing, that yesterday we have seen, cloud services we have seen, right? So everything we have seen now. So this is like a just a, it's a assumption. Okay, it's not exact of virtual warehouse. It's just an assumption. And if you take AWS EC2 instance, AWS EC2 instance, if you are creating it, and it has been compared or Snowflake. Okay, so how we have architectural way, it is compared with EC2 instance in AWS. So how it will be? So Snowflake uses t-shirt sizing. So what is that? Virtual warehouse. So if you take one virtual warehouse, why we are using virtual warehouse? For computing, right? So computing power. It will use this t-shirt sizing. It start from excess. So how we are the t-shirt? We are the extra small, and then small, medium, large, extra large, then up to 6XL we have 6XL. So this is what, so how it differs, we'll see one by one. And most Snowflake uses, okay, the smallest warehouse. If we go to our dev environment, in our real-time project dev environment, so they will give access only to XS only, or maximum small, because in dev environment we will use very less data, and then some more, when we are going to use XS, that's more than enough to handle. So even this XS, right, extra small size, so it can handle up to tens of gigabyte of data. Sorry, gigabyte of data. It can handle GB, in terms of GB it will handle. So if you want to go for TB, terabyte or petabyte, so then you can go for next size. So this way you'll have different size. So it is not exactly the same, because Snowflake will not reveal this information to outside, but it's like it is compared with the EC2 instance. And if you take one EC2 in AWS instance, right? So how it differs this way. If you take Excel, this excess size, it has one node. Okay, it's like a one node. If you take this is the one node, and inside the node, 8 cores we have. So how we have our system? So 8 core, 16 core, 32 core we have, right? Similarly, so 8 different cores will be running threads, server process. So parallelly it can handle it. 16 GB of RAM, 16 GB of RAM, and 200 GB of local disk. So you remember yesterday we have seen that it will use caching, right? In the compute it will use caching, and there it will make this storing, caching. Okay, next to 24 hours it will use. So how much it will use here? 200 GB of local disk, 200 GB, and then 16 GB of RAM it will use here. So local storage, 200 GB. This is for extra small size. 8 cores will be running in parallel. If you take this is excess, and we'll go for small, it's like a doubled. The power is doubled. If you go to medium, so again it's a medium is double here. So if you go to large, it will be double. So this way it will go for. So one excess if you take, so 8 core, and then RAM we have, and SSD we have. So this is not the exact architecture of Snowflake, because Snowflake will not reveal that information to outside. It's just a comparison with, okay, this is what they may have when compared to this EC2 instance, how we have, right? So similarly they have. So if you take the T-set sizing, the value sizing, it it will be starting from, so if you take this one, so it will be starting from XS. So what is that? So whenever we are going to run any queries, we have to select the virtual warehouse. So then only we can run a query. And it's more than enough to select XS. So it will take one node, right? One single node, and then 8 cores, credits per hour. So this is what they will calculate the cost. So tomorrow we'll see, so how they will calculate cost and everything. Okay, so tomorrow we'll see that. And if you take small, it's a 2 nodes, 16 cores, and then it will take 2 credits per hour. So 1 credits per hour. So they will calculate based on this. Okay, this is 1 credit, right? And if you take excess, the AWS region and AWS Canada Central, then what is the cost? This cost one we will see tomorrow. This cost, so how they will calculate cost and everything we'll see tomorrow. And we'll have some calculations also. I will explain that calculations, how they will calculate the cost. So how if you are going to work on the Snowflake admin, so you'll be working on this cost here. But these are like when compared to EC2 instance, one instance if you take, so how much the core, and then so how many cores are there, one EC2 instance, this is compared with that. This is not the exact one. Snowflake will not reveal that information to outside, but this is what it will have. Okay, so power. If you take this is one node, then it is like a 6XL will have 512 nodes. So parallel it will run. And small will have two. And if you take XS will have 8 cores, and 6XL, right? Will have 4096 cores, it will be running parallel. So and think about if you have petabytes of data, then this one, Excel, 6XL and all, it will take quickly, it will take compute, it will make query running. So you'll get very quickly, it will run, it will give you the result. So if you have huge volume of data, and if you are doing a lot of calculation, aggregation, then you can go for maximum. Maximum we will use large. So in our real-time project, large, we will not use extra large to Excel and all. It's a very rare scenario. We'll go for this way. So even if you are going for large or more than that, we have to get approval. It depends on the project. So they'll go for some, if I want to use this one, I have to get approval. Why we are going for this one? So what is the volume and everything we have to give? So that's what we have to use it. Okay. So what is the urgency to complete the task immediately? Then you'll go for. So because the cost is more, right? So 8 credits per hour. So based on the credits, the cost will be calculated. Okay. So cost, how they will calculate. Tomorrow we'll see that one by one. This is the t-shirt sizing. So we have different t-shirt sizing, and then it will go for this way. Okay. So this is the same one I put it here. And most Snowflake, this is what they'll go for gigabyte of data, right? So processing power and RAM and local storage. This is what it will have one particular warehouse. So warehouse will say in Snowflake we have different objects. Okay, different objects. So we know right already on any one of the platforms we created a Snowflake. So if you take this is the complete warehouse, we'll call it as it's a complete enterprise data lake or enterprise data warehouse, we'll call it as. This is enterprise data lake. So data lake meaning, so both we can store structured, semi-structured, unstructured data. Everything we can handle it here. Mostly Snowflake, we'll load it raw data. After that, we'll do the transformation logic. So if you take this is the one warehouse. So inside the warehouse, this warehouse is different. Virtual warehouse is different. So virtual warehouse is for computing, and this warehouse is for entire Snowflake. We'll call it as warehouse or data lake, enterprise data lake, EDL. So inside the data warehouse, we can create multiple databases. So please remember.
Please repeat
inside,
one more time. I'm little confused here actually. Sorry.
Yeah. So Snowflake object, right? So anyhow, we will see in the UI also. So you'll get clear idea. Entire Snowflake, we will call it as enterprise data lake, right? Enterprise data lake. So that's enterprise data lake. We are creating enterprise data lake on any one of the cloud providers here. Okay. Inside Snowflake, we can create n number of databases. N number of databases we can create in one account, and one organization we can create any number of account. Within one account, we can create n number of databases here. Okay, database 1, database 2, database 3. This way we will create. This is logical division. So how we have, for example, you have 1 terabyte of hard disk. In the 1 terabyte of hard disk, how we are splitting that? Okay, like I need C drive, 200 GB, and then D drive, I need 400 GB, something like that. We are splitting, right? So based on my requirement, I am splitting logically my Snowflake. Okay, I need this one for retail database, this one for finance database, this one for some other database. I'm just creating it. So our project based one, project name also we can give. Inside the database, we will have the schemas. Okay, so please remember, inside the database, what we'll have? Schema. It's normal database, right? Schema 1, schema 2. This way we'll have n number of schema we can create. So schema also is a logical division. Okay, this is the logical division here. Okay. Inside this database, we can create n number of schema. Inside this database, we can create n number of schema. We will see that. Okay, so practically we'll see, you'll get clear idea. Inside the schema, we can create a different objects. So what are the different objects are available? It's a logical division, right? In one schema, we can create a table, right? So we can create a table. Even in table also, we have different types like permanent table, transient table, temporary table. A lot of other tables are there. 9 different tables are there. So those 9 different tables we'll see. Tables, views. So views we can create. Normal view, materialized view, secure views that we can create. And we can go for task to do the orchestration. We can go for task and a lot of other objects are available. Okay, we can create different other objects we can create. Okay, similarly, then we can go for other different schemas. Inside the schema, we can have multiple object. So this is what we'll have. It's a logical group of database objects, views, tables, and everything. Okay, if you take left-hand side, we are the one organization, right? In one org, we can create a number of account. If you take one account here, within one account, we can create a warehouse. That is our virtual warehouse. We can create any warehouses. Virtual warehouse is different. The entire EDL, we will call it as different. Okay. Within the database, we can create a database role. Yes, we can create a role. Based on the role only, we will give access. Within the database, we have the schema. Within the schema, we have tables, views, stages. Okay, stages is nothing but we are going to store a file inside the Snowflake. That's a stage. And then we have the stored procedure. We have UDF, user defined functions, and other schema objects we can have it. Similarly, one account, we can have role, different users, and other objects also, account objects also we have it. Based on our role only, we will get all the access. So everything we will see in detail in our session so that you will get clear idea about so all this. Okay, so if you take this one, okay, the delivery model, okay, if you take, okay, how this Snowflake is differs from Amazon Redshift or Snaps Analytics. If you take Amazon Redshift, yes, Redshift also is like a data warehouse. Snaps Analytics also data warehouse, right? Then why the companies are moving towards on the Snowflake? Because it has a lot of other features also, where these Redshift or Snaps Analytics doesn't have. So like we can do uh, time travel. Then even if we drop the table, we can recover the data. Okay, even if somebody else unknowingly deleted that data, we can recover it. So that is option is available. Data sharing is available across entire region. We can do the data sharing, and then compute and so how we are storing compute our data storage. We can increase decoupled architecture so that we have in our Snowflake. So Snowflake is a software as a service. So we are just using it. We have to pay to Snowflake. Snowflake internally pay whichever the platform we are choosing. Okay, they will have some contract. They will annually or monthly they will pay to the system, the platforms. So if you take Amazon Redshift or Snaps Analytics, so those are like a platform as a service. So they will give platform as a service. So here we have the storage format, right? So it will automatically compress it. So auto compressed and columnar micro partitioned. So here it is a micro partition. So that's why so it will have, so we do not have any primary keys, foreign keys, and all the concept here in Snowflake. So only with hybrid table we have, and we will see that later. So how can we create, so how it differs from other tables? How can we handle our duplicate records? Everything we'll see that. And Amazon Redshift, it's a compressed. So here also it's compressed, but not a automatic. So here we have to do manual one. So everything is a self updatable, right? In Snowflake, everything it will go automatically. And data security, so both are same. AES 256 only. So here it is fully managed. So you can go for fully managed. We can do So we can create virtual warehouse and everything. We can go for one more option, serverless one. So while we are creating the warehouse, virtual warehouse. So that is also we can take. And here we can have only one cloud platform, but here we can have different cloud platforms. And performance is here, it's a ultra fast because we are using that different methodologies here. Okay, so Snowflake they'll use in different way. So here also pay as you go model here also, but here these are the services, right? So if you are going for if you are taking AWS platform, okay, everything you have to use AWS Glue and then AWS S3 for storing the files. It's for data lake, and then you can use Redshift. But the performance wise and everything, the Snowflake and Databricks are comparatively more, and we have other features also. Like as I have mentioned, we can have the time travel. It's a very good feature, and data cloning we have, and orchestration, everything we can use it within Snowflake itself. So that's why we are using Snowflake. Performance wise, it's very good. But cost wise, yes, cost is so we have to use in Snowflake. One of the challenges we have the cost optimization. So that's what a separate team will work on that. So how can we use the cost optimized way? So that is what we'll work on that. Okay. So what is orchestration? Orchestration meaning it's a scheduling. So how we are not a scheduling, how we are creating the data pipeline and we are loading the data. Okay. So like mostly you'll have for scheduling, right? So how we are scheduling a task and the data pipeline, it will pick the data from the source system. Maybe it's a batch data or live data that we are loading into EDL, and how we are creating dimension and fact tables, how we are scheduling it. So that is orchestration. And decoupling means,
You mean it's the whole flow how we are loading the data? Is that so?
yes, correct,
Means.
correct. Moving the
Okay.
data from source system, from source system to till up to our data warehousing. Okay, so how we are moving the data. So that's what we'll go for orchestration. Okay, so this is the one. And decoupled architecture, yesterday I explained, right? So we can increase the size of our warehouse and increase the size of our storage. So that is independently we can do.
Okay.
Okay, so I hope everyone is
Thank you.
clear about all this architecture, and we'll create account. Maybe parallelly you can also.
Sorry to
Yeah,
interrupt you.
just a second. Let me complete it. I will take your questions. Give me some time.
Yeah.
Okay, so this is what the architecture I just explained, and I hope you are clear.
Chandra, actually in shared nothing architecture you explained, right? In that each node will have the separate store like I mean node is nothing but the storage, right?
Node is nothing but server process, computing.
Server. Okay, computing. Okay. That what only. Suppose if how why I mean if we are loading the data, how the data will distribute across the nodes. Suppose if we do sell stuff on the table, from which node it will come the data.
Everything Snowflake will take care. Okay, Snowflake will take care if you are taking this node. This node, if it is, if you are running, select star from the queries, this node is running for other different user queries. This node may be running for other different user queries. Okay, different users they will run, right? So that's what you will have multiple nodes. Threads will be running. This node will take care this storage, and then it will have metadata information that on the cloud services. Okay, where the data will be stored, it will pick in that way. So that's what
Okay.
micro partition everything we will see in detail. So how the data will get stored and then how it will pick, all this we'll see in detail.
Okay. Suppose if any one of the node got down, like we can't access the data from that particular node, right? So, or if it is shared disk means we can access from other node as well. But on the shared nothing, if any
It will
node
have
goes
the
down,
fallback node.
okay.
I think it
That
will
is a
automatically retrieve from the other cluster node, right?
yeah,
Chandra?
it will have the fallback node. So we are not going in depth on this node concept because so that will be taken care by Snowflake, right? Internally they will take care. But if you take this node shared nothing architecture, very similar to our Teradata, they'll have a fallback node. So if one node is down, then all the information will get stored in the metadata. The fallback node will take care, and then it will take the data from here. If even storage also it's going down, it will have the replacement disk. It will have the replication factor. So it will get replicated in another storage also, right? So then if this storage is
Yeah,
going down,
cloning.
it will have the
Like
it will have the
cloning concept is
cloning.
there, right?
No,
Cloning.
cloning is very different. So cloning, if we want to do, we have to do it. But this is a server process. They will take care. Snowflake will take care. That's why Snowflake will not reveal that information to outside. That's a confidential information. So how they are storing. But everything they'll have fallback node. Here also they will have the storage also. They'll have some replications. So even if one data center is down, so they will keep it right. So they will go for AWS also will have the replication factor minimum three. Minimum three they will have it. It's like a big data concept. So if one data center is down, so automatically it will point to the other data center. It will pick the data. So that is the server process. They will have it. Storage also they will have a backup, and node also they will have the fallback node.
Must be some
Okay,
zookeeper kind of setup
Yeah, they will have it.
to check the
But
handshakes.
server process and all, they will not reveal that information. Even this information is like an assumption only. It's when
Yeah.
compared to EC2. So how it will be, how Snowflake may have the server and how they will have this local storage RAM and everything, and just an assumption. It's not exactly how they will handle it. Okay, if you take XS is like 8 cores we have, then small may have 16, double. So this way, just one assumption with EC2 instance. So AWS EC2 instance, if you take, it'll have 8 core and then RAM and then local storage. So it has been compared with that way. And data cloning is different because cloning we are going to do. Okay, if I want to do data cloning as a user, I will do. Then Snowflake will do that. But how Snowflake internally will do backup, that for recovery and everything, they will handle it. Snowflake. I hope you are clear. So what is columnar concept that we will see later. Okay, we have the session for that.
Chandra, quick question on architecture.
Yeah, please go ahead.
Coming to the architecture, you have mentioned like we can have multiple data, n number of databases, right? Like, and within that, we can have a number of schemas, so on, so right. So the databases can be heterogeneous, right? Like one is Oracle, one is SQL Server, and one can be.
No. So this is not the on-prem databases. Okay, this is not the on-prem database. So even sometimes they will ask interview this question. So I'll explain. So this is if you take this is one entire Snowflake, right? Snowflake. So how are we going to logically divide this Snowflake? This one. Because everything we are not going, if you take very big organization, right? Everything we are not going to put it everything inside the Snowflake, right? So how we are going to split this entire account, one account into logical division. So if you take this is the one, then this is nothing but one database. Logically, we can divide one database. Another one is this is another database. So we can create. So this database, we can call it as it's a retail DB or some other DB. So another DB we can create. Okay, so this way. So if you take AWS and all, there we can create RDS instance. So that is different. Inside AWS, we can create RDS service. Okay, I want to create Oracle, then I can create Oracle instance, SQL Server instance, or a Postgres SQL. Everything I can create as an instance. But here we are logically creating a database. Okay, this is database. So each database, inside the database, by default, we will have two schemas. Inside the database, how many schemas will be there by default? Two schemas. So what are those two schemas, right? So one schema will be public schema. Okay, so one database. So first one is called public schema. Another one is called information schema. So this one, information schema. So this will have all the metadata information. By default, it will have. So it's like a read only. Snowflake will handle it. So whatever the object we are going to create, like a tables, views, and everything. So that will make an entry here, Snowflake, for this entire database. Similarly, for this one also, it will keep another two different schemas by default. Two schemas will be there. One is public, another one is information schema. In addition to that, we can create n number of schemas, okay, inside database. That's what we are going to see now practically, so that you will get clear idea. So how we will create a database inside. Okay, what I want to explain, right? See, this is like a whatever the tables we are creating, those tables are data lake, we'll call it as, right? Normally we'll go for it's a cloud, right? Sometimes in interview they will ask, can we create OLTP system here? Can we create OLTP kind of tables? So we have options like the tables, hybrid tables we can create. Okay, so we can create some database. There we can create some hybrid tables. So that table will have similar to of our normally how we have our Oracle table, all this table, right? So like we'll have the primary keys, foreign keys, and everything we can handle it by using this hybrid tables only. So if you want to build any OLTP kind of tables, the architecture, then you can create separate database and you can keep it. But normally we'll not do that. So everything will have it without that normal permanent table only will create our transient table or temporary table. I hope you are clear. Still, I haven't completed this one.
Yeah. Here, my question is: well, schemas are logical division that belongs to they all belongs to the particular database. So my question is: can we create multiple data? I mean, like heterogeneous databases? Is it not possible?
We cannot create any database like Oracle or SQL Server here.
Okay.
Here database is a logical division, right? Just a
Okay.
logical division. So we will call it as it's a database. How Snowflake will do? Snowflake internally will go and store the data as a file system only here. So we don't have any Oracle or we don't have any SQL Server databases inside. So those are like a different, how to say, it's a different vendor, right? Oracle is one vendor. Microsoft SQL Server is another vendor. So if you want to create a different instance on the cloud, then you have to go for AWS or Azure. So there you can create some Oracle instance there. That is OLTP we can create. But here it's like a cloud databases. Okay.
Chandra, I'm not clear about the decouple concept. Chandra,
Which,
can you please repeat once?
sorry, which one?
Decoupled.
Okay, decoupled architecture. I will explain that. Okay, I will explain that. So if you take our Redshift as a data warehouse, right? So there itself, AWS itself, we have S3 and everything is there. So if you want to purchase, okay, for this particular cab load, you have to purchase it for that particular server capability. For example, if you take one example, I'll say you take any one of the real-time projects here. Normal January to November, they have some transactions. Okay. So in the December, they will have some transactions. Mostly like in US, Canada, they'll have very huge transactions starting from Thanksgiving Day and then till that New Year, they will have the transaction, right? So whatever they are doing, the transactions business on these 11 months, mostly they'll get 1 month, this 1 month. Then if you take the transaction count here, you have less, and then transaction count maybe here double or triple. So if you want to handle these workloads this December month, if you take on-prem databases, so what you have to purchase? What you have to purchase? Will you purchase this server capability or this server capability? We have to purchase this per server capability, right? We cannot purchase server only 11 months for this one and 1 month for this one, right? So if it is on-prem databases, server capability. So we have to take, okay, so I will handle, this is the data volume, very high volume, I will handle it throughout the year. I need this server to handle this particular volume. It's like a petabyte of range of data we are taking, right? So in that case, we'll go for, okay, server capability, this one. Even if you are using or not using that, you have to pay for that based on the user. Number of users and licensing, you have to pay. Am I correct? But in the cloud, it's not like that. whatever we are, it's like a transaction based. Okay, if you are using more capability here, increase the server capability here in this particular month to do the transaction here. Okay, if I want to load huge volume of data, you want to increase compute. Am I correct? So compute,
Yes.
you have to increase the compute here. Okay, so this month you need more storage here because a lot of transactions coming, and then you want to go for this one. So today I have purchased this one. So if you take server, normally Oracle server, SQL server, there, it's like a vertical scaling, right? Normally you'll go for, okay, one server is like 1 petabyte of storage disk we created, and we will go for another 1 petabyte of this one. So we have to purchase, right? Another 1 petabyte. This way you have to go. But here today data is coming petabyte. Tomorrow it's coming like a terabyte, or later it's coming like a only gigabyte. So any number of scaling, automatically it will scale up, right? So storage, you can use it, Snowflake. Today I need 1 petabyte. Yes, I can increase it. I need storage, I can increase it. It'll auto scaling, right? So it'll go up. I need more power here. So I want to handle huge volume of data. I'm just running one particular query. I can create one warehouse with small excess, one warehouse with large. When you'll go for large, if you want to handle huge volume of data, like you are running a query with aggregation, all this, then you will use this query to attach it. Okay, to attach it and run this particular query. It's like a decoupled. So you can increase computing power separately. You can increase the storage separately. But if you take AWS or Redshift, that is our Azure Snaps Analytics, initially they have this way, but after that Snowflake, they have come up with decoupled architecture. Even they also incorporated those changes. But previously, how we have, if I want to increase the server capability, Redshift and all, we have to increase both storage and computing. Okay, storage they will give 1 petabyte, and computing they will give for one large cluster size. Both will be there. So you have to purchase for both. It's not like if you are purchasing large, you cannot use gigabyte of range of storage here. Both it will get simultaneously increased. So that is a coupled one. But here, so it's a decoupled one, and any number of warehouse we can create. So virtual warehouse we can create. Okay, so I'll tell you. So we'll create account, then we'll see all this one by one. If you go here, so this is entire UI. Okay, this is called Snow Site. Snow Site. So normally this web UI, we'll call it a Snow Site. It is self-updatable. Snowflake, if they are updating it, so it will automatically update here also for everyone. It is Enterprise Edition, and this is the same one we will have it in our real-time project also. Only thing is we may have more number of databases. So left hand side you are seeing something like a database, right? So these are the database. I just created multiple databases here. And inside the database, for example, this is one database. So inside the database, we'll have public schema and information schema. In addition to that, we can create a number of schemas here. And similarly, are you seeing that warehouses here? My compute warehouse, then compute warehouse. So what is the size? Compute warehouse is small. Snowflake learning warehouse is XS. And my compute warehouse is medium. For example, I want to run this particular query. For this query, what is the warehouse selected? By default, medium has been selected, right? Medium has been selected. What is the medium? So this is what we will see one by one. I don't want to go for here and there to explain it. We will go with order. Okay. Just I want to explain it. This is the one. But if you are thinking that, okay, this query is huge and you are running you are running with multiple table joins, aggregations, then while attaching, you can change it here. Okay, you can go for small one, medium one, and anything. Okay, you can attach it and then you can run. So if you're running it, so how it will be running? Are you seeing that this one is not started, right? So if I'm going to run it, then it will automatically start this one. Okay, so you can check it. It's like a very fraction of second, it will automatically start and it will be running. It will fetch the data this way. Maybe yesterday we should have executed. So that's what we are getting quickly. We have the data and we are getting it. So this is what computing and the storage we can go independently. Okay.
Thank you, Chandra. I'm logging
Thank you
off.
all. We'll stop it here. Tomorrow we'll continue. Okay. Thank you all.
Thank you.
Hello everyone. Very good morning and good evening to all. Let us start our today's session. Okay. So if we take Snowflake, Snowflake is a complete data warehouse. Right. This is the complete data warehouse, right? So don't get confused with virtual warehouse and this warehouse. Okay. So this complete Snowflake, we will call it as cloud data warehouse. So inside this warehouse, we will have three different layers. This is the one layer and this is the another layer. So we'll have different layers here. So what are the three different layers? So here we have the storage layer, right? The first layer is the storage layer. So how Snowflake will store the data? This is storage. So Snowflake will store the data. So either by AWS on AWS or GCP or Azure, right? On top of any one of the cloud providers. So whatever the cloud provider we are choosing. So based on that, so Snowflake will store the data. So on top of this storage layer, we have the virtual warehouse layer. So this is a virtual warehouse. This is nothing but the compute, right? So we have the compute. It's nothing but processing, compute layer. So we can say it's a compute layer. So we'll process the data. So it's nothing but we'll have the virtual warehouse. So virtual warehouse, okay? So virtual warehouse. So based on this virtual warehouse size, the data will be processed. So this is a compute layer. Okay, so whatever the operations we are performing, like DML operation, DDL operation, any operations we are performing. So based on that, this compute cost will be calculated. Okay, on top of this compute, we have cloud services. So we have the next layer is called cloud services layer. So whatever the authentications, metadata, so everything it will be handled by this cloud services. We have seen already. So all this, right? Yes. So what we are doing now? So we have seen, okay, inside this Snowflake. So we have the Snowflake tables. So we have the tables here. So here we have the tables. So we can create multiple tables within the database, within the schema. We can create multiple tables. So by using tables only, we are storing the data. So internally, Snowflake will store data on these cloud platforms so that they will take care. But here we'll have the tables. So here we have the tables, right? So multiple tables will be available. So for this table, we have to load the data. So we can directly load the data, but here we will use some staging here, right? So whenever we are loading the data to tables, so normally how we will load? So if you have any external ETL tool like Informatica or any other tool, then directly connect to this particular tables, do the transformation logic here and load it. So we'll connect to the source system and load it, right? But for example, if we are getting sources from different cloud platforms, like maybe external cloud platforms, if you have external cloud platforms like AWS, so we may have AWS, right? So these, if you have data in AWS S3 or GCP GCS, okay, or Azure cloud storage, if you have so data from these particular external platforms, these are the external platforms, right? So if you have external platforms, if I want to move the data to this Snowflake, so how we will move? So from this is called external stage. Okay, so data we are getting to these platforms and we are ingesting the data to Snowflake. If you have any separate ETL tool like Informatica IDMC, yes, we can connect to this tables directly and then we can load. But here, so what we are performing, we are using Snowflake itself and ingesting the data. Okay, so how we are doing it? So these are the external stage, right? So we'll call it as it's external stage here. So from the external stage, we have to load it into this table. So then yes, external stage will authenticate everything. So from this cloud services, and we will use it. So, but here we have the files in our local system. Okay, so local or anywhere if you have files. So here we have the data files. You have some local system, you have the data files here. Okay, so this is called the data files here, right? So what we will do, so we need to load these files from this external place to this internal Snowflake. After that, we will process the data. Okay, so after loading into the tables, we can process the data, right? So how to move it? So from here, we have the data in these files, and then here we have the stages. So Snowflake by default, it will have 3 different stages, right? So what are the 3 different stages? So first one is the user stages. So whenever we are creating the user stage will be created, right? So whenever we are creating the tables, the table stage will be created. Whenever, so this is particular about the user. So this one is particular about that particular table. Okay, if we created a table stage for one table, then if you have data, that table stage we cannot access by another table. It is very restricted to that particular table. But I want a common. Okay, so then I can go for, sorry. Then third one is named stage. So we have to create our own stage. So then we can go for named stage. So here we have the stage is called named stage. So we'll create these two today and you will get clear idea. So what is that? So operation is everything is same, but only thing is, so this is restricted to that particular user. This is restricted to that particular tables, and there is no restriction for this named stage. So we have to explicitly create this named stage by ourselves. Okay, so from here, so what we will do, so this process, so whatever we have this data files, right? So we can have the files. Okay, so it may be CSV files, XML files, JSON files, any different kinds of files we can have. So from here also we can have, and then we can use the command called. So what is the command we'll use? So we'll use external tool. So because we need, so as of now, this Snowflake will not support from here to move the data to Snowflake stage. We will use one particular tool. It's nothing but Snow SQL, right? So we'll use Snow SQL. So this is called data loading. Okay, so this is called data loading here. So we will load the data from here to here by using, so what is the tool? Snow SQL, and we'll use the command called put command. Okay, so this is called from these data files to the staging we are moving. So this is nothing but put. So we are sending the data to the stage. So from stage, this is stage, up to stage we will send. So it may be user stage, table stage, or named stage. So based on our requirement, we will create the most used stages, named stage. Okay, so we will not, mostly we will not filter out the record, or we will not process the record while ingesting the data. So ingestion part, so whenever the file is available in the source system, the source place, just will ingest the data to the staging here. So after that, we'll move to the tables. Okay, so after moving that, so we can perform whatever the data transformation we need. But here it is called bulk data load. Okay, so whenever the file is available, we will move the data. So this is nothing but bulk data load. Okay, so we will load the data whenever the data file is available. So even if it is having more than 250 MB, yes, we can take this external place to the internal stage to move. We'll take this NoSQL. Okay, put command will use it and then move it. So after moving it, in order to load this data, so here tables, so we will use copy into, right? So what is the command here we will use? So copy into will use, and then by using the copy into, so we will move the data to these tables. So whatever the tables we have, and we can move it. So these tables will move the data. So this is like this way. For example, so tables we have the data, we have to send this table data to the outside. Okay, somebody else, we have to send the data. So that is called data unloading. Okay, this is data loading, this is unloading process. If you go to any real-time project, they'll be calling it as, okay, so data load, data unload process. So unload means So from Snowflake to outside, yes, we will send the data, right? So from downstream, we have to send the data, we have to unload the data. So for this also, we'll use the copy into only. Okay, so from here, we will use the copy into the stage. We'll first copy the data from these tables to the stage. So if you are using any external IACS or any Informatica or any tool, we are using ETL tool, just you can directly connect to this tables and you can create target as a flat files. You can send it. But here we are using this way. This is one of the way to send the data. This is called unloading data unloading process. Okay, so from here we will use, and here we are moving the data. So this is called data unloading process. Okay, so please remember this is data unloading process. So how we will use, similarly here we will use NoSQL only. This command line interface, we will use get command. So here we will use put command. So we are getting the data from this stages to our local data files. Okay, this is nothing but get. So here we will use put and here we will use get. So this is the overall idea. So here also again, you can use this external stage and then you can from external stage, this is external stage. So here, if you use internal stage, the storage cost, the Snowflake storage cost will be calculated here. But if you use external stage, the external storage, AWS GCP cost will be calculated, not in the Snowflake side. Okay, so compute cost is different, storage cost is different, data transfer cost is different. So this is the overall idea about data loading, data unloading. Okay, so I hope you are clear. And so this is what we are going to see. Yesterday we have seen user stage, right? So similar. So we'll create one more user and then we'll see that how the user stage is particular to that particular user, and we'll go for the other stages as well. Okay, so other stages operations are very similar to this particular stage, and we'll see one by one. Okay. In this video, I will show you how to enable this Gen AI model in our Snowflake workspace. Snowflake has introduced this workspace model to query our database. In this workspace, and if you want to get this Gen AI suggestions, so you can click on that. So if you are trying that, okay, I need to create a table, just you can make use of this AI. So create table. I want to create a table called customer. But now if I'm going to execute this particular statement, I'm getting this particular error. If you are getting this error, I'll tell you how to resolve this. So this error is because of the regions where we created our Snowflake account. So how to resolve it? So just we have to execute this particular statement, alter account, set Cortex enabled cross region equal to any region. So just execute this particular statement. So we are altering the account to set this property equal to any regions. Execute this particular line, executed. So now I will try to execute this particular statement. So the AI will help us to create a table. So just I have mentioned that AI, okay, I need to create a table, right? Yes, I created. So I want to just click on this accept. Then with this, you can create it, or you can go for create or replace. You can change it. So create or replace. For example, you are creating the table, right? So I'm setting up the context here and I'm going to execute this particular statement. Yes, the table has been created. After creating the table, I have to insert some sample data. Again, you can click on this Control I, then you will get the AI help. So here we can type it, insert sample data for customer table. Just you can put that for above customer table, execute it. Then we will get some statement here. Statement has been generated. So we can make use of these statements. Just accept it and insert some data here, right? So execute it. So it will create this particular 10 records has been inserted. So now we can query it. But completely don't depend on the AI. but make use of the AI. So nowadays, every project, we will use this AI to generate. It's very similar to our Databricks AI assistant, right? Snowflake also, they brought this new feature in Snowflake workspace. Just execute it. So we will get this particular table. Yes, we have the data and everything, right? So this is what you can get the data here and make use of this AI help. So I hope this video will help you to enable this Gen AI assistant in your workspace. If you want to get more videos on Snowflake, Informatica, and Azure, so please subscribe to the channel, and I'll be uploading more videos on these cloud platforms. Thank you for watching. We will meet in our next session with another wonderful topic. Thank you. Snowflake table types. In Snowflake, we have 9 different table types. Okay, 9 different table types. So what are those tables? We'll see. So first we have permanent table. So whenever we are creating a table, that is called permanent table. Okay, permanent table. For permanent table, there is no keyword. Just create table name, it will create a permanent table. This is a normal table we used to create. So then we have transient table, temporary table, external table, dynamic table, directory table, event table, hybrid table, and iceberg table. So these are the 9 different table types are available in Snowflake. Like these tables, like a directory table and event table, similar to metadata tables, these two. Hybrid table is similar to OLTP tables. For example, inside the Snowflake, so you remember I created a table in Snowflake, and then I inserted some duplicate record. Even after creating as a primary key, it will accept, right? So Snowflake will accept that. But if I want to enforce primary key, it is very similar to like Oracle, how we have the tables, right? Then I have to create a hybrid table. So this hybrid table, very similar to our Oracle table, where we can do primary key, foreign key, everything that will be enforced. Inside Snowflake, if you want to create any kind of OLTP tables, it's a very rare scenario, but still Snowflake is giving the option, hybrid table. Iceberg table is a table type where Apache Spark, we can create that iceberg table. So these tables we'll see later. Directory table, event table, hybrid table, iceberg table. External and dynamic tables are different table types. Those tables we'll see later. So here, first of all, we have 3 different tables. One is permanent table, transient table, and temporary table. So what is the edition we created? Edition. So Snowflake edition we created. Enterprise edition, right? We have standard, enterprise, business critical, and VPS, virtual private Snowflake. So these are the 4 editions we have. So whenever we create enterprise edition, so what is the default time travel? So time travel is default time travel 1 day. Am I correct? 1 day. How many days we can go? Up to 90 days we can go time travel. Okay, so time travel we'll have separate session. We'll see 90 days we can go. But by default, 1 day. So these options, 90 days, all this, right? So we can do by using permanent table, transient table, all this. So permanent table is like a normal standard table, whatever the table we are creating. While creating a table, create table name, it's a permanent table. Transient table, we have to explicitly create transient table name, then we have to create. So what is transient table? I will tell you. Temporary table. So temporary table means it will be available, applicable only to that particular session. Once the session has been closed, then the temporary table will get vanished. It will not be available. It will get automatically dropped. Okay, the data will not be available, automatically dropped. So these are the different tables are available. So now just I'll go here. I'll show you. External table is nothing but we are not going to create the table inside Snowflake. We are going to use external stages like AWS, Azure, GCP platform. Put the file there and create the table inside Snowflake. Inside Snowflake, we'll see only metadata. but the table, all the data will be available in outside. That is a file. So that we have external table. We'll see that. Dynamic table, it's very similar to SCD types or materialized view. So first we'll see these three table types. Then after some time, after completing the external stages, we'll take external table. Dynamic table is nothing but materialized view, very similar to materialized view. And these tables are metadata tables. These two tables we'll see later. So 9 different tables we have. So how many tables types we have in Snowflake? 9. What are those 9? Permanent table. By default, the table if you are creating, it's a permanent table. If you want to create any other table, we have to put the name here. Transient table, temporary table, external table, dynamic table, directory table, event table, hybrid table. So we have to use the keyword. But here, if we are not using any keyword, that will be a permanent table. There is no keyword like a permanent. So please remember, create permanent table. There is no keyword. Okay. Create table name. It will create a permanent table. Okay. These are the options. So now we'll go to this one. So we have permanent table, right? So what are those options we have? So we'll see that. So one by one, you will get clear idea. Okay, so these are the table level features we have. So first we have the permanent table. Permanent, transient, temporary. By using permanent, whenever we are creating create database name, it will create a permanent database. Okay, permanent database. Create schema name, it will create a permanent schema. Create table name, it will create a permanent table. So these are the options which we have already seen. How to create a database, schemas, and tables. And is it applicable? Yes, it is applicable up to database level, schema level, and the table level. It's a permanent. Permanently it will be available. Once we created, until otherwise we are going to drop it, it will be available there in the Snowflake account. When we are creating a transient, can we create a transient database? Yes, we can create a transient database, transient schema, transient tables. So while creating database, we have to create transient database name, create transient schema name, and then table name. What is the difference between these two? We'll see. And we have the temporary table. Can we create temporary database? No, we cannot create it. Can we create temporary schema? No, we cannot create it. Only tables can be created. Temporary table. Okay. So if we have created, for example, we created already database. Okay. So this is the database we created inside. Let me show you. This is our inside Snowflake. We created one database. It's called permanent database. This is permanent database. Inside permanent DB, whatever the schema we are creating inside, this is DB. Okay, this is permanent DB. Inside permanent DB, whatever the schema we are creating inside schema, by default, it's a permanent schema. Inside permanent DB, can we create a transient schema? Can we create a transient schema? Yes. We can create a transient schema. Permanent schema and then transient schema. Both we can create inside the permanent. So think about permanent is the top hierarchy. So inside permanent, we can create transient and temporary. There is no temporary schema. Temporary table only. Okay, inside this particular database, we have created permanent schema. Inside permanent schema, we can create permanent table, transient table, temporary table. All 3 kinds of tables we can create. Inside transient schema, if you are creating any table, so that will be automatically transient table or temporary table. So inside transient, we cannot create permanent table. Okay, so please remember the hierarchy. Okay, this is what we can create. So can we create inside the transient schema, can we create temporary table? Yes, we can create. For example, this is like a transient database we are creating. Transient database. This is like a transient DB. Inside the transient DB, can we create permanent schema? No. Permanent table? No, because it's already transient. Okay. Then can we create temporary table? Yes, we can create. So that is the hierarchy. So please remember, we'll see that. We'll see, then you'll get to know. So time travel. So by default for permanent table, by default it's a 1 day, 24 hours. We can go up to 24 hours, we can get the data. So time travel, we'll see that later. But we have 1 day by default, but we can make it like a 0 day also. Okay, I don't want to make any time travel. It is taking extra cost. Then I can put, okay, I don't want any, once it is dropped or truncated, leave it. I'm not going to roll back. So then you can use time travel equal to 0. Explicitly, we have to make 0 days. Otherwise, it will be a by default 1 day. And then we can go up to 90 days. So if you are not using time travel equal to 1 day, sorry, we are not going to use any time travel options. By default, it will take 1 day, but we can explicitly mention that 4 days, 5 days, 10 days, up to 90 days. Okay, for permanent table. Permanent table up to 90 days, we can go back and then get the data if something goes wrong. That have the other feature. Transient table, maximum we can go up to 1 day. 0 to 1 day. 0 to, can we make it like 0 to 0 days? Yes. We have to explicitly make, otherwise it's a 1 day. Temporary table also 0 to 1 day only. Can we go, so we create a transient table. Can we go to like, okay, today we create a transient table and some days, okay, after 10 days, can we go to like 9th day or 8th day? What was their data? No. Last 1 day only I can get the data. So that way. So we can go back and then get the data. So that we cannot take here. 1 day only, transient. Temporary also 1 day only. Fail safe. So time travel we have, right? We can. So time travel is our control. As a Snowflake admin or Snowflake developer, we have the control to define the time travel and then we can go back and then check the data. Fail safe is nothing but, okay, so even after 90 days, we enabled 90 days, 3 months. Okay, 3 months. It means, so we are at April, right? April. It means we can go up to March, February, and then January. January 18th, starting from January 18th, we can recover. So whatever the data was there previously, whatever the changes happened, so that we can recover from January 18th. January to February, February to March, March to April. 3 months we can go. For example, January 18th, we can recover, right? But somebody did the changes, something like January 18th, right? So we have January 16th. January 16th data, we need to take it. 90 days we enabled. But now I cannot take January 16th, what was there? I cannot go back and then take, right? But if I want to take, yes, still they are giving 7 days. 90 plus 7 days, 97 days we can go and then we can get the data. This 7 days is applicable only for permanent table. We have to contact Snowflake team, support team, Snowflake team, not our Snowflake support, Snowflake vendor. We have to check. We can go back and then take the data, 7 days. Transient table we created and temporary table if we created, there is no fail safe. We cannot go and ask them, okay, so we have wrongly truncated data. We have enabled only 1 day. So can we take the data before 2 days? What was there? No, we cannot take it. This fail safe. Okay, so there is no fail safe for transient and temporary. Validity, this permanent table permanently will be available. It will be available in the database. Any number of times we can use it. Transient table also to be permanently available unless otherwise we are going to drop it. But this temporary table, it's applicable only to the session. Session meaning, for example, if we are creating 4 or 5 tables, we have to join it. And we are thinking that, okay, it will take some performance impact. The temporarily we can store the data like a common table expression, how we will create common table expression and then we'll put the data into like a subqueries and then that table we are going to use it. Similarly, We can create a temporary table for that particular session, store the data. No need to drop anything. Just leave it, the table. If we come out of the session, then automatically this temporary table will be dropped. It's based on the scenario we'll go for. For example, permanent table, 1 day we can go, and then we can go up to 97 days. 90 days for time travel, 7 days for failsafe. This one. But if you are thinking that, okay, this is taking a lot of money, right? 90 days, 7 days, they need to keep the data and everything's cost, right? Okay, so we can go with always, we can create a transient table in dev environment. So we can do the dev environment transient table only. So then by default, we'll have time travel maximum 1 day. So that way we can reduce the cost. So based on the scenario, we'll go with, but most of the scenario will go with permanent table only. Any questions? We will see one by one all the options. So how we have database, schema, tables, and what is time travel, all this one by one. But before that, so do you have any questions on this features?
Chandra, one question. For permanent tables, 0 to 90 days, right? Suppose I by default it is 1 day. I only choose 1 day, then failsafe would be
7 days.
7 days. Okay. Plus one, so it totally 8 days.
8 days. If you haven't selected anything, totally takes 8. For example, today I created this table. Okay. Today I created customer table. Then I'm just loading data. Okay. I did not select any time travel or failsafe, nothing. I selected. So what is the time today? Sorry, date 18th. Okay, 18th we created. By default, 1 day. For example, by something, some junior developer or something, we accidentally truncated this table. Still, for example, today 8:27 p.m., right? Tomorrow up to 8:27 p.m., if we have truncated it, we can retrieve back. Okay, we can go back and then retrieve. Today we created the table. Then later of time, we truncated it. We can go back to only 24 hours and then we can take. Anyhow, we can go to 24 hours. We can take truncated the table. We can take the data. But 18th, what was there? Before 18th, 17th, what was there? That we cannot take. You got it, right? So daily basis, we have some data. So for example, you have bank balance. 17th, we have some balance, 1,200, something like that it's showing. 18th, something like some balance is showing. 19th, we have something like 3,006, something like this it's showing. Okay. We have truncated this table, this particular table. Everything gone. Okay. We haven't enabled time travel. So from 19th up to 17th, I can go and then I can check, okay, up to 18th, we were having the balance like this 2,400. And if you ask me what was there before 18th, so that I cannot get it because we have enabled 1 day, right? 24 hours time travel. So from 19th this particular time to 18th this particular time, what was there I can get. But if we have enabled time travel for 90 days, so we are at 19th, okay, or 18th, we can go back up to 90 days and what was there on that particular day, that I can get it. This is current data. Okay, this is current data, current balance, I can check. But what was there previously? Okay, once we are updating, it will get updated, right? For example, balance we are updating. This one. If we are not maintaining the snapshot, so if we are updating, somebody is asking, what was my balance on 15th? Is it possible to get? If you are simply updating it in Oracle database, if we are simply updating it, is it possible to get what was there on 15th?
No, not unless we keep it back up.
Yes, correct. Exactly. Right. We have to keep the snapshot, complete snapshot on daily basis. So that's what snapshot load will happen. It will take exact copy of the table. So that is for very critical table will take. But Snowflake, if you have enabled 90 days time travel, so up to 90 days we can go. This is one example I'm saying balance, but the entire table level data, we can, whatever the changes happen, that particular time, okay? So even if you are 24 hours, if you are changing 24 times, every hour you are changing the data, all this it will capture. So that's what Snowflake will use micro partition, right? So they are within the time travel, they are not going to erase the micro partitions. They will keep it, these micro partitions. Only the metadata they will change. Okay, current data they will point, but previous data they will keep it for future reference. So up to 90 days, we can go back and then check, okay, what was there at that particular instance. Okay, time. Okay, 7 a.m. what was there? 8 a.m. what was there? 9 a.m. So that way we can do the time travel, get the data. But current data, if you are updating, this is the current data that we can select. Before that, we can see the data. If you want to, okay, these are wrong data we loaded. I want to take, so what was there 16th? From there, I have to put all the new data. Okay, select star from the table name, go to the time travel, take the data, load it from 17 to 18, all the data load, do it again one more time with the correct calculation. So that way we can do. So time travel. So time travel, we have separate session. We will see that you will get clear idea. But table types. So how many table types are there in Snowflake? 9 table types. So what are those 9 tables? So these are the 9 tables we have. Okay, permanent table, temporary table, transient table. So permanent table we will create. Okay, is persist until we are going to drop it. So that's what permanent table. Persist until dropped, transient table. When we will go to permanent table, when we'll go to transient. Normally we'll go and create permanent table, and it's based on the time travel we will decide. So for example, these tables we need more time travel, then it's based on the database level it will take. And transient table, okay, maximum we can go up to 1 day only time travel. So we want to create a table, we want to give access to all our developers. Developers are creating dev environment 90 days. Then we will not give permission to create a permanent table. We'll give only transient database. They cannot create permanent table there. So they can create only transient. It will be available up to 1 day only. So that way they can reduce the cost. Development team, development environment, they will reduce the cost. Because everybody is creating 90 days. If they are not going to delete the data, so Snowflake will maintain that data for 90 days. They will calculate the cost also. To avoid that, they'll put database level restriction. Like database level also we can put restriction. Permanent 0 to 1 day only. By default, we'll create 1 day. If you want to overwrite it, we can overwrite it. So default table type is permanent. Okay. Designed for data, so that requires the highest level of data protection and recovery, then we can go for permanent. Used for data that needs to be persist but does not need the same level of data retention as the permanent table. I don't want to have 90 days in dev environment, whatever the table we are creating, time travel, just to create with transient. So don't go with permanent table. Temporary table persists only to that particular session. So something like we want to do the calculations, we can go for this one. Failsafe is applicable only for permanent table. There is no failsafe for temporary, transient, and external. There is no failsafe. For external external table, we don't have any time travel. So are you clear on the differences between these 3 tables? Differences. So have this particular table. You can find out what are the differences.
One question, Chandra, sorry.
Please go ahead.
On temporary tables, we said time travel is to 0 to 1 days, but it valids only to till session, right? Even
If,
though
if the session is available, okay, if you are keeping this particular session next to 24 hours, right? Then you can take the data 24 hours. Up to 24 hours, this will be available. If you have closed it, this one, this particular .sql file, you have closed it, whatever the temporary table you have created, so that will be dropped automatically.
So until I am in that session,
it will be
even though I
available
drop
for
the
24
temporary
hours.
table, then I can retrieve the temporary table. But
Yes,
if I close the session, I cannot retrieve. Okay.
yes, correct, exactly. 24 hours it will be available 1 day. But explicitly we can define as 0 day. Sometimes in interview they'll ask question, I have created a table. Okay, this is the interview questions. They will ask this way. They'll put it like a scenario. I have created a table. I loaded the data. Unknowingly, I have truncated that table. Okay. When I'm trying to retrieve back the data, it is showing that I couldn't retrieve back. What could be the reason?
Time travel is set to 0.
Yes, exactly. That's the answer. Okay. Explicitly, we set the time travel equal to 0. Then we cannot go back and then get the data. Truncate, undrop, all this option not applicable. Yeah, if we have enabled 0 day, okay, so this is applicable only for time travel. But still we have 7 days to retrieve. That we have to go to the Snowflake team. We can ask them. Okay, yes, I have said the time travel is 0 days, so I couldn't retrieve back. So can you please help me to take if this is a permanent table? For example,
Okay.
transient table we set it like 0, then no way to retrieve. That's it.
Noted. Okay.
That is the
Okay.
difference between these two.
Chandra, maybe irrelevant question here. So,
Mhm.
but for the 7 days, right? When we reach out to Snowflake, do they charge extra?
Yes, they will charge it. They will charge it.
Okay.
From our account, they will charge it. And this is applicable, right? 7 days we have, right? Permanent table. That is automatically, for example, today we are creating. Okay, it will go to 90 days up to. So even 90 days is over. Then 7 days they have to keep, right? Those files. For example, today I'm creating. Up to 90 days, it will not go to the fail state mode. Today I created one table. Then up to 90 days, it will not go to fail safe mode. After 90 days, 7 days, it will go to fail safe mode. For that, they will charge for the storage cost.
So for permanent tables, the failsafe is default. Though
7 days.
we even we don't opt for it,
We
Snowflake
have to
will
pay for
charge.
7 days storage cost.
Okay.
That is for data protection we'll do normally.
Within that 90 days, if someone drops that table for by mistake, that 7 days will also be not there, right? So how will you retrieve that actually? So this 7 days will only come into picture when the time travel exceeds 90 days, correct?
Yeah, correct.
But within 90 days, say the 30th day, someone went into the database and dropped this table by mistake.
Mhm.
So what will happen in that scenario? Like we cannot get that data anywhere?
We can get, okay. So what is the time travel you have enabled? Number of days. Just think.
Correct.
You created permanent table, right? You have enabled 90 days time travel. I'm just asking.
Yes, but
You have
yes,
enabled 90 days
time.
time travel. Okay. By default, it's a permanent table, right? By default, 7 days is applicable. For example, today we have created a table, right? Today we have created a table, inserted data. We cannot go back to yesterday's data because today only we created.
Correct.
Today only we created. Okay. Tomorrow, up to 18th we can go. And 20th, up to 18th we can go. Without this time travel also. Okay. For example, this one, 23rd, we created permanent table. Still we have failed safe. Even though we haven't enabled time travel. On 23rd, 1, 2, 3, 4, 5. Yes, we are in the fail safe. 24th also we are in the fail safe. 25th, 25th. 1, 2, 3, 4, 5, 6, 7 days. We can take on 25th. 26th day, for example, 26th day, I drop the table. Okay. I dropped wrongly. I have dropped the table. I haven't enabled this time travel also. Time travel, I put it like a 0 days or 1 day by default. Then I can ask if a Snowflake team, okay, can you retrieve the data what was there on 18th? So they will say, okay, 1, 2, 3, 4, 5, 6, 7. No, 18th we cannot take. Up to 19th we can take. What was there on 19th? So that they will copy it into one table. They'll say, okay, this is what the data we have on 19th we can take. But you have enabled 90 days time travel also. Then we can go something like, okay, 18th we created up to 90 days, 97 days, we can go back and then get data. So even after, for example, this table created today, April, May, June, July, then around July 20th also, 25th also, if we have dropped it, still we can retrieve what was there on April 18th. that we can take. We can
Mm-hmm.
go back and then get the data. It's like on that particular instance, what was there. So that we can take. But permanent table, so if you are select start from the table name, it will show you the current data only. Say for example, if I have updated multiple times this table, if I'm doing select start from the table name, it will show you the current data. But what was there previously? Is there any option in Oracle? What was there in previously? If we have updated it, if it is not SCD table, we don't have any
No.
option to retrieve, right? But Snowflake and Databricks, you can do the time travel. That is a feature of Snowflake and
Arguably one of the finest feature, I would say.
yeah, we have data cloning. That is option we have. So those are options we have. Okay, so far, the example 90 days is over. We can still get the data within 1 week. Yes, 97 days. After that, it will no longer be stored. The current data will be stored, but that particular days we cannot get it. For example, 1 year back, you have created a table. Think about 1 year back. You create 2025, you created a table. But we are at April 18th, today 18th. So I can go, this is April 18th, April, then March, February, March, April, right? February 18th. So just example I'm saying. February 18th is 3 months. Then 1, 2, 3, 4, 5, 6, 7. Up to January or February 11. Okay, think about January 11 or February 11. 3 months plus 9 days. Okay, it may be January. Yeah, January 11th. From today, I can go up to January 11th. I can retrieve back what was there. But before that, what was there, I cannot take. At that instance, I'm saying, okay, January 11th, 10 o'clock, what was there in the table? Okay, January 14th, 10 o'clock, 9 o'clock, what was there? January 22nd, 10 o'clock, what was there? Each update also I can get, but beyond that I cannot go. 97 days I can go. So today I have truncated a table wrongly. Yes, I can get. For example, in real-time project, okay, some deployment happened. Okay, on today. Before 18th, everything running fine, everything's correct. But some deployment happened. They did some logical error on the code. They deployed and it is running. And our customer is coming. Okay, today is like a Friday. They did not validate it. Something like a 17th it has deployed. 18th they did not validate. 19th they did not validate. Monday also did not validate. They're coming back on 21st saying that, okay, so whatever we have deployed, all the data corrupted. Okay, something like aggregation and everything corrupted, right? So if it is Oracle traditional database, we'll be taking backup of every day, the table, snapshot, entire table, daily backup we'll be taking. If data has been corrupted, if we have the backup, we can go back, take the 17th of backup, restore it on table, and then we can again completely truncate that existing table, correct the code, deploy it, and start loading for 18th, 19th, 20, 21st, right? That we can do. But here there is no need of going back to the backup table. We have time travel. Okay, something goes wrong on 18th. Okay, we have to retrieve data as on 17th and deploy the recode, correct code after logical error and rectifying it. And from 17th, you can run the job and it will load the data. So we can ask them to validate. So this feature is available in our Snowflake. I hope you are clear, but we will see practically here. We will create a permanent table, permanent database. I'll show you this option, whatever we discussed. Time travel we'll see tomorrow, but other options we'll see it. So we have seen 3 different table types, right? 9 table types. Out of that, 3 different table types as of now we have seen. So first of all, how to create a database, right? So we'll create one database. So create a database and then create a schema and everything we'll do. Just I'm going to create a database. Create database name. Or we can say it's a create or replace, right? So whatever the database we have, it will be replaced. So create database. So I'm going to create a database like permanent DB. Okay. Permanent database, or you can say it's simply sample DB, something like this, so that you will get idea. First, I'm creating one database. This is like a, if we are not defining like permanent, right? Create database name. That's it. So what type of database it will create? It will create a permanent database. Already exists. Or I'll say it's a retail DB. So I will create one DB like retail DB. So this one I'm creating. If already exists, if you are saying that create or replace, it will recreate the table, right? Database. Create or replace. So we can use this keyword also. Create or replace database name. So what type of database it will create? Permanent database. Can we use keyword like a permanent? Create or replace permanent database name? Is it possible? No. If you see, this is not a keyword. Permanent, there is no keyword. Like this, we cannot create. Syntax error we are getting. Okay, there is no keyword of permanent for table, database, and schema. So if you are simply creating a database, it will create permanent database only, right? So this is a permanent
I have one
database.
question in this actually. When you say create or replace database, what will happen if the database has schemas and tables already existing? Actually?
Everything will get dropped.
Oh, okay.
In
So
the
you have
same
to
name,
use it with
the entire database, it will get dropped. So this is like a drop and recreate. We are dropping and recreating it. So all the object will get, it will get dropped. But you want to retrieve back. Yes, we have time travel, right? What is the time travel we have selected? Based on that, we have to
right.
retrieve back. But what happens here, we already had retail DB on the same name, just we recreated it, the database name. So in that case, previous database name also retail DB, this name also retail DB. If you are going to do the time travel, which database it will go? The current one, right? Current one just we created now, 9:07 p.m. Then it doesn't have any time travel. Am I correct? In that case,
Right.
what we have to do, this retail DB, whatever we created now, that we have to rename it to something like retail DB1 or new, something like this. Okay, this one we are renamed it, retail DB into retail DB new. This time travel is just, we just created 9:07 p.m. It doesn't have any time travel before that. But the one we already had, this retail DB, right? So if we had like a 1 day time travel, still we can go and retrieve this retail DB. I created 1 DB here. If we create any database, how many schemas will be automatically created? 2 schema. What are those? Public schema and information schema, right? So these are the 2 different schemas it will be created. We just created this retail DB, right? So just to open it. So you'll see that information schema and public schema. Okay, so what is that schema also? It's a permanent schema only. Okay, so we can go and check show databases. So always if you use show, use plural name here. Databases, schemas, tables, that way. So just to use it. So how many databases are there? It will show you that all the databases. Control enter. We could see all the databases. Retail DB. Is it DB? It's a default one? No. Is it a current one? Yes, it's a current DB here. And so account admin who has created all this, we can see here, right? So what is the retention time? 1 day, standard table. So kind of standard table. It's nothing but permanent table. These are the options we could see. Okay, so now I'm going to create with one more schema. Create or replace or create schema. Schema name, retail underscore DB. So what kind of, sorry, retail underscore schema. So what kind of schema it will be created? Permanent schema. So we created a database, we created a schema. So if I'm going to create a table, we created a schema like create or replace schema name. This is like a permanent schema, right? Permanent schema we created. So if I'm going to create a table inside the permanent schema, just I'm just creating one schema like this way, customer table like this. Okay, this one I'm just creating. This is like a table, right? I can create a table like this, customer table. So if I'm going to see like a show tables. Sorry, show tables. It will show you all the tables here inside this particular schema. Retail DB, retail one kind of table. So we could see it's a permanent one, right? It's a permanent one. This is the table we could see. And what is the default time travel for this particular table? So it will inherit the time travel from the parent. So who is the parent of this table? Who is the parent of table normally? Schema. Who is the parent of schema? Database. So please remember database name dot schema name dot table name. So if we don't specify any time travel, it will take the time travel from the schema. If we don't specify any time travel from the schema, it will take time travel from the database. So what is the default time travel for the database? This database, 1 day. This will also have 1 day. This will also have 1 day. So you can go and check here. Data retention time. So 1 day here. Okay, so 1 means 1 day. Can we make it like a 0 days? Yes, we can make 0 days as well. So that we'll see in our tomorrow session how to make the time travel and everything. So this is the table. So can we use permanent table? Is a keyword like a create or replace permanent table. Is that any keyword? Permanent table. Is there any keyword like permanent table?
No, we don't have.
We don't have. Okay. So please remember, if you don't mention anything, by default create a permanent table. Okay, I want to create a transient table. Transient, right? So transient. Just I'm giving the naming convention with trans. It's a for naming convention to identify, okay, this is a transient table. Create or replace transient table, table name, I'm just creating. Where this table will be created? Inside retail DB, retail schema, right? So what is this retail schema? The permanent schema. This is permanent DB. Can I create inside permanent schema? Can I create transient table? Is it possible to create?
Yes, yes.
We can create. We can create, right? So we can create this particular table. It's a transient table. So now these two looks like a same kind of table. Why? Only one option is different. What is a different option? Only one option. As of this scenario, what is the difference between these two tables?
Transient.
No, transient, that's okay. But only one option is different for these two tables. Other than that, everything is same. What is that?
Time travel.
No, time travel also same. Time travel also same for both.
The fail over that one.
Fail safe.
Fail safe.
Okay. So please remember, if we created this way, only the fail safe is different. Why? Why? Because we can go to 90 days for this table, but we haven't enabled, right? We enabled just 1 day. We just taken 1 day. This one also will automatically take 1 day. Am I correct? So then where is the difference? Difference is fail safe. So we can retrieve 7-day fail safe here, but we cannot retrieve 7 days fail safe here. So that's the one difference here. Other than that, nothing else. Okay. So how do I know that, okay, this is like a transient table, this is a permanent table? Show tables. Just take this table and you can see we have customer transient, and you can see this is the option kind. So this is a transient table, but time travel, if you see, both are same only, right? Other than the fail safe, everything is same only. We don't have any other options. We'll see later. So whether it is a dynamic table, iceberg table, hybrid table, is event table, all this we could see, but other options we'll see later. And these are the options here: customer transient. That is the only difference now.
I have one question with the time travel actually. You said the time travel hierarchy is database, schema, and then table, right? So if you have a time travel of 1 day in the database, and can we give 90 days for the table? Because
yes, we can give. We can give that. We will see tomorrow. Time travel options we will see tomorrow. So if you don't specify it, it will inherit from the parent. If you specify it, we can overwrite.
That will override.
Yes, exactly. Database level, we can overwrite. Schema level, we can overwrite. Table level, we can overwrite. So that option is available. Okay.
Okay.
But if you don't specify, it will inherit from the parent.
Parent.
Based on the schema or database or it anything. Okay. So this is what we created. Can we create a temporary table inside this detailed schema? Is it possible to create temporary table?
Yes.
We can create, right?
Yes.
Temporary
Yes.
table. Okay. Just for example, temporary table. So I'm creating one table here, temp. So just to create temp table. So one day, yes, one day we can take, but only option is, so I'm going to show tables. How many tables will be there now? Show tables.
Three.
Three tables, right? So we could see three tables. Okay. Just I will open one more session. This is one session. I will open one more session here. I will connect to this database retail DB, retail schema. Okay. So now I'll put the same show tables. How many tables it will show?
2.
Why 2?
Because it's session based,
Session.
right?
Exactly. Okay. Exactly. It's a exact concept. Only it will show 2 tables, right? So why? Because that is session specific. Even if you take a new SQL, it will create a new session ID. Okay, if you go here, query history they brought into here, right? Maybe that's the reason we have everything here we have. And if you just open this one, show tables, session ID will be there. Okay, what is the session ID here? 2750 ending with, right? So now I'll go here. This particular session, I'll open this. What is the session ID here? Something like 510. Both are different. But if I go to this one, this create table or show table, something like that, if I'm going to take this one, session ID will be the same ID. Are you seeing that? Session ID. So if somebody else is login, then the session ID will be different. Even if we have log out and login, session ID will be different. Temporary tables is applicable to that particular session only. So even if you go and log out and log in this particular session, right? We could see only one table, sorry, 2 tables, not 3 tables. So now we are seeing that 3 tables because the session ID is same. If we log out and come back to the same data validation one, we could see only 2 tables. So inside permanent database, we created a schema that is permanent. Inside permanent database, can we create transient schema, create or replace schema, transient schema?
Yes.
Transient or trans schema, but we have to put create or replace transient. Transient. Is it possible? Yes, it is possible. We can create. Is it possible to create a temporary schema? Temporary, we have only table. Please remember, temporary, we have only table. There is no temporary database, temporary schema. We don't have. Okay, so unsupported features, these are the options we have. Okay, so inside, okay, if I'm going to create, this is a transient schema, right? Transient schema. Inside the transient schema, so this is the transient schema. If I'm going to create a table, transient schema, if I'm going to create a table, this table, something like cust table. Okay, so I'm going to create a table. So what type of table will be created?
Transient.
Can we create permanent table?
No.
Okay, so I'm not specifying anything. Just I have created a table. Okay, show tables. So this one, it will show you the tables. It's a transient table. So even though I did not mention that whether it's a transient or permanent, but default it has created with transient because inside the transient, I cannot create permanent table. Okay. Inside the transient schema, can I create temporary table?
Yes, we can create.
Can I create with the same table name? Customer temp.
Yes, I
Yes, we can.
Is because this is overall entire fully qualified path is different, right? So I can create temporary table. So show tables, it will show 2 tables now. So inside. So this is what we can see, the temporary table and all this. So I hope you are clear. Inside permanent database, we can create this one, and these are the options. This is like I will go to the permanent schema, permanent database. This one we created. So by default, what is the retention time? So 1 day. So can I create with 90 days? Retention time in days. Okay, so data, the option is after create table statement, once we have closed this one, so we can use this one, data retention time in days. So how many days I can go up to 90 days? It's possible. I'm just creating. So I'm just overwriting this table one. So data retention time in days, 90 days I can go. Is it possible to go with 91 days? No. Maximum 90 days. Is it possible? Permanent table. Okay. So transient table. Transient table. I'm just going to transient table. In the transient table, I'm using, okay, this is my inside permanent DB, permanent data, permanent schema. I'm just creating a transient table. Is it possible to create transient table with data retention time in days equal to 10?
No, not possible.
Why it is not possible?
Only 1 day is 1 day is
Maximum
allowed.
1 day only we can go. Okay. So if I'm going to create a transient table with 10 days, I cannot create. Even more than 1 day, I cannot do it. Okay, you can see. So 2 days, I cannot do. So by default, it's 1 day. Data retention time in 1 day. So that no need to mention, it will take 1 day, right? Is it possible to create with 0 days? I don't want any
Yes.
time travel. Okay. Is it possible to
Yes.
make 0 days here for permanent table? Yes, we can make permanent table 0 days we can make, and transient table we can make per 0 days, and temporary table also we can make 0 days. Okay, so nothing. It's not going to do anything here. Just it will not have any time travel. It's very similar to our Oracle table, how we have this one. So temporary table. I'm going to do the temporary table here. 0 days time travel. Yes, I can do. There is no time travel for temp table, transient table for this scenario. We have this way data retention time in days. But still for this table, we can retrieve 7 days because this table, permanent table, we have 7 days fail safe or enterprise edition. But this one, these two tables doesn't have any fail safe. So number of days we can create, we can put insert into data, show database, show schemas, and show tables. It will show you all the databases. So how many databases are there in this account? It will show you show databases. So we have these many databases totally. Okay, so 9 different databases we have in this account. So how many schemas are there within the database? It will show you all the schemas. And then database, sorry, tables, if you are showing, it will take this particular tables only. If you want to see all the tables, then we have to write some metadata query there. So that is something like a metadata tables query. So this one we have seen information schema. Yeah, this one information schema only. We can go and check all the tables. Okay, so this way, I want to see that all the database, information schema dot databases, it will take all the databases, information schema dot schema here. Okay, so you put schemata. Okay, this one. Then it show you all the schemas here. Retail DB, this one, current database, and tables also you can put. But here it will show you all kind of, in the retail DB, it will show you all kind of tables here, schemas and everything. So this way you can find. So even if you want to take all database and schemas and everything, we have to frame the query here. So that is metadata queries. Okay, we create a transient one. So then we have seen this one also, transient database, transient schema. Okay, so temporary table, just temporary table. Okay, we'll create one temporary table and then we'll log out and then we'll see so that you'll get clear idea. So now I'm inside the retail DB, retail schema, right? So I'm going to do this one. So I'm creating temporary table. Is it possible to create? Yes. And then I'm inserting set data here. I'm just checking here. So I could see 2 records. So I will go to the same one. This is something like retail temp table, right? Retail DB. So I'll put retail underscore DB dot retail schema dot this table. So I could see the data now. So I'm going to take the same one, Control C. I'll go to another session. I want to see that. Is it possible to see data? No. So we don't have this data at all. Okay, I'm going to log out. Okay, log out. I logged out. I will log in again. Okay, so log in here. I will log in again. And then I'll go to the same data validation, this particular workspaces. So I will try to open this table. Okay, because we were seeing the 2 records previously. So can I get this table? Is it possible to get? No.
No.
We cannot get it. Okay. So table or view does not exist. This is what we will get it error. But can I get this the other tables which we created? This customer temp we cannot get it. Customer trans and other tables. Is it possible to check these tables?
Yes.
Get those tables? Yes. So if I go to show tables, it will show you the 2 tables which we created. So one is table kind is table means it's a permanent. Table kind is transient means a transient table. And what is the retention time? There is no retention time. So there is no retention time here. So these are the options we have. So just to create a table, just to play with these table types. So you should be very clear. So what is temporary, what is permanent, what is transient, all this. Permanent, we can create a database, schema, and tables. Transient, we can create TB, transient database, transient schema, transient tables, and temporary, we can create only tables. Okay. So these are the interview questions. You will get it definitely. If you know, okay, now you are clear, right? All these types and everything, these table types. If they are asking any questions, you can answer them. So what is the keyword? Data retention time in days. That is the keyword here. We will see this option in detail in our tomorrow session. Time travel, fail safe, all this. So are you taking these quizzes? Just go to NICIT Academy here. So I will add more quizzes also based on this interview. Just go to materials, interview quizzes. Every now and then, please complete the quizzes. Okay, go to Snowflake and take these quizzes. Stages I put. So time travel, I will put separately here. Okay, so time travel and other options what we have seen, table types. Okay, so all these options we'll see one by one. But architecture 1 and 2, stages, internal stages. So please, when you have time, so please go through that and take the quizzes also. Okay, I will add more quizzes. So just to take that quizzes here. So whatever we have seen, so that you'll get clear idea. So when we are going to complete these quizzes are like, so after completing everything, you can take these quizzes. So it will be there all the not concept wise. So all this will be available here. Okay. So all the questions will be available. So 20 questions will be there here. Let us start our today's session. So we have already seen Snowflake table types, so different tables we have seen. So permanent table, transient table, temporary table, dynamic table. So external table we will see today, directory table, event table, hybrid table, and iceberg table. We will see one by one. So already we have seen permanent table, transient, temporary table, and dynamic tables, right? So dynamic tables, it's very similar to so how we will perform SCD logic. Same way we can do the dynamic table also. And we'll start with external table. So what is external table? So we have seen already external stage, right? External stage. Then what is this external table? So for example, this is Snowflake. Okay, this is our Snowflake, and this is our external stage. So then we are creating the integration, right? And then we are loading the data into Snowflake. So this one, just like a stage. So we have already created external stage. This is external stage. So we'll create external stage here and we'll place the file, and then from Snowflake we can access it. So now the similar one. So instead of external stage, so we are creating external table. Okay. So external table. So what is this external table? So we are creating external table inside the Snowflake. Okay. So here we are creating the table, but it will have the data externally, not in Snowflake. So for example, if we are creating any table in Snowflake, so all the data it will store here itself, right? But if you are thinking, okay, so we do not want to take this Snowflake storage, so we can take the data from externally. So we can keep the data externally and then we can access it from Snowflake. So how can we take? So either we can take AWS S3 or GCS, right? Or Azure storage. So whenever we are going for this AWS or GCP or Azure, so we can take the storage from this external platform, and then from Snowflake we can access it. So this integration we need to perform. This integration we need to perform. So we already seen, right? So what is the advantage of external table? So external table, so the storage it will take from the cloud platform, not from Snowflake. So that cost will be reduced. So if you are thinking that, okay, instead of Snowflake storage, okay, external storage cost will be less, then you can create this way. Another one is the stable access. Okay, so whatever we are creating the tables and everything, we have to create that integration and everything. So we already seen Snowpipe. External stage we have seen. The external stage we can load the data. So whenever we are making the file here, then copy into command. So we can load into Snowflake, right? Similarly, Snowpipe. Snowpipe is nothing but we are creating the automatic the pipe data pipeline. Then it will continuously ingest that file from external stage to Snowflake. So whenever the file is available in these three platforms, then it will send the file to Snowflake, right? But now we are creating the table here and we will access it. So to create the table here, the external table, so we need to perform all these, whatever we have done so far, like creating the role, creating the policy, creating the user groups, and everything we have to do. So first of all, we have to create AWS account. So that we have already created. Then go to this IAM, it's identity and access management. You can search from here, okay, the global search. Then go to IAM here. Then, so here now, this particular AWS account is 6-month account. We have 6 months account. We already created, right? Then the role we have to create and the policy we have to create, and user group also we have to create. Just to go to the policy, we already created the policy, the Snow policy to access this S3, and this is the S3 one. But if you see the policy we already created here, right? The policy and everything. And so normally we will take this JSON one, then whatever we have previously that we removed and copied this one, right? So here we need to put our S3 bucket name. So before creating this policy, we should have created S3 bucket. Then this is same process. You're not going to see any other process. This is same process, whatever we have seen already. So policy we have to create and roles we have to create. So go to this role. So already the role will be available. So you can add a new role. So create a new role. Like we created one role called snow role. So this is account number. Okay, so go inside. So while creating, this is what it will be there. And you can add this AWS S3 full access and snow policy. So whatever the policy we created, right? So those two policies we can add, and trust relationship, right? So this is very important. So this is the AWS ARN number and external ID. So these two ID, whenever we are creating the storage integration, there we can find this one. So we can take those IDs and we can update it here. So edit trust policy, we can update it. So this is the ARN details. Okay. So just to go to this role, inside the role, we can find this ARN details, right? So this is the IAM role. Then user, if you want, you can create one user and we can create user group also. Just to create one group, one user. So user is for accessing this particular account. That's it. So after that, so previous to this IAM, we should have already created S3 bucket, right? So go to S3. So here we created already bucket. Then I'll go to this particular any one bucket, no issues. So you can go to this bucket or any other bucket. So we already created these buckets, right? And we can go to this bucket also. I'm just removing. So whatever we have, just I'm removing these two folders. Even you can create a new folder as well. Okay, so inside this bucket, we have one folder, CSV. So just one file we have. Okay, so one file. So we have here. So this file, we will load it into the external table. Okay, so up to these steps you are clear, right? So first we should have created S3 bucket. Then from the bucket, we can access it. Okay, so S3, first we have to create a bucket. So give the bucket name. Okay, so and then you can go to the IAM. So go to policy, create a new policy and change this one to this one. But we have to update this bucket name. That's it. Then create a policy, then create a role. And so this is the account ID and role, just to create a new role. So normally this is the steps we have to follow. We should have already created. So roll number, external ID. Initially you can put some dummy ID. Then after that we can update the trust policies. Okay. So S3 full access we can take and this one. So we have already created this one, right? So now we will go and create the storage integration in Snowflake. So to create this particular external table, so we have to follow these steps. So what is this external table? We are not storing the data inside the Snowflake. We are storing the data outside Snowflake, and from Snowflake we are accessing it. That's a external table. So first we have to create normally the storage integration, right? So storage integration, whatever the steps we follow for the external stage, right? The same steps we have to follow. So storage integration we need to create. This is the storage integration. Go here. We will create one storage integration. So where we can create, so any database we can create. If you want, I can create a new database also. Create database name. So just I'm creating table types. Okay, just I'm creating new database, new schema. I'm just creating a new schema here. And here I will take storage integration. So create or replace storage integration. So this is integration name and type. So this is external stage. Storage provider is S3. and it's enabled. This is the ARN number. Okay, this is the ARN number and storage allowed locations. Okay, so where can I find this ARN number? Just to go to this IAM, the role. Okay, so here itself you can find the ARN details. So this is the one. So you can copy it. This ARN details, just to copy and paste it here. Okay. So if you have created different one, just to create it here. Then this is the storage where we are placing the file, where we are creating the storage, this external table, just we have to create it. I will duplicate this particular page. I'll go to S3 here. Okay, so we can create one more bucket also, that's fine. Or we can create this any existing bucket also. So inside the bucket, we can keep the file, or inside the bucket, we can create a folder. So there itself, we can create file also. So why we are creating the file? So that is the data file. So inside the CSV, this is the data file. So from this file only, we are going to access it. Okay. So what data is available here? So whatever the data here we have, so we can download it and then check. So what data is available, and we can upload. So if you want any other file, just we can upload the file. Okay, so everything is same. This is the bucket name. I'll go here, check this bucket name and the folder. If you do not want to keep the folder, you can remove it. Just you can keep only the bucket name, just to create the storage integration. This is normal process up to external stage, whatever we have seen. So that is normal process. Now, so after creating the storage integration, we have to describe the storage integration, right? So describe integration. So integration name, then we will get the user ARN details and external ID, right? So these are the details we'll get it. So from here, we have to copy this user ARN details. So whatever the ARN details we have, so just to copy it. This is user ARN, then external ID. So copy these two. Okay, this is user ARN. This is the external ID. And after getting these two details, go to this IAM, the role. This is the role we created, right? So go inside and trust relationship. So go to this trust relationship. So we have to update this policy. So go here, and this is the ARN details. ARN details will not change actually. So once we create it, it will not change, but the external ID will change. So copy this. We can update one more time, no issues. Just to go here and paste it here. And again, so take this external ID, copy and paste it here. The external ID will change. Yeah, change, right? So update it. So then only the Snowflake, so whatever we have taken this ARN from AWS. So after getting the AWS ARN details, so we have to get Snowflake ARN as well as Snowflake external ID. So this one, whatever the Snowflake is creating. So that we need to give it to the AWS. So that's what the connection we are establishing, because it's a very secure connection we have to take, right? So that's why we are creating these IDs. Okay, we already created this one. So then we can create the stage. So to create a stage, so we can use the file format. If you want, you can directly mention the file format. If you have any date inside the file, so we can make this file format also. So what is the file format? So create or replace file format. It's a format name and type equal to CSV And field delimiter, if you want to make, yes, field delimiter also we can make. It's a comma delimiter only, right? And header we have S1, we can skip it. And this is the one, okay? That if you have any date column inside this file format, the file CSV file, you can mention the date format also. So this is nothing but it's a file format we are creating. So after that, we have to create an external stage. So this is the external stage we are creating. Create or replace stage name, URL equal to this is the S3 URL details, storage integration. So whatever we already created here, right? So this storage integration and file format is the file format. So directly we can go to this stage. So whatever we need a stage to create as external stage, we need storage integration and file format, right? So file format directly we can mention here, but since we have date column and everything, so just I have taken separately created. So now I will create external stage. So list down this external stage. So whatever the files are available, so we can check it here, right? Okay, this is the file is available. Okay, one file is available. So even if you want to check the file, you can put the $1, $2, that command, right? So select this one, right? Whatever we have already, so that we can put it here and we can check. We put already, this is the CSV, then it will go here inside the CSV. It will list down the file columns. Okay, first column, second column, third column. So whatever we have, so we could see the data, right? Could see the data here. It means we are able to access the external stage. So now we can create external table. Okay, up to this, whatever we have seen so far, external stage, then we will use the copy into command, right? So copy into command, we will create a table inside the Snowflake, then we will copy it from there. And even we created a snow pipe. So whenever we are placing the file, and then automatically it will ingest, right? Snow pipe we have seen, and SNS service, SQS service also we have seen. So how it will automatically ingest the file, right? So, but now we are going to create external table. So what is this external table? So this is what we are going to see, that external table. Okay, just we will create one external table without having the column defined. Okay, just we are creating external table. So how to create external table? We already created stage, right? So normally previously what we are saying, create table, table name. Just we are making the table name T underscore EMP underscore stage. Then we'll create all the columns. Then we'll put copy into command, right? So after creating the table, we'll use copy into and we will load it. But now we are not using this because so we have the external stage, then we are loading the data into Snowflake. Then the Snowflake will hold the data storage, right? But now we are not going to hold the data in Snowflake. So we are going to create a table here. Only table structure will be there, but it will access the data from this external stage. External stage, whatever we put the file here, so we can access it from here. Only the table structure we can maintain in Snowflake. So whenever we are querying this particular table, we'll go and take the data from external stage. So whatever we are keeping the file over there. Okay. So how to create external table? This is the syntax. So create or replace external table. So keyword is external. External table, the table name with the location equal to, so whatever we created the stage. Okay. The staging with the location equal to the external stage, file format, CSV file format, refresh on create equal to true. So what is that meaning, right? Refresh on create. So while creating the table, if we have more number of files, just we are refreshing it. Refreshing means while creating itself, it will load the data into the table. If you are not mentioning that, so we have to refresh it. So then only it will load the data. So now I will go and create this particular table. Then the table has been created. Where? Snowflake. But we can access the data from this table. So if I'm going to run this particular query, right? So it will fetch the data from this S3 bucket and display. But how it will display? It will display with variant data type. So each column, this is the way it will display. So you can see this one. It's very similar to how the JSON file looks like, right? So it will access the data in this file like this. So you can see here, this is what it will display. But if you want to check the column name, so you can write the query like this, $1, that is nothing but column one, $1 C2, $1 C3. This is the way we can access it, the data. So this is the first one, second one, third one, fourth column. So all the data we can access it this way. But this is one single variant file it will store. But we want to make it like a table. So with defining the column, okay, this is nothing but employee ID. This is nothing but first name, last name, email ID, phone number. Okay, so all the columns we have to define in this way. Then we can create with the column name the same table structure only. So we can mention that this way. This way. Okay, so these syntax we have to remember. Create or replace external table. This is a table name. We have to define the each column. So first column is nothing but C1. It's nothing but employee ID. It's a number data type. C2, it's a column 2. It's a first name, last name, email, phone number, hire date, job ID. So I have taken all three different data types. Number data type, it's a varchar data type, and date data type. So whenever we are taking the date data type, use this format conversion. Okay, so we are informing Snowflake that so whatever we have data in this format. So 2_date, this is the format we have. DDMM4Y. Yes, that's a format we created, right? Already file format and everything. So we can keep the same file date format, job ID, salary, commission percentage, and manager ID and department ID. If you do not want, okay, so we have 100 columns. You do not want all the 100 columns to be loaded into the table. No need to create all this. So whatever the column number we need, so that column number you can mention that. So it will map to the respective column here. And then after that, we have to create location. This is the external stage. So if you have inside external stage any other folder, then you can put the slash also. So pattern. So if you have multiple files inside this one, then you can mention the pattern, or you can no need to mention the pattern. Okay, so normally we'll put this way. This is the file format. Then file format is CSV. Just I will create this table. So table has been created. So now I will access this particular table. Select, start from this table name. Then we can see this table. This is the column. Okay, so this value by default it will be available. So if you are using select star from external table, then definitely this will be available. So if you do not want, then take only the column name. Okay, if you want only employee ID, so employee ID, comma salary, comma department ID, then we can mention that all the column names from this external table. So we will take only those columns. That's it. This is the file. So I'll open the file. So here I put the data. So I will remove this one, or I'll remove this one. So instead of this one, 227, this one, I will put one more record, 300. Just I put, this is the one, Control S. This file, we will upload it. Okay, so now some process has uploaded this file into S3. So think about, this is the file we have. And I'll copy this. I'll go to S3. Okay, I'll upload it. So one, I'll go here, I'll add files. So it will replace the file, right? So whatever we had the file, so it will replace. So now, so we replace the file, right? So now I will go and check this data from this file. So whether we will have this file data? No, we have this 207, right? It is not there. Is there any 300? So we have this. So when we put, waits auto refresh. Okay, so now it has loaded, right? So maybe we already created a SNS service, but if it is not loaded here, you can refresh it. Okay, so we have to refresh it always. So since we have already created this, you remember we already created this SQS service, right? SQS or SNS service. That's why it has already refreshed it. If you haven't created any services, you can mention that alter external table name refresh. So this is manually we are refreshing it. So if you refresh it, so then if you go and check now, this will be available. So whatever we have added newly, so that will be available. 207 has been removed, right? So this way we can check this external table. So where the data is present now. So even if you are taking 1 terabyte or any storage, S3 only it will charge. So if you are thinking that, okay, S3 will be very less cost when compared to Snowflake storage, then you can take S3 storage itself. Yes, we can take external table. So if you ask me whether we will use external table in our real-time project, yes, we will use it. So permanent table, that is the default table. Whenever we are creating the table, yes, it will be there. And transient table, so we will not have that fail-safe option. And time travel will have one day, only one day, all this, right? Then temporary table, particular to this particular session. So if we are creating any stage table or any temp table to join it, so we can use this temporary table. External table we have seen now, external to the Snowflake, and dynamic table. So dynamically it will get updated. So whenever the data get updated in the source table, right? So these are the tables we have seen. Welcome back. The next topic is called constraints. So in Snowflake, the way the constraints will work, it's a different than our traditional database. So normally if you take any database, so how many constraints will be there? So we have primary key, right? So you'll have the primary key, constraints will be there. So primary key, so unique constraints, not null constraints, and check constraint, foreign key, right? So foreign key constraint, and sometimes we'll say default. So if you take Oracle database, we'll say default also sometimes constraints. But default is not a constraint. If we are not giving any value to a particular column, then if you want to pre-fill that particular value, then you can use this default constraint, right? So here in Snowflake, we don't have this default as a constraint. Okay, so default is like we can give the column, then check also it's not there. Okay, so we have 4 constraints are available in Snowflake. So what are those 4? So primary key, unique, not null, and foreign key. So if you take Oracle database, if we define a column as primary key, so in that column, it will not allow duplicate, right? And unique also this particular column will not allow duplicate. So not null means it will not allow null value. Foreign key, it's like integrity. Okay, so we can go for integrity constraint. We are giving relationship between 2 tables. So if you are creating a foreign key, it should be a primary key in another table. But here in Snowflake, so we have this constraint is applicable in 2 different tables. Okay, so one is standard table, another one is hybrid table. Okay, so the way it is working for standard table is different, and the hybrid table is different. Okay, the primary key, if you go to the standard table, so only this not null is enforced. Okay, so not null is enforced. So other keys are not enforced. So please remember. So just we are saying the standard tables. Okay, so standard tables, normal tables. So whenever I'm defining a not null column, then only that not null is enforced. So primary key, unique key, foreign key, all these constraints are not enforced. So what is the meaning of not enforced? So we can create a constraint. Okay, so we can create a constraint and it is not enforced here. Okay, so it means, so if you are creating a column as primary key, it will accept duplicate. This is what the 4 constraints we have. So here if you go to the tables, so standard tables, these constraints are optional. Okay, just for metadata, we will keep it. And we will not keep for, okay, so uniqueness, okay, if I want to maintain uniqueness, all this, we will not use it. And if it is hybrid table, if we are going to see later, like up to 4 table types we have seen, remaining 5 table set types are there. So we'll see that all the table types one by one. And hybrid table we are creating. So this particular primary key is required. Okay, it's a mandatory. We have to create a primary key for hybrid table and it is enforced. Okay, so here it is enforced. And all the keys are enforced in hybrid table. So hybrid tables like foreign key, unique constraints, not null, everything is enforced. But these 3 are optional. So we may create or we may not create. But if we create it, it is enforced in hybrid table. But in standard tables, you can see only this not null constraint is enforced. So what is that meaning? So we'll see that. So I'm just creating a table without any constraints. Okay, so without any constraints, just I'm creating one table. So I'll go here, I'll take this one. So I'm just creating this particular table employees. So create or replace. So nothing is there, right? So here I'm just giving default. So default is like, okay, if I'm not giving any value to this first name, so it will take automatically this one, right? So I'm going to take this one. So it will create. So if I'm going to have duplicate value for this particular column, will it accept? Yes, it will accept. So I'll go here. So I'll go to this. I'll insert some data here. So insert into this table. So I'm using it. So this one first name is default, right? So I'm not going to give here. So just I'm going to give null. So null means I'm not giving any value. So in that case, what will happen? We'll see. So second one I'm giving. So null. So don't give null inside quotation. Okay, quotes. So if you give null inside quotes, it's a value. NULL, it's a character. Okay. So just I'm going to create this particular table with duplicate data. So will it create? Yes, it will create, right? So then what value it will take? So for this first name record, then I'll go here. So I will select this way, select star from the table name. So employees, right? So here, okay, so here it is taking null because I gave this column name that null. So that's why if you are not mentioning this column name, then it will take. Okay, this column name itself you are not mentioning, just you are giving only 4 values. Okay, so I'm not giving this, just I will remove it. Who records inserted? So then it is taking this default value because I did not give this value, right? This particular first name I did not give, so then it will take default. If you describe the table, so DESC describe table name, so you can find all the so default and everything. So what is that? It's a table, it's a column, then it's a nullable. Yes, nullable. And default is okay. This first name I have given default. So primary key, no unique key, and this way we can check all this. Okay, so this is the way we can check the constraints, right? Okay, I will go here. I will check. Okay, so this one also show primary keys. So these statement also I can execute. Show primary keys, no primary key. And in this particular schema, is there any primary key? No. In this particular table, do you have any primary key? Okay, in this entire database, we are checking. Entire schema, we are checking. Entire table, we are checking. So whether we have. This is particular about table. This is particular about schema. This is entire database. Okay, so this way we are checking. Now, so I'm going to create primary key here. So these are some create table statement only. So that's why I'm copying it. So create or replace table name. So when we are creating, we can define the primary key. So this way. So this way we can take the primary key and then it will take. So if you go and execute, and if you are checking the primary keys, yes, which table we have in this particular database, this one. So this is the primary key and constraint name. So it is taking automatically the constraint name. So why it has taken automatically? Because we did not give any name, right? So even in Oracle database, if you go and check all underscore constraint, so it will have some constraint name. But here, since we have cloud, so we may have huge volume of data, right? So all this. So to give unique name, so they created this way. Okay, alphanumeric number. So this way, even if you have millions, billions of record multi-tenant, and definitely this constraint name will be unique. This way, they have kept, okay, this might be this particular account ID. Then they will keep some values here like this. Okay, this way. In this particular schema, so do we have the constraints? You can check it here. Yes, in the test. Okay, this is test schema. So I have to check core DB, core schema, right? Yes, I have the constraints. So here table level also I can check one single table. So I will go and check here. So this is what we can check the constraints. Okay. So here you can see employee ID nullable no, primary key yes, right? So we cannot give null value because whenever we are creating a column as primary key, so it will take that way. So not null. Not null also, not null is enforced. So here and so you can create with table data. So normally if it is in Oracle database, will it allow duplicate record? So if you have primary key, so I'm going to give some duplicate record on the table. Will it allow? No, right? So but here it will allow. In Snowflake, it will allow to accept the duplicate records. So please remember, even though if you have primary key, it will allow duplicate records. Then how can we do the deduplication or I want to perform? So how can I ensure that, okay, this table doesn't have data? So then we have to go for some workaround only. So by default, primary key will not add not null constraint when we create a column, right? So if I'm going to do with, okay, it's this way, insert into employee ID. So I'm passing null. So what will happen? So will it accept? We'll see. So DML operation to employees table failed because null result a non-nullable column. So by default, it will not enforce. Okay. So we can create a column with primary key. So then it will add a not null. Okay. So it will by default not null. Yes, definitely not null means it will not accept null value. Okay. Primary key will always, it will create a not null and unique, right? But unique anyhow, it's not enforced. So both combination you have. So how many primary key we can create in a table? So only one. So only one primary key we can create in a table. So you can see not null is enabled, right? Enforced. So not null key is enforced here. Not null is enforced. So even we are creating a primary key, if you are not giving a column ID or if you are giving a column ID and null value, it will not accept. So because primary key not null is enforced, but duplicate it will accept. Can we have multiple primary key in a table? So one more column as primary key. Is it possible to create? So just I'm creating employee ID is primary key. Here I'm creating department ID also. No, it will not accept. So it cannot accept more than one column as primary key. So this employee ID is primary key and this way. So if you want, you can create a composite key, but composite key also we can create, but not enforced. So composite means primary key of multiple columns. So that way we can mention that composite. So here I will go with, so I already created a table. Okay, I already created a table without primary key. So can we create a primary key after that? So for example, if you are creating it, so if you insert some data, if it is Oracle table, if you insert some data, first I created a table. Okay, I created a table, inserted a data, some duplicate data inserted. So if I'm going to alter the table with primary key, will it allow? No, it will not allow because it has the duplicate record, right? So, but here in Snowflake, we'll see. In Snowflake, the primary key is not enforced. So if I'm going to alter the table, alter table name, add constraints. So here one advantage is we can define the constraint name. So if you do not want to give this as a constraint name, if you want to define a constraint name, so you can define the constraint name, alter table name, add constraint name, primary key of employee ID. So I already created a table. It has duplicate record, but I created a constraint. So if it is Oracle, it will not accept, but here it will accept. Okay. So here it is creating primary key. So Y and primary key of employee ID. I'm creating a table. I will alter it. I'm adding a primary key. So in this way we are creating, it is accepting nullable. See here nullable is yes, right? So here it is accepting nullable. So even though I'm creating this employee ID as primary key, so here it is accepting as nullable because we are not going to use this primary key and all this in Snowflake. So even if you have duplicate record, I will tell you some workaround. If it is a staging to, if it is file, okay, if it is file, you are doing it. So select distinct and then load the data. But you have already duplicate record in the table, then normally we will create some workaround. Okay, if you are thinking that this particular table we may get duplicate record, so normally we'll have two tables. First we will stage the data into one table, then we will select the distinct record and we'll create one more table, final table, core table, like work table, then core table. So work table will be a temp table, so that particular instance it will have, and from that table we will take the data to final table. So then you'll have the final table here. Okay, show primary keys, so it will show you the primary key. So this way we can create a primary key. So can we create more than one column with primary key? Yes, so we can give. So this is nothing but composite key, right? So I'm just replacing the table. That's why it is replacing the existing table with this new table. Okay, employee ID and first name. So if you describe the table, if you are creating with this table create table structure, then it is creating not null, right? But if you are altering it, it is not enforcing this null value. So now the combination, normally why we are creating a composite key, because this combination we should not get any duplicate on the table, right? But here it will accept. So even though we are having the duplicate, so definitely it will accept here. So primary key, yes, first name, the employee ID we have. Okay, this is a constraint name, automatically it is creating, right? So everything. If we created a constraints, and how can I delete the duplicate record? That also we'll see. So I'm going with unique. So unique also here it is not enforced. Just for metadata purpose we'll use. I'm just creating here. So unique constraints is on employee ID. So I will use duplicate record. Then it will accept duplicate. select star from employees, right? So we can check. So now you can see the duplicate is available. So it is not enforced. And unique key is not enforced. Yes, correct. So unique key also you can have composite unique key this way. So then it will accept duplicate. So not null. So not null is enforced. So I'm just creating a table. So here, and just I'm going to create or replace I put. So first name is not null. So here I'm giving null. So this is don't use within single quotes. If you use single quotes, then it is a character. Okay, it's a value. So this will not accept, right? This will not accept because first name is not null. Okay. So I executed 2 records. So select star from employees. And so since it's a one single statement, we got the error. But if I put, so here I'll put some value. Okay, single quotes. Will it accept now? Yes, it will accept because below null is not a null. It's a character, right? We can execute this one. So it's a character. It is not a null. Null means it should be like this. Okay, like a disabled one. But here it is null means it's a value. So this way null is enforced actually. In not null is enforced in the Snowflake. Okay, so how to delete a duplicate record in the table? So duplicate means if I have 2 records, 3 records, I have to keep at least 1 record. We have to remove the duplicate. Okay, we should not delete all the records. That is not a deleting duplicate record. So here 101 is duplicate. I'm just creating it. Okay, even if I have primary key here, so it will accept duplicate, right? Primary key. I'm going to create and I will insert the data. I will select it. So I have the some duplicate record here. So it may be the full row duplicate or duplicate on the employee ID. So how can we remove the duplicate? So we can select a distinct record, right? 6 distinct all the columns from the table name, and we can create one more table. That's it. So normally this inserting will be on the some work table, temporary table. Then we will perform merging the data. Okay, so we will select distinct and merge the data into the original table. Then even sometimes we can go for swapping also. Swapping means, for example, this table, employees table has duplicate, right? So I'm creating one more table with employees deduplication. So create employee deduplication as select distinct star. So yes, we can use distinct star here in Snowflake. So if you use distinct star, it will remove the duplicate, right? So that way you can create one more table. So this is the way we can eliminate duplicate in Snowflake. Or we can use some other method, some rank method, row number method. Okay, so that or we can go for CTE. Some with class we can go for common table expression. So that way we can use some temp table and then we can create it. But here, just if you select it, this table, employee deduplicate, it will not have any duplicate, right? So after that, you can swap these tables like this. Alter table swap also we have seen right already. Swap, if you see employees table, now it will not have any duplicate. This way also we can do this table do deduplication in the Snowflake. So if you ask me how we can perform some table do duplication, this is the way we can do. So or we can go for one more method is called overwrite. So what is overwrite, right? So I will create the table one more time. I'm just replacing the table. It doesn't have any data. So I will insert some duplicate record here. Okay, inserted. But I'm just one more insert I'm executing. So if I check here, you can see this is the data we have duplicate. But we have overwrite is the keyword in Snowflake. Insert overwrite into employees, same table, select distinct star from employees. So within the employees table itself, I'm selecting distinct record. Then I'm overwriting into the same table, employees table itself. So if you have huge volume of table, then don't do this, because if you are doing it again, it will take more computation, and it has to perform all the records, right? Whether it has to check it here. So now it'll go for, you can see there is no duplicate also. Or you can go for some rank or row number method to do this deduplication. But don't use this way. If you use this way, then it will remove all the records. For example, I'm just inserting the record duplication. So 101 duplicate, 102 also duplicate. If I go and execute this one, what will happen? So normally in Oracle, we'll use row ID to delete it, right? So, but here we don't have any row ID. So row num function we have row num, and we have the rank. Maybe later we'll see. So that method we can use. Okay, rank method. Those are like SQL statement only. So here we have the delete from table name employees, where employee ID in. Just we are checking here whether we have the duplicate or not. Count of star greater than 1, right? Group by. Yes, we have the duplicate. 2 records we have. 101, 102. But if you are selecting the employee ID and so deleting here. Okay, so I will use 103. Okay, one more record here. One more record. So one record, right? So I will use having count of star 1. So you have this one. So this will delete whichever we have 1. That 103 it will keep. But 101 we have to keep one record, right? We have to keep one record, but this will delete. Since we have the duplicate on these data, it will delete these 2 record also. It will keep only 103. So because 103 doesn't have duplicate, so it will keep that record alone, remaining all the records 102, 103. So these 2 records will get deleted. But this is not the best method. So if you want to delete entire duplicate, even if you do not want to keep one record, you can do this way. So if you want to keep the record, you can use these 2 methods. So even if you use row number this way, it will delete matching record also. This is similar to this one. But the above one you can do. Normally we'll go for some temp table. We'll select distinct, and these 2 methods we will use it in real time project. If you are thinking that, okay, we may get duplicate record while fetching the data from source, or we have to do we have already data in the table. So we have to use something like overwrite method, or we can keep this some workaround. Okay, selecting the distinct record and merging it here. Okay, so even you can perform some joins also. Stage table and final table you can join, and then you can find whether we have duplicate, and you can do that way also. Okay, so this is the way we can perform the deduplication. Sometimes interview they will ask, so whether this table has primary key, foreign key is enforced here. In Snowflake, no, it is not enforced. Why? Because they are keeping all the data in the file, right? So that's why. So zero copy cloning. So what is cloning? So here cloning is nothing but, so we have seen already, so how to create a backup, right? So we have seen that, so how to create a backup. Create a new sheet, the SQL sheet. So I'll connect to the database, okay? So this database, the schema. So I connected to the database and connected to the schema. Okay, so we have seen already, so how to create the backup. So backup is nothing but, okay, so I want to create a backup. So this is the Snowflake that we have. So first we have to understand, so what is the difference between backup and cloning, right? So here we have Snowflake. Okay, this is Snowflake. So within the Snowflake, we have three different layers, right? So we have cloud services and processing layer, query processing and storage layer, right? So we have the storage layer also. So this is the storage layer. So what will happen if we have the table? Okay, so if we have the table, then if you are taking that backup, so I will take one table here. Okay, whenever we are creating a table, for example, we created a customer table, right? So here we created customer table. So multiple tables we created already. So whenever we are creating a table, so where the metadata will get stored, it will get stored in the cloud services layer. This is the cloud services, right? So we have the cloud services and this is the storage layer. This is cloud services layer. So in between we have query processing. That is the compute. So we have, right? Yes. So here, whenever we are creating a table, for example, I'm creating a table called customer, the metadata will be stored here, right? The metadata. So all the metadata information will be available here. So metadata will be available here. Metadata means, okay, create table, table name, all this, the statement, right? The statement will be available here, customer table. So when we are inserting the data, so where the data will get stored? So the data will get stored in the storage layer, right? So this is what the storage. So that time only it will take the storage cost. Yes, this is the storage. So this is nothing but for whenever I'm creating a table, customer table, so it will have the storage here. It will have the storage, right? Yes. So this is a separate storage. So I want to, so all the data, so whenever I'm inserting the data, so it will get added here. So I want to create customer underscore backup table. Okay, so one more table I'm just creating here, customer underscore backup. It's a backup. I'm just creating backup here. So what will happen? Customer underscore backup. So if we create a backup table here, then Snowflake will create. So here, this is the backup table. And here it will create one more storage, right? So definitely it is taking the backup. So if you are taking, for example, this table is 2 GB, then again, it will take another 2 GB. So here we are taking the backup here. Just we are taking the backup of the table. Okay, this is another 2 GB. So example, I'm saying this is 2 GB. If we are creating, so this will take another 2 GB of space, right? This is normal backup. So how to take the backup, that I will show you. So we'll see that. And so how this data will be stored in this database, the storage layer, it will take micro partitions. So micro partitions means, so this is one partition, this is another partitions. So like this, my micro partitions will be created, multiple levels, okay, based on the volume. So based on the data, it will create micro partitions. So entirely 2 GB. So out of that, it will create multiple micro partitions. So this is like backup. So whenever we are creating a backup, right? So instead of creating a backup here, so we can go for zero copy cloning in Snowflake. So we have one option called zero copy cloning. So what is this cloning? So cloning is nothing but again, the similar way we are going with all the three layers. Okay, so here also we have the three layers. So cloud services, compute layers, and then storage layer. So when we have the table called customer, right? Customer, the metadata will be stored here. Metadata means, okay, the DDL, so all this will get stored here, customer table. And so this is the storage, right? In the storage layer, it will create this way, okay? So this way it will create micro partition storage. So here I'm going with customer table. This customer table, so we'll create, so this is a customer table. I will take customer table, okay? So this is micro partition storage. So micro partitions, it will create micro partitions. So many partitions you can go with micro partition. Okay, just we are cloning. Okay, so cloning. So if the customer table has 2 GB of space, okay, so for example, here I have 2 GB, then it will occupy 2 GB space here, right? Yes. So here we are creating a cloning. Okay, so here we are creating cloning here, customer underscore clone. Just I'm creating one table here. That's it. By using the cloning concept. So customer underscore clone. So if I create the clone table here, so what will happen? Snowflake will not create one more storage. So it will share the storage here. Okay, it will create only metadata. Okay, this particular definition alone will be stored in this cloud services layer. So it will share the storage. Okay, the same storage will be shared. So multiple micro partitions will be available. It will share this particular storage. So this is like a storage here, right? Yes, this is the storage. So here we have the storage and this storage will be shared. So we have multiple micro partitions. We'll call it as micro partitions. Okay, so we can go with micro partition 1, micro partition 2. So this way we can have multiple micro partitions. Okay, so this is micro partition. So micro partition 1, micro partition 2. So this way you can have multiple partitions. So Snowflake will do that. Okay, so we are not going to do. So compression, micro partition, everything Snowflake will take care. So 3, 4. So in this way, Snowflake will create micro partitions and then it will store the data. So this is what it will happen. So at this particular instance, for example, today, 1913, I'm creating the customer clone table. So if you are creating backup, what will happen at this instance? So whatever the data is available in the customer table, it will create customer backup table, right? Then after that, if you are changing customer table, will it reflect here? No, it will not reflect here, right? If you are doing any changes in the customer backup table after creating the backup, so here if you are doing any changes, will it reflect here in the customer table? No, it will not reflect. Similarly, here also. So we have cloned this table. So after some time, if we are doing some changes in the customer table, then it will not reflect on the customer clone table. So whenever we are creating any changes in this particular, if we are changing any partitions here, so this data we are changing, this will not reflect for customer clone. So if we are creating any changes for customer clone table, so it will create a separate partition. Okay, Snowflake will create a separate partition here. So it will create a separate partition here. So there it will make the changes. So even later point of time, if you are deleting the table, dropping the table, if this table, we are dropping it. Okay, so customer table, we are dropping it. So what will happen? So whether the customer clone will be available or not. So customer table I'm going to drop because it's sharing the same storage. Will it be dropped? No. So if we are dropping this table, then this metadata, this alone will be dropped. Storage will be maintained as it is. Okay, even we can go for some time travel also, right? We have dropped today, but we have 90 days time travel. So anytime we can undrop it. So that time, yes, definitely we have to take the original, the previous version, right? So then it will keep the storage here. Anyhow, it will not delete because it is this storage is shared by customer clone table, and then it will be available. So it will support if the data get changed, then it will create a separate partition here. Similarly here also, if data get changed, then it will create a separate partition. So here it will create a separate partition. It will keep the data here. So this is the way Snowflake will do the cloning. Snowflake will do the cloning here. This is the cloud services layer, is the cloning layer. Okay, so we will see that all the options here. So just I'll go here. So if we do cloning, so what will happen if you do zero copy cloning? It creates a metadata pointer alone. Okay, so metadata pointer. So metadata pointer means if we are cloning this particular table, so this metadata, so here we have the metadata. So metadata means it will have DDL, all this information will be stored here, right? Okay, so this metadata alone will be pointed. Okay, so it will make the point here, and then it will tell us that, okay, this is the data and no physical data. So sometimes interview, they will ask this question, no physical data duplication. So if you ask me whether cloning will support time travel, yes, definitely it will support the time travel. So we have to enable the time travel options. So for cloning, or for the base table as well. So it will support time travel also. So it supports time travel also. Okay, so we will create, first we will create a backup and we will understand that. So what is it? So when we are creating the clone, so what objects we can clone? Okay, so this is the statement. Create object type. Okay, so which object I want to create it. For example, create table. So object name, right? So we'll create object name. Just we can use clone. Then from which table? Okay, the base table. So this is the syntax. Okay, for example, I want to create a table. So create table, table name. So I want to create a cloned table name. Just we can mention clone from which table. Okay, so just we should not use from here, just from base table. So this way we have to create a clone. So what are the different object we can clone? So we can clone database. Okay, entire database object we can clone. Okay, so entire database we can clone. So we can clone entire schema, just one schema we can clone it. So we can clone a table. So we can clone a views. So if you have any views, so we'll see that views later. And materialized view also, sequences and task. So we can clone task also, and we can clone streams also. Okay, so these object we can clone. So if you have multiple object within the database, for example, we have the tables, right? Stages we have. And please remember, so when we clone these object, entire database we are cloning. If the database contains temporary table, okay, so temporary table and stages, okay, stages cannot be cloned, okay, so it cannot be cloned. So please remember, so temporary tables and stages. So any temporary tables, because temporary tables is particular to that particular session alone, right? So we cannot go beyond the session. So temporary tables we cannot clone, stages we cannot clone, even if it is a internal stages, external stages, named stages, any stages. So we cannot clone it. Okay. So we will do that and then we'll try cloning. Then we'll see. So I'm going to create, okay, here we have the stages, right? Named stage we have. So named stage one we have. And just I want to create a temporary table here because temp table is not available here, right? So I'm creating one temp table. This is permanent DB only. I'm creating. So create temporary table. So table name. So I will use something like customer underscore temp, open bracket and close bracket. So we can use customer underscore ID. It's a number data type. Okay. So number data type. I can use this way. And I'm just creating the table here. Okay. So where we are creating this, I'm just creating. So temp table. So I'm inserting some data. So insert into this table, customer underscore temp values, customer ID. Just I'm using one ID alone. So you can go for multiple insert also, right? I'm just using. So if you are doing that, select star from the table name, select star from customer underscore temp. Then this is what we have the data. Okay, so we have the temp table also, right? So if you refresh it, you will get customer underscore temp also. So yes, we have the temp table. So we have one record here. I want to clone entire database. Okay, so I want to clone so entire database. So how can we clone? So we can mention that, okay, so create database. Okay, database name. So I'll go with the database name, core schema, right? Core underscore cloned DB. So this way I want to create entire database. So we have entire database, just I want to clone it. Create database name, clone is the keyword. So from which one? So we want to create from core DB. So just I want to create it. So for example, in the real-time project, when we are doing some testing, so we have some testing we want to perform. It's nothing but, so we have one database. Okay, so here we have one database, but I want to do some testing. So something like ML model, I have to train it. So I do not want to disturb this production data. So because it's there, and I want to create a separate database. There I want to do all these operations. So I do not want to give access to this particular database. So I have to clone the database. There I have to give all the access to train the model. And similarly for any other testing also. For example, so we have the production data and we have to create a production like database. So where we have to do all the load testing. So in that case, for example, we do have secure 1, secure 2 environment where we will do, so production data, will migrate to this secure 1, secure 2 environment with masking. Okay, so masking we will do, and there we will perform all the testing. But here in Snowflake, with this feature, no need to do anything. Just to create a cloned database. Okay, so like this. So if you do clone database, so entire database will be cloned, but make sure that while cloning, it will not take any stages and it will not take any temporary table. But transient table, transient database, will it take? Yes, it will take. So I'm going to create it. It will take some time. So it is creating the entire database, all the objects, cloning. Just it will do only the metadata pointer. It will not create all the object here. Just it will make metadata pointer only. So if you refresh it, so you can see one more database. So what is the database? Core underscore cloned DB. Yes, we have one more database here. So just to open it and then check. So whether we have core schema. Yes, we have. Only tables we have, right? Not the stages. So stages cannot be cloned. Okay, so only we have the tables. In the tables also, you can see customer temp table. Do we have customer temp table here? No, it is not there, right? So it will not create temp table. Other tables, yes, it will create with other tables. So whether it is creating the storage, no, it will not create any storage. So it will make only the metadata, right? So metadata information. So this is what it will make entire database. You can take entire schema. So one schema you can clone it. Okay, I want to clone this schema alone, core schema alone. So within this database or any other database, you can clone it. So so which database you want to clone, from which database, which schema, so that we have to define it here. So then it will automatically clone. Okay, so this is what we'll go for the cloning. So I hope you are clear. So what is cloning will do, right? Yes, now we will go with, so how it differs from backup, right? So how it differs from backup. So I'm just creating one table. I'll make create table statement here. Just I will make one create table. It's a customer table, right? So I'll go here, customer table. So this is the cloning. So cloning database, I'm just doing it. If we do any changes here, what will happen? So whenever we are doing some changes, this will be created in this cloned DB only, not in the original DB. So it will not do here, right? So it will be performed here only. Okay, so we can do here also. So if we are doing any backup, so what will happen? We'll see. So create or replace. Just I'm creating one table here. Okay, customer table. So we have this customer ID, customer name, phone number, date of birth, all this. Just I'm creating with some constraint. Constraint we'll see later. Okay, but I will create with constraint. Okay, so constraint customer name I'm creating with not null. something like unique. So all this I will create, okay? So just I'm creating with, okay, this way I could just create it. So insert into, so I'll go here, customer table. Okay, the previous customer table will be replaced, right? That will be replaced. That's fine. So I can move the data from, so here we have the customer 2, right? So we'll check here, select star from customer underscore 2. Do we have any data? Core schema. So we have some data. So how many records we have? We have 32 records. So I'll go and insert it. So insert into this table. Select star from customer underscore 2. So I hope both structures are same. Okay, so this one, we have more number of characters there. Okay, inserted 32 records. So if you check this data, so we can see, so this is the way data is available, customer 2. So customer 2 has primary key, but in Snowflake, primary key is not enforced. Okay, so enforced means, so even though it has primary key, it will accept duplicate. You can see the duplicate available, right? So even we created as customer ID as primary key, it will accept duplicate. So I will explain this constraint concept later. Okay, but just understand this way. So how can we create a backup? Just I created one table. That's it. This table, I created a backup to show you that. Just I created a table, inserted some data. So I want to create a backup of this table, customer underscore backup. So how can we create? I can go with this way, create table, customer, right? Customer underscore backup, customer underscore backup. Let's select star from customer table. Okay, customer, this table. So from this table, I have to create customer backup table. So what will happen here? Just I'm creating a customer backup. I'm not creating a cloning. So if I'm creating the customer backup, so it will have complete data, right? Complete data will be stored 2 times here. So whatever 32 records we have, the customer, it will create here also 32 records. Then, so what is happening here? We'll see. So I'll go here. So I'll take, so this way, select get DDL. So this is one function. Okay. So you can use this way. So you can use table and table name. So I want to go for table name is customer. So I want to use this particular table's DDL. So if I use the DDL here, so what we'll get? This is the DDL we are getting. So when we are creating this way, it will create, okay, this is the DDL of customer table, right? Yes. Similarly, I want to get DDL of customer underscore backup. So this DDL. So because I created this way, right? So what is the DDL here we will have? We'll check it here. Just you can copy it from here. So DDL, you can refresh here. So you can get it from here also, right? So manually you can get, or you can get this way also. So when we are seeing that customer, so what is the difference we are seeing here? So when we are creating customer, so customer create table name, select star from this one. So here we are seeing the customer, here we are seeing the customer backup. So both DDL, if you check, so what is the changes we are seeing here? So we are not seeing that the constraint, right? So it will not copy the constraint. So when we are creating a backup table with create table statement, okay, this way. So create table name as select star from this way. It will not create with backup. Sorry, it will not create with constraint. So it will not take any constraint here. So it will not take constraint here. So here we have the primary key. So primary key always it will have not null. So unique key, yes. So this is the way. So it is not copying it. So make sure. So whether we will have the data, select start from customer backup. So data will be available. Customer underscore backup will be available. Yes. So backup will be available. Data will be available. Okay. So data it will take. So we can create backup from another way also. So this way, create table name customer underscore backup 2. Just I'm creating one more backup. So this way, like customer. So this way also we can create, right? So we can create a backup of this table. So if you are going to create, what will happen? So I'm just creating customer 2 backup. So here I'm using customer 2 now. Get DDL. Okay, so I'm just taking the DDL. So I will check here. So what is the difference we are seeing here from the previous one? So when we create with this particular statement, customer like statement. So whatever we have the DDL, yes, it will be copied. Constraints will be copied and we'll check data. So whether we have the data here, right? So select start from customer, whether data will be copied. Any idea? We have seen already customer underscore backup 2. Okay, so data will not be copied. So only structure will be copied. Structure with the data. So please remember these are the three options. So when we create a table, okay, so when we create a table, create table, so it will create a table. Okay, so table. So if you are creating with constraints, so it will create with data. So this is what we have. It's a definition, right? DDL. So we can take this as a DDL, constraints and data. So when we are creating as create table statement, create table as select statement. Okay, this way DDL, but no constraints, but data will be copied. So when we are creating with like statement, so create with like, create table like. So what will happen? DDL constraints will be copied, but no data, right? No data will be copied. And when we are cloning, so what will happen? Cloning. So when we cloned, shall we check the cloned table also? So whether we have the any constraint previously we had. So when we are creating cloning, for example, same table I can clone, right? Customer table, I can clone. So I'm going to clone the table, create table name, customer underscore clone. Okay, so we have already cloned table here, clone DB. Just I'm going to create, or I can drop the table, drop table customer underscore clone. Okay, so this is the table, I'm just dropping it. Previously we had the customer clone table, all the table, I just dropped it. So I'm going to create one customer cloned table. So create table name, just you can use clone from which table? Customer table. So just use, select it and then run it. This is a customer cloned table. So cloned, I used one word, cloned here. I want to get the DDL here. So cloning, right? So this is the one. I'm taking the cloned table DDL. So whether it is copying the primary key, foreign key, all this, yes. Table structure, yes. Data, we'll see that. Select star from customer underscore clone, right? So this is a table. Just I'm using that. So I'm getting the data also. So 32 records will be available here, right? So 32. It means it is copying that all these options. Okay, so DDL is copying, constraints is copying, and then data also we are getting. So these are the difference. Okay, so please make sure that. So when we are doing that, so normally this one we'll call it as, so this way shortly we'll call it as CTAS, right? CTAS is nothing but create table as select star from. So create table as select star from. If you do it this way, you will get, this is the way you will get all this. Select star from customer clone, you will get this way. So entire table we can clone. You can ask me one more question. I cloned this particular table. So where we did it, all this options, we did it. So in this clone database only, right? Cloned database only, I did all this. Now I will go to this core DB because we have taken this cloned DB from core DB only. I'll just refresh. If you go here in the cloned DB, the core schema, we can see that tables this way. Customer cloned we have, right? Customer cloned we have. And so whether we have this customer temp will not be available here. Temp table will not be available. And do we have customer 2, customer underscore backup will be available? Yes, here will be available customer backup. We will check here in the core DB. In the core DB, go here. Customer backup is available. Is there any customer backup? No, right? Customer cloned DB. So just we have created customer cloned database, sorry, table. We have here no. I just deleted a table. These tables I dropped it. Customer clone L2, L3, all this table where I deleted in the cloned DB. So, but it is not deleted in the main database, right? So it is still there. So whenever we do changes after cloning, so it will create separate micro partitions in the storage. Okay, so please remember it will create separate micro partitions in the storage. Okay, so now what I will do, I will, can we create clone table, or we can say, can we create a table from the cloned table? Yes, we can create. For example, I want to create table from this cloned table. Create table underscore, I'm using L1, so level 1. Okay, something like that. From which table? Clone from this table. Okay, so one table I'm just creating. One more table I'm just creating. One more table I'm just creating. So whatever the table, so you want to create, we can create. So here I will use L2. Here I'll use L3. Here I'll use L4. So here I'll use L1. From cloned table, I'm just creating L2. So here I'll use L3. So can we create this way? So from cloned table, I'm just creating one more table. Yes, we can create. So here also, I'm just creating it, right? So here also, I'm just creating it. So here also, I'm just creating it. So where we will get all these tables, all the tables we'll get from here only, customer clone tables, because I created here. So this is the way we'll have here. So all other tables will share this particular storage only, because I did not change anything, right? So I did not change anything on this particular tables, and I'm using that this way. So how it will be used, you can check here. So select star from, so you can go to information schema. So this is like information schema dot, you can check here. Okay, so here storage metrics. Okay, so we'll have the storage metrics table storage metrics. Okay, we have one table called table storage metrics. Just to take this table, so whatever the table we have, all the storage metrics will be available here. So in this table, you can check here. So table catalog is nothing but database name, right? And table schema, table name. So which database it is? Core cloned DB. So where table catalog equal to this this one, right? Double click. So it will be available here. It's a case sensitive. So if you are using lowercase here, then use lower of here. So then only you will get. So I'm just taking this one. So then I'll go to this particular DB alone, right? So DB alone. So where I created this one inside the core schema, right? And table schema equal to this schema, this core schema. So within quotes, I can double click, so I can put the core schema. I'll go to this one. So how many tables are there? So these many tables are there. So I want to make, so only customer cloned. So I'll make one more table and customer underscore table name and table name like, I'll put this way, table name like single quotes, this way customer clone. So when we use customer clone this way, for example, I'll use percentage here because, so this way it will not select anything because I'm using lowercase. So if you are using lowercase here, just to use lower of table name. Then it will convert everything to lowercase because I'm using lowercase here. So how many tables are there here? So we have customer clone, first one. Then we have this, so we can put order by also. So this way also. So we can make ascending order or descending order. So this way we have. So we can use order by here also. So here if you see, so we have ID, okay, ID and group ID, clone group ID. If both are equal, okay, if both are equal, it means it's a original table. So all these are cloned table. So how can I identify? If the ID and clone group ID, if both are equal, it means it's a original table. If not, if it is not equal, it means it is cloned. This particular table is cloned from this particular ID. Okay, so what is the table? Because we cloned this customer cloned from where we cloned, so that we have to check it here, right? Somewhere we cloned from customer table. So we have to include customer table also, right? So lower of table name equal to, so we can put R. So this way I will use that table also. I have to take lower of table name equal to customer, right? So I will use bracket here. Then I'm adding that customer table also. Okay, so one more table. So here customer table I'm getting 2 times. Why? 3 times I'm getting customer table, right? So here we are getting 3 times. So this particular table only 51202. So all these tables are cloned from this particular table 51202, right? You can see if both are equal, this is not a cloned table. This is like original table. If this is the table we have, and you can check here why this customer table still appear in the same database, we might have dropped it and recreated it, right? So you can see table dropped. Yes, we dropped it. We already dropped the table, right? Why the table is available here again? Because the table is there in time travel, right? So if the table is there in time travel, so time travel by default, 1 day, right? 1 day. It's like you can check it. So time travel, the table definition, you can check time travel, it will be 1 day. So that's why even though we have dropped the table, still it is available. Okay, table created on this one and time travel, it is within the, so tomorrow if you go and check after this time, it will not be available because tomorrow time travel is not there, right? 1 day, after 1 day it will not be there. So if you go and check, it will not be there. But today up to next day, tomorrow 24 hours, it will be available because we put 24 hours. So here, so we can use one more filter condition also. And table dropped, table underscore dropped is null, right? So is null means, So table is not yet dropped. It's an active table. So then we will get that particular record alone, right? And order by table name. Order by table underscore name. So this way we can frame the queries and then you can check here. So this is the way we are seeing it. Customer table, it's the main table. We have this ID and all these tables are cloned from this particular table. That's why we are getting this clone group ID. So I hope you are clear. So what is cloning and where it will be stored? So it will have all the storage here. So it will take this particular storage. So from this particular table only, from customer table only, all these tables are taken. So if you are updating it, so if you are dropping a table, okay, if you are updating a table from the cloned table, okay, so cloned L4, you are updating. So after updating, so what will happen? So whether it will have this way or this way, we'll see. So I want to make, for example, I'll go here, select star from customer cloned L4, customer cloned L4. So this way I'll use. So this is a table we have and this particular ID. So customer name, I will update it. So I'm going to update. So update table name, set customer underscore name equal to, I'm just updating it. So where customer underscore ID equal to this one. If I'm going to update it, so what will happen? This update alone will be separate micro partition. It will create micro partition here. So I'm updating. So it will automatically committed because we have two data for 1001. Two records has been updated. So now I'm checking here. So where is the 1001? So here we have the 1001, right? So here we have 1001 and data has been updated and I will check here. So what will happen? So it will create a separate partitions. Okay, it will create a separate partition and it will have, so here L4 still it is taking that same customer table storage only because I'm not doing any changes, right? I did not do any changes in the customer table. So here, so whatever I updated, it will create a separate partition here and it will keep the data here. So we can go for even, so here also we can go for time travel. So there also we can do the time travel. So all this we can perform here. Okay. So here, this is what will happen. So so I hope you are clear. So how this particular table will take. So if I'm going to drop this entire cloned database, the table, this table, customer table itself, I'm going to drop it. So whether this particular table, because it's using this particular storage only, right? So whether it will be available. So I'm going to drop it. So drop table, even though I'm going to drop it, it will not drop because so within the time travel, we can undrop it, right? So we have the time travel is 1 day. So it will not drop the table. It will keep it and just it will metadata level, it will change. So I'm going to drop the table called customer. So this is the main table, right? So because I cloned from this particular table only, from this table only, I cloned this customer cloned table. So here we created the customer table, right? Somewhere here we created customer table and we loaded the data. So, but I'm going to drop the table. So if I'm going to drop the table, this particular storage will be, we may think that, okay, it will get dropped. No, it will not drop. So that's what. So I dropped entire table. So I will go and check now. So I put here table dropped is null, right? So then I will not get this customer table now. So still it is using the same group ID. You can see here 51202. The same storage it is using, right? So this is the way you can understand that it is still using that. So if you comment this particular option, okay, if you put commented out this one, then you can see that previously what we have customer table, all the customer table, it will be available. But if you go and check is dropped, yes, you can see the table has been dropped. So we'll have the dropped one. So but why the DDL and everything is maintaining? Because so we can undrop it, right? So if you are just simply using undrop table name, it will be retrieved back. That we have seen already. So it means So when we are doing it, the metadata level only, it will make the changes. So I hope you are clear. So this is the way. So we can go for the cloning. Okay, so how it will make the cloning? Let me explain here. So this is the cloning options. Okay, this is the main table here we have, and we are cloning here. So this will take the cloning object here. It is not taking the database, that storage, just it will make the metadata only. In this cloning, if you are doing some changes, so only this micro partition will be changed and it will not be changed here. Okay. So what is zero copy cloning? So quickly take a snapshot of a table at that particular instance. So at that instance, what data is available here, so that will, you can take it clone. So when the clone is created, all micro partitions in both tables are fully shared. So micro partitions are fully shared. Micro partition storage is owned by the oldest table. Clone references them. That's just this clone table, just references. Okay. No additional storage cost until changes are made to the original or the cloned one. Okay, so it will not make any changes here. So often used quickly spin up to dev or test environments. Yes, you have the dev environment, you have some data. Test environment, you want to do the same data, you can go for. Mostly if you go to real-time project, dev and test will be there in same account. Production will be there in different account. So even if you are keeping on the same account, so based on your role, so you cannot see the production tables. And somebody if saying that, okay, so production data, we will clone it to dev or QA, no. So definitely we will not clone production data to dev. So if you are doing that, it's against the violation, right? So we will not do that. So because for even testing also, if you're doing it without masking, so production data, we should not do it on the dev. So we can go with some other environments like other higher environment after UAT. So we can have secure one, secure two. In that secure one, we can clone it. So because it's the same copy of production. So if that particular environment, if it is running, then definitely the code will run in production. So that way, if you want to test it, you can go for. But production to dev, we will not, definitely will not copy the data. Okay, clone it. So production data cannot be exposed to dev or test environment. Okay, so effective backup. Yes, we can go for backup, right? So when we are creating backup or you want to do, as I told, some testing you want to perform in the production itself, or you want to do some LLM. Okay, so like large language model. Okay, you want to train the model. So you want to give the data. Yes, you can clone it and then you can give the data. So this way, it's called a zero copy cloning. Okay, this is what we are. Okay, select star from customer table. So this is customer table. I just dropped it, right? I just dropped. So can I go with time travel? I want to know. Just now I dropped it, right? So I can go with 30 minutes before what data is available. I want to take 30 minutes before. No, the table itself, I think it's not there. Okay, so we have to do undrop, right? So this way, we have to go with undrop the table with the time travel. But you can go with the time travel on. So half an hour before. So what data is available? This is the data. So available. So what is that? So here we have. And 15 minutes before. Okay, so this way, right? Customer table. So where I changed it, customer. Okay, customer cloned. That's fine. So you can take this one also. Can I do time travel for this one? Select star from this one, customer cloned table 15 minutes before. So what data was available? So this is the data, right? Steve and this one. Then 20 minutes before, customer cloned. When I updated 10 minutes before, so you should have taken 5 minutes before. Okay, so this is the same data. So 15 minutes, 20 minutes. Oh, this table only I changed. Okay. Customer cloned L4. So 20 minutes before what data was available? This way, right? and 15 minutes, 10 minutes before. So we have this way. See here, 10 minutes before this data and 15 minutes before, 20 minutes before, we have this data. So we can do time travel also. So whatever you want to do time travel on all the levels. So you can go with all the levels. So you can do the time travel. For example, L3, you want to perform the time travel. So we have the time travel option here. Okay, L3, 20 minutes before. Same one. 10 minutes before. Same data, right? But if you see L4, 10 minutes before, we have different data here. So this way we can do time travel also. So time travel, yes, we can perform in 3 different ways, right? So we can use some particular timestamp. So this particular timestamp, what data is available, or you can go for offset value, or you can go for query ID. So with that query ID, we can do the time travel. Yes, so we can do time travel also. So definitely it will support time travel also. So even if you are updating it, update something like, okay, so if you are updating it, so it will, so we can do the time travel. Okay, so this is the way we can do time travel. Hello everyone, very good morning and good evening to all. Let us start our today's session. So far we have seen a different concept in Snowflake. So today we'll start with the next topic is called Snowflake and GitHub integration. So how to integrate the Snowflake with GitHub. So Snowflake has already did that integration. Just we are going to integrate with our GitHub repository. So this activity, so most of the activities will be done by admin team. So it's like like a one time they will do it. We are going to make use of this particular GitHub integration in our Snowflake to deploy the code, right? So for example, if we go to any real-time project, so there will be some different environment. So if we are the developer, yes, definitely we'll have the development environment, right? So you'll have development environment where we will develop so all the code here. So it's like, so how in Snowflake, how they will change it, I'll tell you. So this is like a dev environment. So after development, so we need to deploy this code to QA environment. If you have separate QA, sometimes QA will not be there because our current project, we don't have any QA. Just will go to dev to UAT. So because we don't have any QA team separately, so we have only the UAT. Okay, so this is, for example, this is like a UAT. So we have UAT here. So we are moving the code to this UAT here. So different environments will keep it. And then from UAT to the production. So this is our production environment. So 4 different environments we have. So in our real-time project, we have dev, UAT, and production. So because we don't have any QA, it's a completely agile methodology. We don't have separate team for testing it. So here we have the dev. So we'll call it as dev environment. So we can keep it like another environment called QA, quality assurance. So we'll do all the testing. The quality engineer will do the testing. That means the testing team will do all the testing, whatever the code we developed it, and the code will move to UAT, and after that the code will move to production. So this is our actual production data. We will have it here. So these are the environments, right? So different environments we have. And if you take, this is our environment. So we will develop, okay, if you take one account, one Snowflake account. So we'll take one Snowflake account. So within one Snowflake account, so most of the project, they will follow this way. They will not go for different account for different environment, because if they're going for different account for different environment, then they need to do the data replication. Not, for example, I want to do the cloning. So then they need to do the data replication. Cloning is not possible between the accounts. So within the same account, they can do the cloning. And also some data migration and everything, creating a backup, all this, right? So within the environment, If within the same account, then it is easy. So Snowflake, one single account will take it. And for example, if this is the core DB, so core DB, if I have in our production, so normally in prod, you'll have it like core DB. So if you don't have anything, suffix or prefix in the database name or schema name, so that is our production. So this is our core DB we have. And then in UAT, it will have like this, UAT underscore core DB or core DB underscore UAT. So here you will have QA underscore core DB, and here you'll have dev underscore this one. So this is what we'll have separate databases. And then how this will be given access, it's based on completely on the RPAC. So we have the role-based access control, right? So admin team, so they will give the access. Okay, so they'll give access to each individual. If I have if I'm a developer, then this particular database I will have access, read, write, and execute permission. So the UAT, no, I'll have only read access. Production, I'll have only read access. So deployment, everything we'll do by using a different tool. Okay, so here we are going to use two different tools. Okay, so we can use single tool or we'll go for two different tools. One tool is called GitHub. Okay, so by using GitHub, we are going to do the version control. So I'll tell you what is version control. We are going to do version control. Second one, we need to, okay, we are having the latest code in this particular GitHub. We are maintaining the code here. So after that, after the GitHub, so we can use GitHub actions. Okay, so we can use GitHub action to deploy it, or we can use any other tool. Okay, so we can use for the deployment the CI/CD pipeline. We'll say it's a CI/CD pipeline. GitHub actions we can use, or we can use Jenkins. So previously we were using Jenkins, so now our deployment moved to GitHub actions, or you can go for any other DevOps tool. Okay, so like so different tools we can use it. Terraform. Okay, so you can use different tools for this particular deployment. First of all, we have to maintain the version control. The version control means in real-time project, so there will be a lot of developers will be there, and this is called CI/CD. So CI/CD is nothing but continuous integration, continuous delivery or deployment. Okay, so this is what we continuous integration, continuous deployment or delivery. So we'll say it this way, the CI/CD. So whenever we are having multiple users into this particular environment, by using CI/CD only, we will continuously deploy our code into production. So for example, we have multiple developers here in the development environment. We are developing it. So we might be developing a new code, or will be in the existing code. We have to take existing table, we have to take our existing procedure, existing code we have to take, and from the existing code we have to do the changes, right? So that may be a enhancement project. So dev, so this is the dev underscore core DB. We'll have the tables here. So how to do it? For example, version control tool. So whatever the changes we are doing it, the dev, right? So then it will maintain all the versions here. So whatever the versions we have. So we are doing some changes. Okay, so you do the changes and take this code to next environment, maybe the QA, just to deploy the code by using latest code. You will have it in the GitHub and use GitHub Actions or Jenkins or Terraform or any other deployment tool just to deploy it into QA. So who will deploy it? Just to give the artifact to tester, then they will deploy it. They will deploy it by using GitHub Actions. So we need to give the repository name, and latest branch will be their main branch that will deploy it, and then start testing it. So the QA tester is finding the defect. So then they'll assign the defect to this developer, right? They will raise the defect. and then they will assign the defect to the developer, this defect. So this defect, so where they will raise it? Using Jira. So the Jira also, they can raise the defect, they will assign it to the developer. Then developer will see that, and then based on the requirement, so they will do the code changes. So then, so whatever we had, so again, raise a pull request and create a PR, that is pull request, and do the, first we'll create a new branch, do changes, and then create a pull request, deploy it. Okay, you give latest code to this particular person, deploy it, start testing it. And again, the tester is finding the defect. Okay, then they will raise it. So this cycle will go. So once we found that, okay, everything is good, so then we'll move the code to UAT. So here, business will do the testing. Business people, like functional business testing, functional testing, we'll give them the data, and then they will test it. Or some separate UAT team, they will do the testing. Okay, if they are finding defect, they will raise the defect in Jira, and then the developer will be assigned, and they will be doing the code changes. Again, they will be deploying to UAT. So directly it will go to UAT now. And this cycle will go. So finally we'll have the latest code. So everything is done. Then we'll create a change request here. Okay, we'll create change request. Finally, we'll create a change. Then we'll go for the CAB meeting. So CAB meeting meaning, like we'll go for change advisory board. We'll go for CAB meeting and then everything. And then finally, we'll deploy the latest code to, so this production, like production. Okay, so for the production go live. So from here to here, we'll deploy it. So all the approvals and everything, this CAB, they will see it and then they will approve it. The timing and everything, change request, we have to create it, and then we have to get all the approvals, evidence, everything, we have to paste it. And each stage we have to go. So even initially also we can create a change request, we can track everything through change request, and we'll go one by one stage. And then it will go to the implement state. So once it is there in implemented state, we can deploy the code to this one. So UAT sign off. So you'll have some UAT sign off. And in change request also, we'll have some UAT approval. So there if we get approval, then only it will go to implement state. So then we can go ahead and then deploy the code to this one. So we can run the Jenkins, GitHub, or Jenkins, GitHub Actions, or Jenkins, or any other DevOps tool. Just to run it, it will deploy it. No need of any other team. Or sometimes you'll have release engineering team. Okay, some project will have the release engineering team. So release the lower environment we can do, but running the Jenkins pipeline or GitHub Actions to the production environment, so release engineering team only can do. So we cannot do it because so production deployment, they will check all the approvals. Change should be there in an implement state. Okay, so implement state it should be, and change window will be opened. So everything they will check it. Okay, so then only they will deploy the code to. They will run the pipeline. This Jenkins pipeline or GitHub Action, they will run it. So production one, we don't have control. Some project team they will have the control, but the other project team they will not have the control. So this is the way we will do it in real time. Okay, so you may ask one question here, some tables and database and everything. So we'll use some variables. For example, database name. So here it's a dev. So we might have used some DDL statement, right? So dev underscore core underscore DB. We cannot, can we use that code? So in this QA, no, we cannot use it. So there we have to use some variable. So variable, maybe you can check it online, or I will tell you in our next session. So how to make use of these variables for different environments, right? So variables will be there. So that variables will use it. For example, so this variable point to dev core DB, in this environment, the same variable, for example, variables will use it. So this variable will point to this particular environment. Okay. So like variable, something like I'll say So $A is nothing but it will point to this div or something like core_db. This variable, example I put, okay? This variable will point to this environment, div_core_db. So only one time we will do it, or we can do it in our DBT also. So DBT also we can parameterize and everything. Okay, so like if you have this one, it will point to this one, and here it will point to same core DB will point to QA. Okay, so QA underscore this one, and UAT, yes, we'll maintain the UAT. So something like this it'll point. So everything we are the same code, and the code, the database level, the variable environment level, we will maintain this particular environment variable. So it will point to dev core DB. This will point to QA underscore core DB. So this will point to UAT underscore core DB. This way we'll maintain the different environment. So once we are going to deploy it, some DDL or anything, so sometimes we'll put fully qualified path, right? So we cannot use QA underscore core underscore DB dot the table name into this UAT. So because that will not be available here, right? So everything will parameterized. So we can, if it is notebook, we can go for param, or if it is any other code, we'll maintain the environment level variables. So this way we will maintain it and then we'll deploy it. So first of all, so it's not this variable just for representation I put dollar, but I will tell you. Okay, so think about, we'll not use the same way the variables. So we may use variables in Snowflake or DBT. If you are using code in DBT, yes, there we will use it. So just to think about this one, we are not going to use it. So maybe it's like another very different symbol also that I'll tell you later. So we are going to use this way, and then we have multiple environments. So these are the knowledge. Okay, so I'm just sharing the knowledge to you. In interview, if they are asking questions, right? So you have to tell them that, okay, so that this is the architecture we'll have. So how many environments we'll have? So 4 different environments, right? So how will you move the code? So if they ask, so they will not ask directly, you have to explain them. So I'm responsible person to move the code, to develop the code in dev environment. And then dev environment is nothing but the database is different. That's it, within the same account. Then I'm responsible for unit testing. Then I'll be coordinating with QA team to do the QA testing. So if they found any defect, they will raise the defect through Jira, and then they will assign it to me. Then I will check that Jira, and then I will, if it is exactly the defect, then I will do the code change and raise the pull request to merge the code to main, and they will take not main. So up to QA, I will merge it. So they will take the code from the QA, and then they will go to next one. It will go to UAT. If there is no defect, I will defer that defect, right? I will defer that defect. Then we will discuss with the defect triage call. So we'll have the defect triage call. So triaging will have it, right? So normally we'll have the defect triage calls, and there we'll discuss it with the QA team or UAT team. So sometimes if it is a very big project, we'll have the defect manager also come into picture. Okay, so here defect manager, here defect manager for different environments. Then it will go to one by one. If it is a agile methodology, will not have separate defect manager. So end to end, we'll do the deployment. But going to the production, so this is one time we'll do. And from the production, if you see from prod, all other environments are lower environment, right? For UAT, production is the higher environment. Dev and QA will be the lower environment. So like this, we'll maintain. For dev, all environments are higher environments. So this way we'll have it, the differentiation. So now we'll go to the GitHub version control. So first of all, what is version control? And all this we'll see. And so in real time, let me take this one. So in real time, so how we will have this one, I'll tell you. So for example, GitHub is the version control tool. So if you see multiple developers are there, the real-time project, and I'm doing some changes, you are doing some changes on the same code, right? Same project, we are all working on it, and we have to have a common pipeline. We have to, whatever the changes we are doing, at the end of the day, we have to just merge it into the branch. So then only as a lead or somebody else as a senior resource, I can deploy the code to production. So like a single one. So always you'll have a master branch. Okay, so think about this is the master branch, and this is called main branch. Okay, main branch. We'll have it master or main branch. So anything is fine. So then from master branch, you will create a develop branch. Develop. Okay, so develop branch will create from the master branch. From the development, we will create a QA, or from master branch also we can create a QA. But normally, so QA will be created from the development, dev. And then UAT will be created from development. So like this we'll create. Main branch will have it here. And from develop, we will create a feature branch. Okay, for example, this is one feature branch. This is another feature branch. So this feature branch will be created by one developer. This feature branch is created by another developer. So I'm doing some development. I will take code from this development branch because it is synced with this main branch, right? So I will take the code from this particular development branch, and then I will do all the development here. Similarly, so you are also going to do the development by taking the code from development. So from here, you will be doing the development, right? So once you have done the development, you are going to merge it to development. So once I have done the development, so testing and everything I have done, unit testing, everything I have done, then I will deploy. I'm going to merge it into develop this one. So once I have merged it into the development, then only you can see my changes. If it is in future branch, so you cannot see my code. So if somebody is merging the code, somebody is committing the code to develop, then I have to just pull it. So whatever the code changes, he has done. Similarly, two persons can take one feature branch? Yes, you can do the code changes and everything. And if he is doing the changes, once he has done the changes, you have to pull it, the latest code, to this particular feature branch. Otherwise, this changes, it will not reflect here. So, but development branch, if you just to pull it, so you'll have the latest code. So everything will have. So for example, what is this feature branch, right? So first of all, we'll create a feature branch from development. Developers build the feature branch. For example, I have to do some changes as per the Jira. So normally we used to follow the Jira number. So we'll have some Jira number. That Jira number, we'll put it here. Then we'll do the changes and everything, test it and everything. Then create a pull request, deploy to, merge it to development. Okay. Then others, for example, other developers want to take the latest code, so they can just pull it from the development branch. So they'll have the latest code. Okay, so if I'm the only person working on that particular changes, then I can merge the code to development, then development to QA, then the tester will do the testing from here. And then if tester gives approval, then I can move the code to UAT, and the UAT business team will do the testing, that functional testing. Our business analyst will do the testing. And if they are giving the approval, then I can move to the main branch. So I can merge it to main. So we have to have the code in the main branch, then deployment to other environments, right? Environments. So I have the code to UAT. I have the code to main branch. So then I have to so if I have to deploy this code to this particular environment, I have to run the Jenkins actions. Sorry, GitHub actions. So that way we'll do. Okay. So this is the different environments we'll have it here. So I will give you this one. So you can go through this particular document, you will get clear idea. So what is feature branch? So developers create individual feature branches from the development branch. to build new functionalities, enhancement, or fixes in isolation. So this will not be applicable for others. Each feature branch represents a specific change request or Jira ticket or user story. So normally we used to create with the feature branch with Jira number. Then we'll go for code development and unit testing, frequent commits and rebase with development. So peer code review before merge, stable and tested features ready for integration. So normally these are the actions we'll do. So what is that? First of all, we have to go here. We have to do the github.com. Just to go to this github.com. So please do the sign up. Okay. But I have already did the sign up. So just I'll go to sign in. I'll use this. I'll go to continue with Google. Take from here. Okay. So I already logged in. Okay. I have already created this one. So this activity we will not do it. With this activity we will not do. But in real-time project, this will be done by admin team. Okay, so GitHub admin team and Snowflake admin team. So normally we will use GitHub Copilot to all the codes will be there here, right? So entire the project code will be available here. So they'll use the GitHub Copilot to train the agents and everything. So that's different. Okay, so GitHub Copilot is different. So just we will go to this one. So first of all we have to create a new branch. Sorry, new repository. So I will create a new repository here, something like this. So go to new. So just go to, this is our github.com. After sign in, you'll have this one. Just to sign up with the email ID, that's it. So new, then, so this is the owner. And so just to put that repository name. So create a new repository here and just to create, click. So here, choose visibility. So we can choose the visibility as a private. Okay, so or even if you have created with public, you can change it later. Just to create a repository here, private repository. Then if you see, if you have created a private repository, so you can see this symbol, then the log symbol, it's nothing but it's a private repository. So this is a repository name, right? So for example, you have already created a public repository and go to settings here, go a little bit down. So you'll have this one, right? Danger zone. So here change the repository visibility. So change it to private. So here it's already private. That's why it's asking to change it to public. But if you want to change it here, you can do here. So this cannot be done in real-time project because here we are the admin. So there it's we are like a developer. Okay. So now I'll go to repository. So we are done with repository creation. So just to follow this one. Okay. CI/CD is nothing but continuous integration, continuous deployment. So create a GitHub account, first step. So we have to create a GitHub account and repository and branches. Okay, we'll create a branches. Feature branch, user story, some number will be there. So just I'll go here. So this is the code. So I want to create a new file. Okay, this is SSH. If you want to copy it, you can copy it. Link, complete link, we'll have it here. So if you want to copy it, you can copy. Okay, somewhere for your reference. You can keep it here. So github.com, this is the username and then repository. This one, this is a repository and everything will have it here. Okay, so now just we can to create this one, the pull request or the code, just to go to create the branches, everything, you just create a new file, simple new file. So just I'm using some file name here. Name your file. This is sample.ddl file. And then just I'm creating, this is a sample DDL statement. So create or replace table customer. So open bracket customer ID number data type, customer name, something like this. Okay, you can do any code, customer name, varchar, then close it. I think everything I have given correctly. Semicolon, I put semicolon. So then I just created a file into this main branch because I have only main branch. So I have only main branch. Just I want to create a file in this main branch. Just to do the commit changes here. So click on the commit changes. So this is the file name. Put commit changes here. So if you see the code now, so this is our repository. Within the repository, we have the code. And how many branches are there as of now? So only one branch. So we can create a number of branches. Okay, master branch, it's nothing but main branch, development branch, and then feature branch. Just I'm going to create a different branches here. So normally this is what we will work in this our real-time project. It should be a private. Go to branches here. So within the main branch, you can see, so within the main branch, you have only one file, sample.ddl file. Just go to branch here and main branch, here at main branch, you want to create a new branch, source from main, just to create a develop. So develop branch, create a new branch. So create one more branch, UAT. Just I'm not creating anything like dev. So UAT I'm creating from development. Okay, so development is not available. So new branch, just I'll create from development. This is UAT. So because from development to UAT, I'm going to move. That's why I created here. And this is like a different branches we'll have, right? So develop UAT and then this one. So I can create one more branch, like a feature branch. So create a feature branch. For example, I'm going to create, I want to do the changes here. So I can create a branch here. This one, I can create feature branch. Okay, this is the feature branch and different branches will be there. So if you go to code here, so we are at main branch, we have one file. So do we have that file in feature branch? No, that file will not be available in this feature branch. Okay, this feature branch is up to date with the main. Since we have taken the code from main, it is available here. Okay, so main branch also we have the code. So develop we have UAT. Yes, we have this one. So after that, if you are going to do any new changes, it will not be available. Okay, we have some different branches now. We created these branches. So multiple branches we have done, right? So multiple branches we have. And so if you want to deploy the code, you have to merge the code from one environment to another environment. We have to create a pull request. Just to go to pull request here. So from where to where I have to do? From feature branch to develop branch. So we'll take this way. So nothing is there as of now. That's why we are not seeing it. And if you are going to see in feature branch, if you are doing some changes, it will be available here. So then we have to raise the pull request. You have to get a review from your peer reviewer, client reviewer. So whoever is the senior resource, you want to get the review. And once it is done, just merge the code to this particular develop. So if I have merged the code to develop, so any other developer can see that the changes. Okay. For example, I'll go here. So if I go to this particular branch, I'll go to this feature branch. Okay. So here I'm going to create some file. Okay. README or something, some different file. I'm going to create it. So this is one file. I'm just creating it. Or manually I'm adding the file, new file. Go to new file. Just to create a new file here or upload a file. So this is manually we are doing it, but we will do it through Snowflake directly from there also. So where I'm currently I'm in feature branch. So I'm adding just to one simple file. So this is like a customer underscore DDL dot SQL file. Okay, this is like a dot SQL file. Some create statement I need. So I'll take some create statement or something like that. So whatever the changes I want to do, some create table statement, that's it. I want one, some code, customer address, okay, something like this. I'm going to insert it. So for example, this is the file. So we got it from our Snowflake directly from there. Think about from there we got it. So I'm doing it manually here directly into our GitHub, but I will tell you how to do it from the Snowflake as well, because Snowflake and GitHub we have to integrate. So create customer underscore DDL. So just to do the commit messages and commit directly to the feature branch. Yes, right. So directly to the feature branch. Some code will be there. If you see, feature branch has two files. Develop branch will have only one file because just now we did the changes, right? So this particular feature branch, if I have integrated with my Snowflake, I can see this file, but no one else can see that. So even if I have committed, then they can see if they have taken this particular branch, they can see, but other branches they cannot see. So now you are seeing that compare and pull request had written pushes 15 seconds ago. So you have to create a pull request now. So why we are creating it? We are at feature branch. We have to move the code to the development branch. So then only developer can see that or QA or UAT, then they will see the code and then they will deploy it into their environment. So I am at this one, development, create a pull request. You'll see the pull request number 1. Copy this. So normally like GitHub, we are doing this one, right? So reviewer will be automatically added. We'll have some GitHub admin. They will add the reviewers. So automatically the reviewer will be added, or you can add the reviewer here. So for example, so if I am the developer, I will add somebody else. Okay. If somebody else is developing, they will add me as the reviewer, something like this. We'll do this. By default, some reviewer will be there for this repository. But if you want to add it, you can add it. But here there is no reviewer. Just you can merge a pull request. So where we're merging, so from this particular feature branch to development, merge. So commit confirm merge. So now if you go to this development branch, okay, you can see pull request successfully merged and closed it, right? If you go to development branch now, just to go to code and go to development. So now you could see two files in dev, but you will not see two files in UAT, right? So in dev environment, so deploy it. I will do the testing one more time. Okay, everything I found correct. So then I can move the code to UAT. Now UAT, nothing is there, only single file is there. So again, you have to do the compare and pull request from development to UAT. I'm just moving develop to UAT. Just to take this develop to UAT. So just to give the title here, description, create a pull request. This will have pull request number 2. Right? Previously had had 1. Now it's a 2. And it will go for quality checks. So you can add some quality checks also. So Copilot, we have already created the admin team. They have already created this code checks. Everything it will do. Conflict it will check everything. And then merge pull request. Just merge it. So from develop to UAT, we don't have any review in our real time. But sometimes if you have preview, just to get it review. So we already did the review in feature branch to develop, right? So then UAT will not have it, just to run it. So now we have done the code to this particular branch, develop to UAT branch. So if we are going to say, okay, so we have the code in this UAT branch, then this UAT tester will run that GitHub Actions or Jenkins point to that particular pipeline. They will deploy the code to UAT. Then they will start testing it. Okay, the deployment, they will do it in the GitHub Actions here. So you will see the actions here. So you'll do it here. So now the code is up to UAT, right? Code is up to UAT. So if you go here, main, it is not there. But UAT up to the code will be there. So now we added file directly to this GitHub, but in real time, we will integrate with the Snowflake. We'll do that as well. So we are at UAT. So again, create a pull request. So UAT to main. So this needs approval in our real time also. UAT to main, create a pull request. So whatever the changes we did, so everything it will display here. So not only one person, so any other persons are doing for this particular repository, so who has done the changes. So everything it will display here and the pull request number and everything. And finally, we can merge it to main. Okay, we merged it to main. Then that main to that particular environment we have to deploy, right? The production we have to deploy it. So for that only we have the release engineering team. So we'll have the change. The change should be there in the implemented state. Everything should be approved, right? So UAT testing, everything will show to them. The cab approval will get approval. Then change will move to implemented state. Implement state, then release engineering team, we have to send an email. So they will run the deployment pipeline, or some project you will run the deployment pipeline, but you say release engineering team will run it. So because this is our normal architecture we'll follow in our real-time project, okay? So just we have committed, and if you go to this branch just now, main branch, now we have the code. So this is the way normally the code will move to one environment to another environment. To deploy the code to this particular Snowflake, we will use the actions here. So we have to create a new actions. So configure the actions by using any of the deployment. So here if you see continuous deployment, continuous integration. So we can create by using Terraform. So I said, right? So you can use this one. So you can create it or so whatever the way you want to do, you can do it. This one. So maybe this will be done by the admin team. They will create a YAML file and they will put all this parameterize the code and everything in the YAML file. So they will do it. Just the only thing is we have to update our repository, that YAML file, and which branch we have to deploy it. So that's it. So dev environment, the repository and development branch, and UAT environment, the repository name, UAT branch name, and main, yes, main branch name. So that way they will configure it. So each environment will have separate environment YAML file, and so this one environment level and repository to point that. So only thing is we are going to change the YAML file. That's it. They will give us the access. We have to change it. So this is GitHub Actions. Okay, so we can do this one. So even by using GitHub also I can do. So this is separate one. But now we will do it integration between this particular GitHub to the Snowflake. Okay, so how to do? So in order to do this, so we'll have this one. So go to developer settings and create a token. So we need to have a token to integrate GitHub to our Snowflake. So who will do this activity in real time? The admin team will do that. But here we are doing it. Just to go to developer settings. So here this is normal settings. Just to go to this particular profile. So go to settings here and go to developer settings. So do we have developer settings here? Yes. Just to go to this developer settings. So this action will be done by, so who will do this activity? This will be done by admin team. So personal access token, go to token, this one. Okay, so this token is there up to February 4. It has been expired. So we can delete this token. So we will create a new token. Because with this token only, Snowflake can integrate with this GitHub. So I'll go here. So create new token or generate new token with classic. Okay, so then I can go this one because we created classic one, right? Just to go to this classic one. The token name, if you want to put some name. So token underscore batch 03, something like that. And it will expiry by 30 days, May, it will expire on this particular date. Just to select the scope. So you select the repository. So that is we need full control of private repository. Yes, we need this one. Okay, that private repository we need to give. So take this, generate a token. So this is the token. Copy this token, copy it. So go here, just will paste it here. Just I'll replace it. So for you it will be different one. Go to developer settings, create a token. So create a token. So username. So where is the username? This one. Just to go to this profile. Okay, so profile here. So you'll see the username here, github.com, then username, or so here itself you'll have the username. So here, whatever the username you created, everything will be available here. So just you take, so this is the username. So just I have taken the username and base GitHub URL. So base GitHub URL is nothing but github.com / the username. Okay, so just copy it from the profile page. So copy this entire, copy this, Control C, and paste it here. So normal one we pasted here, right? Yes. A repository URL. So this is important. Which repository you want to connect? Go to this home repositories. Okay. So the repository URL. Which repository? B03. So go inside. This is a repository URL. So copy this repository URL and paste it here. So you're able to see this, right? So batch 03. So repository. These details you have to just copy it. So keep it here. And we will use this one. This one. So these details. Just I'll go here. I'll go to this one. I can create a new database. Okay, so we are at this one, right? So we'll create a new database. Create database name. No underscore CICD, something like this. I'm just creating it. Okay, some new database we have. And if you want to have the public schema, you can keep it public schema, or any other schema also you can keep it. New CICD database. So take this Snow CICD public, or create any other database also. Just to follow this. So use role account admin. So we are at account admin only, right? The role is account admin only. So account admin role only, they can do all this. So developer role we cannot do. Compute warehouse we can use it. That's fine. We are at account admin only. No need to run this one, right? So create or replace secret, GitHub secret. So just we have to create a secret for this. So type equal to password. So username. This is a username and password. So where is the password? The token we have taken. This is the one we have taken, right? Control C. Go here. Control V. So you can give any different name also for this. Just I have given GitHub secret. So just to create one. So secret successfully created. Yes, we created a secret. By using this one only, Snowflake will establish the connection, the integration. So secrets, you can see all the secrets here. So yes, we have the secrets already created. So now create API integration. So we have created some integration before that, right? Like Snowpipe, we have created some different integration. So, but here we are creating API integration. So through API, we are going to fetch the data to the Snowflake to GitHub, all this. API integration name, API provider is GitHub, Git HTTPS API, API allowed prefix, yes, this particular profile, allowed authentication is the secret, enabled equal to true. So just execute this particular line and API integration has been created. Show API integrations. So API integration will be available now, right? So this one, external API we created. So after that, we have to create a repository. First of all, we'll go here. You go to the show GitHub repositories, nothing is there. So the repository we created here in GitHub. So that we have to integrate here, right? So Snowflake deployment, no, Snowflake repository. So what is the repository? Snowflake underscore B03, right? So this is the same name we can give. Create or replace repository, git repository name. So API integration is this API integration, GitHub secret. So origin equal to this one. Same one I can put. This name I can give different name, but same name I'm just creating it. But this repository name we have to give correctly. Whatever we have given there. So that repository name. Just to create a repository here. And then show git repositories. So now it will show you all the repositories. Okay, so we have the Snowflake branch 03. So show git branches in git repository. This one. So how many branches we created? Feature branch, one branch, developed, second one, UAT, then main. 4 branches should be there, right? In this repository. So 4 should be there. You can see. So it means you are able to see the repository. These repositories we created from GitHub. But from where I'm seeing it now? From this Snowflake I'm seeing, right? So develop one, branches, develop, feature branch, this one, main branch, main, UAT. So all the branches it will show here. And I want to display, so whatever the files are available in this list files in this branch main, so I can display it here like this. Okay. So this is the way you can do. So if you have any Python file or anything, if you want to show code in the file, you can do this way. But this is the one we can list down, this file. Customer DDL, this one, I want to deploy it in the main branch, right? The main branch I have. So think about this is production environment. So how they will deploy it here, right? Into this particular environment. So where I created the customer underscore DDL, this one, I created this customer address, right? This table. So I did not create, but think about somebody else created in their different environment. Select star from this particular table. Is there, this table is available in the CI/CD database? No, right? This database is not available now. It's not available, but I'm going to deploy it. See, normally this is what we will give in our GitHub actions. So they're going to deploy it. They'll use this way. Okay. So now alter git repository. Take that repository here. Okay, repository name. Alter git repository name. Fetch. This will fetch. It should be it will be available up to date only, right? No changes are fetched because it's up to date already. We did not do any changes here. So then this is the actual actions. So they will put this way. So branches main. So what is the file name? Main branch customer DDL. This is a branch file name, right? So copy path, you can copy it here. Customer DDL.SQL. Okay, so take this. It is there in main branch. Am I correct? So this particular branches main. So this is the file name. See, this one I'm executing manually right now, but this will be done by YAML file. So if they are going to do, okay, you have code up to main, so they want to deploy it into production environment. So environment, they will set it up, where they have to execute it. So now I set up here Snow CACD, that is a database, compute warehouse, account admin role. So everything I put it right. So there they will define all the role and everything in the YAML file itself. Then this execute immediate, they will parameterize a repository name, they will pass it from the config YAML file, branches, and then main is common. And what is the file? So this file is like so whatever the file we have, So all this. So how many files are there? So that they will deploy it this way. So after that, you have to execute it. So you have to execute it this way. Deploy it into TDL and all, we can execute. And normally other files are we will not execute. So TDL only executed. Other files are deployed. So that will not execute it. We'll go to some other task or something. Will take that file. It will execute. But if I'm going to before executing, I'll show you. Nothing is there in the main, right? So I'm going to execute. So did I create any table in the inside a Snowflake? No, right? So think about somebody else has created. They created this one GitHub integration, everything they have done it. So now number of rows inserted 1. You're seeing that show tables. So now you could see one table here, customer address. So select star from customer address. So whatever we did from that file, so 4 records so table has been created and 4 records have been inserted. So this will be done by either Jenkins pipeline or this GitHub Actions or any other deployment pipeline you are using it. So you will use it. So this is the way we will do the deployment. Okay. And this is just we have done the reverse. So we took the file from here and then we have done it here. But now we will do it from the Snowflake to the GitHub, right? So how to do this? So go up a little bit. Are you seeing that my workspace here? My workspaces. So then go to this. Okay, refresh it. So you're not seeing it, not this 3 dots. Just to go to arrow mark here, not this one. Or yeah, here. So now they changed it. Previously we had to click on this one, then you have to put. So GitHub workspace, right? So click on this plus symbol. So create a workspace now. So separate GitHub workspace will be created, not normal workspace. So create a GitHub workspace. So repository URL. So take that repository URL which we created now. Repository URL. This is the one. Okay, so put this. So then automatically it will take the workspace name, right? And then the API integration we already created. So here in this account. So one API integration we created, right? For this repository. So that will be available. Personal access token. So that token also will be available. So you remember we have created the token. Select database schema. So we can select a database now. CICD, public schema. Select the secret. So we already created a secret, right? So this one. So everything we already did it. So or you can do UI itself. So create plus create a secret and personal access token. Here you can put API integration you can create from here. But we did it all this through the SQL command. Okay, so just to create a repository now. So that is a GitHub workspace we are creating. Separate workspace will be created. So this is the real-time environment. You will see this way only. Notebook and everything we'll have it here. So now which one we are there? This is my workspace. This is the GitHub workspace. So we have it here. So in GitHub workspace, if you see 2 files are there, customer ddl.sql. This one I did not create because from the GitHub it has been taken. Okay, which branch it is pointing now? So this is the workspace and it is branching. You can see branch is main branch, right? It is pointing to main branch. 2 files are there created by and everything. You can see repo underscore workspace location, all this you could see. But I want to change the branch to feature branch. Changes. Okay, so you can see the changes, main branch. You are seeing main develop feature and UAT, right? So what I will do, I will create a new branch. For example, I want to do some development. Just go to repository here, code. So create a new branch. Go here. I will create a new branch. For example, this development is new development I'm doing. Go here. Create a new branch from development. So because development and main is already synced, create a new branch. So where I created in GitHub. So can I take it from there? Yes. So I can take. So it's not automatically, it is not updating. Just to go to changes here or main, just to fetch all, that 905 will be available now. Is it available now? It is pointing to main, but go to 905. Here nothing should be there. The files, no, the two files should be there because I have taken from development, right? Only two files should be there. Okay, so I'll go here. This branch, it's not refreshing. Okay, this is my workspace. Okay, so this is our, it should display here. So it's not displaying. Sorry, 1 minute. Just I'm reloading. It should available. Okay, yeah. Just to reload the page, entire page, not with this one. Just reload it. So now it is available, right? You can see this is the repository. Inside the repository, we have taken from the feature branch. That feature branch we created from main, sorry, development, right? So that's why two files are there. So there is no changes, right? For example, this customer DDL, I'll go and update. I will insert one more record here. Okay, so now 4 records are there, and I'll put 5th record here. So this is something like modification, right? So modification. Are you seeing the M here? It means this file I have modified it. So I have taken the code from main and I'm just modifying it. Okay, this one modify. So then I can create a new SQL file. So go here, new SQL. This one, something like emp.sql. So this is A. So what is the meaning of A? It is new addition. So addition, this file I'm adding it. So this is the developer, we are doing it changes, okay, developer. So I'll go here, I will create some table. So just I'm creating one table and insert some data. So create or replace table, insert some data. Okay, so I need this one. Okay, this statement I just created. I'm not going to, so this one database, for example, this database, I can choose it like CACD, dev underscore CACD, or so any other before that, if you have anything, you can do it. Okay, so this one I just created, right? So this is addition, this is modification, this is existing one. There is no changes. So now go to the changes now. And so somebody else has changed to this branch. You can pull it to your local. This is the private one, right? Just a local. Okay, so for example, we are working in one particular project. So I'm also doing the changes to this branch. You are also doing the changes. Then before doing the commit, I have to pull it because you have done some changes that should be available here before I'm going to push it. Because if I pushed it, so whatever you did the changes, that will go, right? So or we will get the conflict because you have 3 files, I have only 2 files. So that way we may get, if you have already committed it, I have to pull it. Okay, nothing is there to pull. If you want to pull it, yes, pull it. It will be pulled from GitHub. I hope you are clear. So what I'm doing it. Okay, pulled it, nothing is there. Only 2 files are there. See, these 2 files are changed. The other sample, something like that, other file, there is no changes. So no need to do the push, right? So this is addition, this is modification, just to push it. So this is something like a new development for this Jira, something like this. We push it to this feature branch. I pushed it, so now no changes. It's up to date. If we go to the files, so now this feature is up to date, right? You will not see modification or addition or something because this branch is like up to date now. But if you want to change the branch to some other branch, like a development, right? Development branch, whether the development branch will have that file, that whatever the employee file, do we have that? Do we have that file here? No. I'm changing to development. Okay, actually this is not doing. Just reload the page. Maybe something. Now which branch I'm in? So I'm in develop branch. You can see develop branch. But develop branch, I do not have the updates because only two files are there. The employee file we don't have. So normally, as a developer, I did the changes. I just commit to this particular feature branch, right? Feature branch. This feature branch 905. So I will have three files here 905. So this is not auto updating. Maybe that's a bug from Snowflake. They will fix it. See, so they will fix it maybe later. So I'll refresh this page. So we have the three files now. As a developer, I created three files and tested in my local and everything is fine. And I have to deploy this into develop. Then UAT, I have to move and then main. Just go to branch here, okay, in GitHub. So everything else we have to do by using GitHub. So which branch I have to select? This branch, right? So you could see three files here. Whatever we just upload it. So here we have the 2 minutes ago, we did some changes here. So now I will create a pull request, compare and pull. This feature to no, directly don't merge it to main. Stage by stage we'll go, develop. Then deploy the code to development. Just we are merging the code to the branch. Then we have to deploy it by using actions, GitHub actions. Something, this one develop, then pull it, create a pull request. We got the pull request number, add reviewer, view. So they will go to the file changed. Okay, so this file we have already. In this file, customer underscore ddl.sql. This new line has been added. And this is a completely new. It's a green color you are seeing, right? Completely new. This plus symbol, green color, represents its addition. This plus symbol, minus symbol, showing that it's a modification. You are seeing that representation also. And commit. So how many commits we did? Just one commit only, right? So this is quality check. If you want to do some quality check, you can build it, that quality check, everything. So now if I go to the pull request, this one opened, right? It's not merged. Just to go inside, we have to merge it. So otherwise, the code we did from the feature branch, it will not be merged to development. So merge it to development and then deploy to development environment, do the unit testing and everything. Then create a pull request to UAT, deploy to UAT, ask business to validate it, the data table and everything, the code, whatever they want to run the job, task or something, they will do the testing. And then they'll say, okay, everything is fine. Then only we have to create a UAT to main. So now we created from feature branch to development, right? So go to pull request, go here, develop to UAT I'm going. Okay, so UAT. Just moving the code from one branch to another branch. So if you are the UAT tester, what I have to do? I have to create a pull request from development to UAT, development to UAT. This is what exactly we'll do in our real-time project. Okay, the only thing is the code will be different, but process is same. Merge it. Now go to the GitHub actions. Deploy to UAT environment. Okay, it's nothing but the database will point to UAT underscore CICD, something like that. Whatever the database here we have. So we'll have different databases, right? UAT underscore retail DB, UAT underscore permanent DB, something like that. We will deploy it there and then we'll do the changes. So, but we will deploy to main. From the main, we'll run the GitHub actions. Just I'll go here. I'll create one more pull request from UAT to main. Yes, we have these changes. We have to create a pull request UAT to main. For this, we have to get the approval. Just to create a pull request now. This link I have to copy, I have to send it to my approver. I have to ask them to approve. They will say, okay, go, they'll go and check what changes we did it, whether we have tested everything lower environment, they'll ask. So once you are done, once you are saying that, okay, everything I have tested, so everything they are also okay, they'll also check it here. Yeah, peer review, everything is correct. So then they'll approve it. Once approved, so then only you can see the merge pull request, this option. Otherwise, it will not be available. So just to confirm merge. So then we merge to main. Just to go here. So now see this table, employees table or something, this table. What is the table name? Employee, right? So whether we have this table here. So let's think about this is main database, main production database. Just I'm saying that employee is not there. So I will go to this main. So this will, I'm executing this one manually, but in real time, this will be executed by GitHub Actions. Okay. So where is this branch? Go to this branch. Sorry, this is a repository. Fetch it. I want to do it in this one. Okay. Current repository, just to fetch it. Okay. So how many branches are there? These branches are there. 905, everything. So we have here. So because these branches are changed. So it's a new and it's a change rate, right? So that's why. But the other branch, so you see 904. So that we did not change. We already closed. Just to copy this. From where I have to deploy? From main. What is the file name? emp.sql, right? Or the previous one also. emp.sql. This is the one I'm going to execute it. So this is the one manually I'm doing it, but in real time it will be done by the actions from the YAML file. Number of record inserted 5. Now you can check this employee. See, this is our production one database, right? Use database, everything we have to put. And now we could see 5 records. And even in our previous one, if you see previous table, select star from, I think, customer, right? Customer address. 4 record is there. So what is the file name? Customer underscore DDL. Customer underscore DDL, right? Same one. Customer underscore DDL dot SQL. Just I'm executing it. We'll see. So there I put create or replace table only. So it will recreate the table, right? So I should see that 5 records. So this record I added newly, right? That addition. So I'm taking this way. So I just did it. So this will be done by the GitHub Actions or Jenkins. But exactly this is what we will do in our real-time project. So please remember. So how many environments will be there? If somebody asks an interview, you can explain them with the CI/CD. So how we will do. So all this. So I can explain them with this GitHub Actions. So this will be done by the DevOps team actually. Okay, this actions creation. Only thing is they will provide us the YAML file. So there we will put based on our the repository and database name. So all this will just change it and then we'll take that YAML file, config.yaml file, so that we will deploy it everything into the different environment. So I hope you are clear. Just to go through this particular document, so you'll get through so all the details. Okay, just to go through this, you'll get all the details. So thank you all. We'll stop it here and then we'll continue tomorrow. let us start our today's session. We'll start with Snowflake certifications. So if you are planning for certifications, so first you plan it for SnowPro core certification. So that is the developer certification we have. So first you plan it for core certification. If you have already completed, so then you can go for role-based certification or specialty certifications. So what are the different types of certifications are available? There are 3 different categories. So you can take it up. So based on your role, so based on your experience and based on your requirement. So first one is SnowPro Associate and Core Certification. So normally we will take this core certification, SnowPro Core Certification. This Associate certification comes under the platform. If you want to go for Snowflake Admin, yes, you can take the SnowPro Associate certification. But if you want to go for data engineer role, then you can take this SnowPro core certification. And we have the SnowPro specialty certifications. It's nothing but we have GenAI, Snowpark certifications, all different certifications are available. If you want to take, yes, you can take. The third one is the advanced certifications. It's like we have some role-based certifications. So if you have already completed the core certification, then you can focus on this advanced certification. So here, if you take associate or core certification, we have associate certification. SnowPro Associate is nothing but it's a platform. Snowflake admin team. If you're admin, yes, you can take this certification. SnowPro developer will take SnowPro core certification. So if you are planning for SnowPro core certification, these are the percentage of questions they will ask with the 6 different domains. The first one is data cloud features and architecture. The architecture basics, they will ask 25% of the questions from architecture. Snowflake architecture, then account access and security. 20% of the questions are from account access and security. So we have RBAC, some different roles, users, and security, everything, right? So they will ask 20% of the questions. Performance concept, they will ask 15%. We have seen already completely the performance. Data loading and unloading. So data loading is nothing but copy into. So we have the different stages, internal stage, external stage, everything. 10% of the exams they will ask. And data transformations, like a cloning. So a lot of concepts are available, right? Transformation logic, procedure, UDF, transformations, SQL functions, all this they will ask. This transformations and data protection and data sharing. So this one also we have seen. So 10% of the question they will ask from this particular domain. These are the 6 different domains. We already completed all of them, and please focus on these areas. And if you are planning for the specialty certifications, there are 3 different certifications are available. So one is Snowpark. It's completely on the ML side. They will ask Python related questions, right? So how we are the PySpark. So here it is called Snowpark. Okay, so that comes with the Python, and you can take Python. If you're interested, yes, you can take Snowpark certifications also. If you're planning for AI related certifications, like AI related ML, AI role, then you can focus on these 3, the specialty certifications. So what they will ask in Snowpark, so they will ask Snowpark concept, API for Python, and then data transformations and performance optimization. Mostly they will test the programming skills. Okay, so here in Snowpark. Then we have the native apps. There are different questions they will ask in the native apps. And so here we have the Gen AI. So normally this is for these 3 are AI related certifications, like we have the AI, LLM, all this, right? So ML, everything they will ask from here. So to take the certification, we need SnowPro core certification. So then only they will allow us to take the certification. Then we have the role-based certifications. These are the advanced certifications. Once we complete SnowPro core, then we can take it up these certifications: architect, data engineer, data scientist, administrator, and data analyst. So before going to this administrator, you can take platform certification, associate certification, then you can take this one. Data engineer, data scientist, data scientist. So mostly like the specialty certifications where they will ask the Python related questions, AI and ML related questions. And data analyst, mostly they will ask SQL. So how we will do the analysis on the data. They will ask data engineer. So everything they will ask. Advanced SnowPro core certifications. This is the cost. for certification. So if you are planning for SnowPro Core, it's approximately $175 with the tax. So if you are taking the certification from India, then you can expect 20% regional discount on this cost. The SnowPro Core certification is valid for 2 years. If you have already taken before 2 years and you want to take recertification, then you can pay $88. Like a lot of new features they have added, right? So they will ask the same SnowPro only. Since we are taking after 2 years, so we can pay $80 plus tax. And then specialty certification, they will take $225 and advanced certification $375. Okay, $375 plus around $40 to $50 tax, then you will take around $440, $450. Okay. So this is a certification, the cost, and this is the minimum score. They will put a score from 0 to 1000. Then we need to take 750 plus. Okay, so then they will say like it's 75% is the passing score. We have to score at least 750 plus. So we can take no issues. So then if you ask me, how can I register it, right? So you can go to this one, just Google it with certification, Snowflake certification registration. Okay, so you can go here and go to this SnowPro certifications. So here, this is the page, learn.snowflake.com, certifications here. Then you can create account. So first you can create account. I already explained, right? SnowPro Associate and Core certifications, specialty certifications, and advanced certifications. So these are the certifications available. You can check every now and then. Definitely they will change the pattern, questions, and everything because they're changing the entire Snowflake architecture, UI, and everything, right? They will change the questions. This is the page, okay? Snowflake login, certification metrics, this one. Okay, so just go to this login. So based on the email, so you can log in. Okay, so this is the page. You will get cp.certmetrics.com Snowflake. Okay, this is the page, and you will get your Snowflake number, also certification number. I already completed, right? So this will be available in the my certifications, certification status, all this. So whatever the certification I completed, it will be available here, right? So whatever the certification you have completed. So they put the expiry date also, when it is going to expire, all this. So now if you want to register it, go to the schedule and manage exam and manage my exams. So go to this one. So since I already completed the SnowPro core, so it will not be available here. And if I'm planning for any other certification, for example, I want to write data engineer certification or any other data analyst certification, right? So I can go inside, register and schedule. Just I will go here. Okay, so this is the one and there. And you can take, if you want to take online, so this one, online with OnView, just to go inside, or if you are going for any in-person test center, you can take this one. But so you can take online exam. They will give us some instruction. We have to follow that. So go to this, and these are the prerequisite for this. Okay, go to next, and you can read all this. Okay, so how they will ask questions and everything, and you can check all these checkbox. You can read and then you can check it. Okay, so what they will ask, right? So prerequisite on the test day, what we have to follow, all this they will put here. Then go to agree, and okay, what is the instruction? Okay, you want, you can put English, right? Then go to next. Then which time we are preferring. So based on our address, it will take automatically. So you can take, or if you want to change this, you can change it. Now I'll go here and you can book a slot, for example. So from today onwards, it's available, right? So if it is available, it will show you, but you can refresh it always. If it is not available, for example, you want to take it on Monday, but the slot is not available, then after 10 minutes you can try. So it will be available definitely. Go to this one and choose a slot. Okay, explore more times if you want. So you can take the more times, or they're giving this particular time, right? Or you can go to this one. Okay, these are the timings are available. So whatever the timing you want. For example, I want to take this particular time or this particular time. Okay, so I will take this one. Then so what is the time slot, right? So I'm taking 6 p.m., 6 p.m. to 8 p.m. So 2 hours. Then book this appointment. So click on this. So this is the one for all of most of the certification we will follow. So online, and this is the cost, $375, right? And so you can take, so this is the 423 US dollars. It's almost, it will come around 500 Canadian dollars. So 500 is nothing but around 30,000, right? So you can take 32,000 around that. So this particular certification, data analyst. But if you are planning for the Snowpro core, yes, it will be 175 plus. So it will around $200. Okay. But this is the advanced certifications. And so I'm just removing it because I already put card. Then if I go to this checkout, then they will take the from the card. Okay. So this is the way you have to do it. So I hope you are clear. It's not like this particular website. So this is the correct website. Okay. So after completing the exam, then you can go here. You can check your exam status, and so what is your score and everything. You can check it here. All right. So this one. So they will check whether the score, the everything is correct or not. Okay. So this is like the exam history, everything you can check it here. So dashboard. So this is the page. Okay. cp.certmetrics.com Snowflake. So you can go here, you can take it from here. So I hope you are clear now. The certification, how to take, how to register it. So if you are planning, yes, you can go ahead and then you can register it yourself. So while taking the exam, so we should not wear any watch. No one should be there in the room, and the room should be very clean. And they will ask us to take the camera, and we should not move out of the camera of 2 hours. They will give us the instruction. Okay, so you have to follow that. That's it. Then it's very easy only to take. If you, for example, you have registered it, if you are planning for, okay, I want to take some practice, right? Here you have the practice. You can go to this practice one, register it. For example, today you want to take it. Yes, you can take it today itself. Okay, so this one, practice. And you can, so it will be very similar to how we'll take the normal or practice also they're asking around $56, 70 minutes. Okay, it's almost 1 hour and it's very similar. So if you want to take, yes, you can take this one, practice also. They're asking $56. But some online practice certifications are available. If you want, you can take it. So you can purchase if you have any voucher code, then you can purchase some voucher code also. It's available already. Some people are there to give the voucher code. It will be less cost only than when compared to this one. So DBT is nothing but it's a data build tool. The answer is 2. Okay, so now you check it and then you note down your answer. You take 1 minute. So what is the main purpose of DBT? So DBT is to store the data or transforming data inside the data warehouse, extracting data from sources or visualizing the data. So it will not store any data. It will not extract any data from source. It is not a data extraction tool that we have seen. So we cannot visualize the data also. So the answer is transforming the data inside the data warehouse. So DBT is primarily so what type of tool it is? Data extraction tool, data transformation tool, data loading tool, BI visualization tool. You can note down your answer and then you can check it. So whether it is correct or not, right? So DBT is primarily a data transformation tool. So it will do the transformation in ELT or ETL. So this DBT will perform T, right? That we have seen yesterday itself. Data transformation tool. So what is DBT's main role in the modern data stack? So whether DBT will store the raw data, building dashboards, transforming data and tracking versioned SQL logic, running machine learning models. So DBT's main role is, the answer is 3. Transforming data and tracking versioned SQL logic. And next question, in DBT, so what are Jinja expressions used for? So why do we need this Jinja expressions, right? Is it for data extraction, automating SQL queries, writing modular SQL with dynamic content, or creating the dashboards? So Jinja expressions, so what is for? The answer is 3, writing modular SQL with dynamic content. So which 2 main versions or flavors of DBT are available to use? So DBT Studio or DBT Shell, DBT Core and DBT Cloud, DBT Lite or DBT Enterprise, DBT Python or DBT SQL. I hope you are clear on this, right? So we have seen in our basic session. The answer is 2, DBT Core, DBT Cloud. So which syntax represents a Jinja variable in DBT? So what is this Jinja variable? So whether we are going with this one, variable, so percentage variable, or this is the variable or variable or variable. So what is the way we will use Jinja variable here? This is for macros, right? So we have seen this is for macros. And this is the answer. The answer is 2, the variable one. So what is the purpose of setting up different environments like a development, production in DBT Cloud? So what could be the reason why we are setting up multiple environments? We set up 2 environments today, right? So development and production. So what is that? So what is the answer for this? So just to go through the options and you fix one answer, you'll see that answer. Okay, to store raw and processed data separately, to allow testing changes before they affect production data, to change between Snowflake and Redshift, to build a dashboard with different colors. The answer is, so because why we are going for development and production? So before going production, so we need to test it, everything, right? So the answer is 2, to allow testing changes before they affect production data. So this is the answer. So what is a DBT model? So we have seen DBT model, right? What is DBT model? Is it a dashboard? or SQL file that defines a transformation, a data extraction tool, or a database? So what is the answer for this? So DBT model is the SQL file that defines a transformation. So the answer is 2. So what does the command dbt run will do? So we have seen dbt run also, and dbt run -s or dbt run -ss model we have given, select statement models we have given. So what is this dbt run will do? It launches the Python server, deletes your models, execute your SQL models, and materializes them as views or tables, or creates documentation for your project. So if you give dbt run, it will execute your SQL models and materializes them as views and tables, right? So this is what views are tables. This is what we have seen practically today, right? The answer is 3. Which folder in a DBT project contains models by default? So where the DBT models will be there, if you are creating a DBT models, so where it will automatically created, is it on the data or models or analytics or transform? The answer is 2, models. It will create here in the models, right? Yes. So what is modularity in DBT? So what is modularity? So we have seen, right, modularity. So writing all SQL in one single file, breaking SQL script into small reusable models, avoiding version control, ignoring data lineage. No, modularity, we are not ignoring data lineage. So DBT is for data lineage. DBT is connected with version control, and we are not writing all SQL in a single file. So the answer is modularity is nothing but breaking SQL script into smaller reusable models. So answer is 2. Okay, so DBT follows which approach for data transformation? Whether it will take Python approach, that is Python first, or SQL first language, or Scala or NoSQL. So what type of language this DBT will follow? So DBT will follow the SQL. The answer is 2. So why is version control important in DBT? So why do we need this version control? Why we are connecting DBT with version control tool like GitHub or Bitbucket or any other version control tool, GitLab or something like that? It stores dashboard? No, it will not store any dashboard, right? It tracks changes to models and allows collaboration. It creates data visualizations. It runs SQL faster. So the answer is 2. It tracks changes to models and allows collaboration, right? So DBT is platform agnostic. So what is meant by platform agnostic? Meaning it only works with Snowflake. It only works with on-premises. It can work with multiple data warehouses like Snowflake, BigQuery, Redshift, Databricks, so etc. It cannot run on the cloud. Okay. So what is the answer for this? The answer is 3. So DBT can work with multiple data warehouses like Snowflake, BigQuery, Redshift, and Databricks. So we have seen multiple platforms, right? So today we have seen. So the answer is 3. So what is a DBT? Data lineage graph. So what is the data lineage graph, and so why we are using it for? To visualize the flow and dependencies between the models, to extract data from sources, to load the data into warehouse, to write Jinja expressions. So DBT data lineage graph is used to visualize the flow and dependencies between models. So the answer is 1. I hope you are also answering correctly. And DBT allows you to create dashboard, add documentation and run test on models, extract data, manage BI tools. With that 4 options, the correct answer is 2. Add documentation and run test on models. Yes, DBT will allow. So which of the following is not a DBT model materialization? So we have seen materialization, different materialization. So what is the answer? Table, view, incremental, and dashboard. So which one is the not a DBT model? Table is a DBT materialization, and view is materialization. Incremental also it's a materialization. Dashboard is not a DBT model materialization. Okay, the answer is the 4, dashboard. If model A uses reference of model B, which statement is true? Okay, so we are referencing model B in model A. So what is the answer? Model A runs before model B. Model B runs before model A. Both run in parallel. DBT ignores dependencies. So this is called dependencies, right? So we have seen 2 projects, right? Project 1 model and project 2 another model. So second model referenced with first model. So here, what is the answer? So model A uses reference of model B. So we are running model A, but it is referencing model B. So the answer is 2. So model B runs before model A, right? Because we are referencing here. So then this will be executed first, will run first, then model A will run. So answer is 2. So consider this particular statement, okay, in DBT. Select star from reference of orders, something like this. So what does this reference orders meaning do? So runs the table name as a string, creates a copy of a table, defines a dependency to ensure the orders model run first, execute SQL immediately. So what could be the answer? This is related to our previous question only. So if we are referencing it, so it defines a dependency to ensure that orders model runs first. Okay, it will go to the, if you are selecting something, it will run the orders first. So then only it will take the select statement. Okay, so I hope you are clear. Hello everyone. Very good evening and good morning to all. Let us start our today's session. So today we are going to start our Snowflake with the DBT live training session. And so thanks for joining once again. Welcome to the session. The session will start every weekend, Saturday and Sunday, 7 p.m. the same time. So whatever today we have started, the same time we will start the session at 7 p.m. IST. And please join the session by at least 5 minutes before or 10 minutes before, so I can give you the access and everything. So I can verify if you are facing any issues, I can rectify it before joining the session. Okay, before starting the session. The Zoom link, I will share it before the session through email, as well as I will create a WhatsApp group for this particular batch, and all the communication I will send it on the WhatsApp group. Okay, so please join with your name. So don't join with your system name. Sometimes you'll be joining with different names, and then I cannot identify who has joined. So please join always with your name. Okay, and so please join the session by 7 p.m. Okay, at least by 5 minutes before, like 6 p.m. or sorry, not 6 p.m., 6:55 p.m. or 6:50 p.m. So please join it. And also, so for this particular entire training, Snowflake data engineering, so please have notebook. So please have one notebook, and whatever we are discussing, just note it down. Okay, so today we are starting with introduction and everything. So just note it down. And if you are getting any questions, right? So while explaining, just raise your hand, then I will stop it and then you can ask your questions, or we will have a separate question and answer session also, like QA session. Like so once I have completed my explanation, then we will go for, I will take all your questions. And please practice it. It's very, very important. I'll be sharing exercises. So please practice it on weekend as well as weekdays. So whichever is convenient for you. So please practice it. Okay, you have to practice it and you have to share whatever you have practiced. Okay, and then I will provide the exercises. So for example, if I'm taking one concept, time travel or cloning or any other concept, so just to practice whatever I have taken and then try to complete the exercises. So once you have completed the exercises, send your exercise, whatever you have completed, like a screenshot, take screenshot, or you take the queries, whatever you have practiced. So send that query to this email ID. So nicitacademy@gmail.com. Then I will check it and then I will respond to your questions. And for example, so I'm taking one particular topic today, and then you are rewatching it tomorrow or this week. If you are getting any questions, so no problem, note it down at that particular time, and then you can ask me in the next session, okay, in the question and answer. So you'll have the QA session every day. Then please ask that questions in the QA sessions, and then you will get all the answers. Even I will guide you how to rectify that particular error. And so, for example, we have 3 hour session. It is not continuously 3 hours. So you'll have break in between, like a 15 minutes break or 10 minutes break. Then you'll have two sessions, like first half and second half. It it is almost like 2.5 hours to 2 hours 45 minutes. So that's why we'll have it. And finally, we will have the project level session in our final. So we are going to complete after completing all the Snowflake concept. Then finally, we will have project level session. There, I will explain that. Okay, so whatever the project, we have architecture and how to explain the project in the interview, and so how in real time project. So everything I'll explain it. Okay, project level session. Any advanced topic, if you have any questions, so don't worry. So I will answer all your questions in the respective session itself. For example, you might be having some questions on, okay, how we will deploy it, Git or something like that. We have separate session for that. Okay, so don't worry. We have separate session for each and every topic. So we will see that concept in detail in the respective session. So what will be there the daily session? Okay, like 7 p.m. I will start. So it will go up to 10 p.m. But today it's not 10 p.m. because today we are starting. So first off, only we will have it today. Then I will give you some time to practice the SQL. Okay, so SQL you have to complete. If you are not from SQL or if you are not from ETL background, so you need to do some workaround for that SQL. And then even if you are from SQL background, so try to complete exercises. So which I'm going to share with you. So that exercises. So you take some time. It's not urgently you have to do. So take your own time and then try to complete the exercises. Okay, by next week, or even you can take some 2 weeks time for completing exercise. The SQL part or EDL part or the enterprise data warehouse or data lake concept. So those you can take it like 2 weeks time. So please remember, for Snowflake should have complete knowledge on SQL. SQL is very important. Even if you are having any questions related to SQL, so please ask me. So I will guide you how to learn it. So complete complex SQL also. So because even if you are going for any Databricks or Snowflake or anything, yes, definitely we need to have a SQL knowledge. So please have knowledge in SQL. So SQL prerequisite learning, I will share it with you. So after this particular session. So troubleshooting session. So we'll have the Q&A, like question and answer. Then I will. So you can come up with your questions. So I will answer those questions. And you are practicing something and you need my help to complete the exercises. Then so I'll guide you, okay, how to complete that particular session. And even I will take your session. Okay, after explaining you are not able to complete, then I will take your machine remotely. I will explain it. Okay, so you can complete this one troubleshooting session as well. And if you ask me, okay, so once after completing the session, and after how long the recording will be available, right? Okay, how can I access the recording and notes, exercises, right? So you should have received this particular login credential. So if you haven't received, so please contact me. So I will guide you how to get this particular login credential. Okay, so just go to this nicitacademy.com. Then you'll be seeing the student login. So just to log in with your email ID and password. So even if you forget password, you can reset by using reset password. So log in to this particular website, go to this enrolled courses, go inside. Then if you see okay, let me log in. Just give me a minute. So I'm going to log in my username. Yeah. So you can see I have enrolled for multiple courses, but for example, you have enrolled for this particular course. Just go inside. Then you'll be seeing that Snowflake Data Engineering DBT batch 4, right? Weekend session. Then if you see start learning, so you can click on start learning, or you go to the session recording 1 to 10, 11 to 20, 21 to 30, 31 to 40. Like this, we'll have sessions, daily session. Just go here, session recording. So click on the recording here and you can watch it. Okay, so after this particular session, so when will be the recording will be available? Okay, the recording, right? If you ask me, then I can say that. So this is like a 3-hour session, right? So it will take some 3 to 4 hours to convert as an MP4 file. Then after 4 hours, I'll be uploading it into the website. Then initially, the video quality will be SD. Okay, standard definition. After that, it will convert it to 4K quality. So it will take some time, minimum 5 hours it will take to convert it. So after 5 hours, if you go and check, so you'll be seeing that complete the 4K quality content. Okay, so this way you'll have the 4K quality like this you'll have. So this way you will have. And if you go a little bit down, you can find the download option. Just to click on the download, then it will be redirect to the Google Drive. So once after completing today's session, I will upload this particular one, Snowflake Patch Introduction, ETL, ELT process. So this one I will post it. So then if you see, then today's one will be available. The recording will be available. Sorry, not recording. The content will be available. Just go inside the content. So you can find, okay, so whatever we have to do. So this is nothing but prerequisite learning document. If you know already SQL very well, okay, so that's completely fine. Start learning that EDL concept, enterprise data lake, data warehouse, all this concept. Then try to complete some SQL, a complex SQL queries. And if you are not from SQL, that much background, so please install any one of the Oracle database. This is nothing but on-prem database. You can practice with Oracle database or the same Oracle queries, right? Same Oracle queries. You can practice with Snowflake also. Okay, so I will give you how to create Snowflake 120 days trial account. So that particular video, by watching it, you can complete it within 5 minutes. Just you can create 120 days trial account. So no need to have any hardware configuration for that. So just you can create the Snowflake account and then you can start practicing these SQLs. So day-wise SQL notes I have given, video I have given. Just to click on the video. So video will be played and then the drive. So you have the drive link here. So if you click on the drive, then you'll find the notes for this particular day. So each day I have given the notes and go to day 2. Then you can find all the notes here. So you'll be seeing the notes here. Okay, so just go inside the notes and then you can start learning it. But if you ask me, okay, whether the Oracle SQL completely applicable in Snowflake, no, it is not completely applicable because in Oracle database, we have primary key, foreign key, constraints and everything, right? But in Snowflake, we have constraints. except not null, all the constraints are not enforced, meaning that it is not enforced, meaning, so even if you are creating a column as primary key in Snowflake, so it will accept duplicate. Normally it will not accept, right, in any other database. If you are creating any column with the primary key or not null or any other column, this constraint, then you cannot insert duplicate value here. You cannot insert null value. So in Snowflake, only not null is enforced, meaning not null constraint alone, it will work. The other constraint, it will not work in Snowflake. Even if you're creating with unique, it will accept duplicate. Okay, so that's why some concepts are different, but start learning this one. So either by using Oracle database, you just install it. So I have given here installation link and everything. So just install it. This is the installation link I have given, Oracle 21C installation link. And complete SQL, you can start learning from here. PLSQL I can learn. Even if you ask me, okay, do I need, whether I need to learn complete PLSQL? No, not complete PLSQL, at least basic SQL, the PLSQL syntax. So what is PLSQL? What is anonymous block? So what is procedure functions, right? So this one, please start learning it, because these procedure function, anonymous block, and all this we will see in our Snowflake as well. So while seeing it, you'll be, so you can get the whatever the concept. I'm going to explain it. Okay, so 100% you can receive that. So that's why please complete all the SQLs. I will give you this particular document, so please start learning. And even if you want to learn some ETL concept, so please start learning here, ETL concept. So Snowflake data engineering, it's nothing but ETL. So not completely ETL, it's like a ELT process. So that we are going to learn. So you should know what is ETL, what is ELT, all this process that I will explain it today. Then these are the content we have. ADF if you want to learn. So you want to learn Python here, you want to learn Unix. So everything I have given the link. So these are some prerequisite learning. Okay, you should have knowledge. So if you have already from this background, so no need to do again. Start learning Snowflake. And in Snowflake, if you are finding any events is happening in your hometown or in your place, so just register for it. So not for paid one, just a free event will happen. Okay, then please attend it. Okay, if you are looking for the practical knowledge and so advanced concept in Snowflake, yes. So they will reveal all this advanced concept in the submit only, Snowflake submit only. So if you get a chance, so please register it for this kind of event. Okay, this is all about the course content, where we can see the recording, where we can get the document and everything. Okay, I hope you should be clear now. And just to go inside the website, please sign up first. If you are already signed up, then I will add that course in the backend so that you can see the course. Okay. Even you can ask me one question. I do not have the system, very high configuration system I do not have. Still, can I go ahead with the Snowflake learning, or Snowflake, can I use it? Yes. Snowflake is a software as a service, right? So it's like a software as a service. It's a web-based tool. In this web-based tool, just we have to create a Snowflake account. It's a web-based UI, right? So your Snowflake account we have to create, cloud account. So from the cloud account, all the configuration, everything we can do within this cloud account itself, web UI itself. The web UI of Snowflake is called Snowsite. Okay, Snowsite. So anyhow, Snowsite and everything we'll see later. But if you ask me, since it's a cloud, so you need to have 4 GB RAM, minimum 4 GB RAM, and you can have Windows 10 or 11. Mostly you'll have 11, and at least 200 GB of space in your hard disk. And how do I install the software? Okay, for example, if you want to learn Snowflake completely, no need to install anything. So everything I will tell you. This 120 days trial account, right? So 120 days trial account. So I will tell you how to create it. We have the working session. So you can create parallelly than whatever I'm creating here. This one we need. Okay, this is nothing but Snowflake one. Okay, cloud one. So cloud one, I'm going to take AWS Azure, and GCP. Okay, GCP, these three platforms. So that I'm going to cover. So no worries, you will get basic idea about AWS, Azure, GCP, and all this. So then if you are looking for extra knowledge, then start with on-prem databases like Oracle. So you can install it like Oracle 21c, just install it, start practicing it. So even if you are looking for any ETL concept, so ETL related concepts you want to learn, just go to this one, ETL concept. You can start with Power Center learning or IACS learning. So anything is fine. So start uh, learning from my YouTube channel itself. So that is more than enough. Okay. So how can I practice the daily session? So you have to, whatever I'm teaching, that you have to practice it. In addition to that, you have to complete exercises. So please completing exercise if you want to get 100% of my training. Okay. Then each session level, we will have the exercise and you have to complete it. So when will the project related session be held? So project level session will be held so almost at 80%, which I have completed the concept, technical concept on Snowflake and everything. Then we will have the project related session. So for both Snowflake as well as DBT, so how the architecture will be and everything we will see. So this is a project level session. Okay. So I hope I have answered. So if you have any questions related to how can I access the material and related to the training, please ask me now. I will answer it before going to the actual session. So please feel free to ask your questions. So have you all registered for this particular Snowflake site? So the meaning I'm asking you whether you have signed up this website. So then if you have signed up, then please allow me 1 day time today or by tomorrow morning first off. So everything I will do it, creating the WhatsApp group and adding your name into the website and the Google Drive link and everything I'll do by tomorrow morning. Okay. So I will follow up with you. I will take a responsibility to complete it. Okay. So don't worry on that. So I will follow up on each week. So you have to complete all the sessions so that I can give you the assurance. So please complete it. Yeah, yes, Anisha, please go ahead.
Chandra, I'm audible.
Yeah, you are audible.
Yes, Chandra, I was able to access the videos you shared this morning, but do you mean this NIC IIT Academy or the Snowflake University?
No, NICIT Academy. I'm talking about
Yeah.
NICIT Academy
I was
videos.
able to log in with my email ID actually.
Okay, no problem. Yeah. Then you have access. Then you will get access for this batch 4. Okay, batch 4 as well. Yeah, I will do it by tomorrow morning. Okay. So I will create a WhatsApp group for everyone. Then I will communicate into the WhatsApp group. Okay. So for any updates for this particular batch, I will communicate through WhatsApp group itself. Okay. So any other questions for this training? Okay. So now, so we will move on to the actual training session. Okay. So we will start with the enterprise data warehouse and data lake. So that knowledge you should have. So you might be from ETL background, right? Or you might be from different background. So let's say we have this particular Snowflake environment. So think about this is Snowflake. Okay, this is the Snowflake, or this is just a enterprise data warehouse we have. So initially, so we have the enterprise data warehouse, right? So how we have enterprise data warehouse? So this is our entire data warehouse. Okay. So normally I want to take business reports, then initially what type of databases I used to have. I used to have like a Oracle database, right? Maybe it's Oracle Exadata also. So Exadata is nothing but Oracle. We have the data warehouse environment. We can create on Oracle Exadata. And you may have Teradata, right? So we might have Teradata in our project or SQL Server, like Microsoft. From Microsoft Corporation, we have the SQL Server. So this kind of databases, we might have used it, or data warehouse related. So this warehouse is called enterprise data warehouse. Okay, this warehouse is called enterprise data warehouse. So enterprise data warehouse, right? So initially we have this enterprise data warehouse, nothing but we'll call it as EDW. So EDW is nothing but enterprise data warehouse. Okay, so we have the warehouse here. In the enterprise data warehouse, in our traditional data warehouse system, so what we had, like we have used only structured data. Structured data means data like tables, right? We have the data on the tables like a structured data. So mostly like structured data. Structured the meaning like how we have the tables, right? The rows and columns. So that's what we used to have, structured data. Then from here we will take business reporting. Okay, from where we will get the data for this particular data warehouse, EDW. So enterprise data warehouse, we have the heterogeneous sources, right? So left hand side, we have the heterogeneous sources. So we have data from RDBMS, that is OLTP system, or we may take the data from different systems, like we have cloud platforms, and we may get data from third-party vendors through APIs. Yes, we can take data from API as well. Okay, we can get the data from APIs, and we can get data from applications. So different applications we may get data, right? So different applications, so we can get the data. So like this, we'll have different platforms. Different platforms we may get data. Mostly like RDBMS, right? So we have the database, relational database management system. So RDBMS. So we have RDBMS, right? So relational database management system we have. Then we have we can get the data from the file system. Okay, so we may get data from files, like files meaning CSV file, even some files are from TXT file. Yes, Excel file if you have. So we can convert that Excel file data into CSV, and then we can process it sometimes. And we have the different files like JSON file, XML file, all kinds of files. Then Avro file, Parquet file. So different files. So yes, we have the file system. So this file system also will get either by in-house application, we will get the file, or we may get a file from the third-party vendors. The meaning, okay, different vendors. For example, you have one particular company, insurance company. That portfolio, any third party application can maintain the portfolios, right? For example, if you go to some bank, they'll say, okay, you want to maintain your mutual fund and everything. So if you take one particular bank, they will have some different product, right? So different product from their bank, or they will ask us to get log into another applications. Okay, so create an account. So from there, start building your portfolio. So that's what they will inform us. So we can go to that one, then we can build our financial stuff there. It may be the mutual fund or the investment, different investment, gold investment or property investment or any investment you can do. And then all this portfolio management will be maintained in that application, and the data will be flowing for reporting purpose. Okay, what kind of report? At the end of the day, so how many newcomers, new customers has taken this particular product, right? So that way I have to do analysis. So we can extract the data from here, and even that data will go to the another third party also for different process. We can send the file. So we may get the data from third party, or we can send the data to third party here. So that we will send the file system, and so we may have data from APIs like applications, real-time data we can take, and we can take data from cloud also. So cloud applications also we can take. So in-house applications. So even we can take data from applications like a CRM. So like this, we might have different applications, right? So we can take data from different application as well. Different applications. So like in-house application, like we may have CRM, customer relationship management, ERP, enterprise resource planning, other Workday or NetShoot, Marketo. So different applications we may get data. It's all about customers' data, their employees' data, or portfolio data. So this way, it depends on the domain, we will get it. So it's nothing but application. Okay, the application data also we can get from the source system. So these are like heterogeneous sources. So what kind of source system will say? It's like heterogeneous. So this particular source system is called heterogeneous sources. So this way we'll say heterogeneous sources here. And initially, if you are from Informatica background, Informatica Power Center background, so we will do the ETL process, right? So ETL process. So what is ETL? Extraction, do the transformation. So do the transformation logic, all kind of transformation. So extract the data from the source system, maybe file you can extract it, or you can get the data from APIs, or you can get the data from the cloud, right? So you can take the data from the cloud, or you can take the data from the applications. So different applications you can take, and from these sources, so we can perform the data transformation logic by using this ETL tool. So it's nothing but ETL. So ETL is nothing but extraction, transformation, and loading. So it's not like a one single layer we are just extracting and do all the transformation here. Just we will extract it from here, load it into the staging layer here. So after that, we will move one by one, all the layers one by one. That architecture, we will call it as medallion architecture. So that also we will see later. But just we are moving the data here. So this is nothing but ETL, mostly like a batch data. Mostly like a batch data. So what is the meaning of batch? It's nothing but, okay, so think about today the business is happening. All the business related data. Okay, if you are a customer to a particular bank, and then by using the bank card, you are doing some transaction. Yeah, this is transaction, right? So all the transaction will get stored in this particular source systems like RDBMS. We'll call it as OLTP here, file system, APIs, and everything. At the end of the day, we need to take the reporting. Okay, for today, we will say report up to yesterday, right? Yesterday only, because that is the nothing but ETL batch. This is daily load. So daily 7 a.m. we'll extract the data from here, or by 7 a.m. we'll complete the load. So 12 a.m. to midnight 12 a.m. we'll start loading the data, doing the transformation logic, and load it here. So this way we will perform. It will have multiple layers. Just I'll put this way. Batch is nothing but it's a intraday or daily, monthly, weekly, yearly. So that way we'll schedule the job. So this way, if you are scheduling it, extracting the data from here, do the transformation logic, and load it here, right? So then this will be consumed by business analytics team. If you take banking, okay, if you take banking, business side and IT side will be there, two different departments. IT meaning the professionals will work for IT, technically they will work for. Okay, business is asking one new application they need to launch. This is the tables and everything we need. So then they will contact the IT managers and they will build the application, they will build the platform and everything. Then they will move the data. So finally it will reach to business analytics team, right? So business analytics team, they will be taking the data from here They'll be doing the they'll be doing the data visualization here. So data visualization, it's nothing but business reporting or business analytics. It's analytics. Business analytics will perform. So what kind of tool we will use? So any idea what kind of tool we'll use here? So we'll use like a Tableau. So mostly like Power BI nowadays, right? So we'll use Power BI tool. If you are from this one GCP background, they might be using Looker also, or if your company is using AWS, then we'll have the quick site. Okay, so quick site here, and similarly we'll have more reporting tool. So from here only they will take. So what is this process is called? This process is called business intelligence. Am I correct? Business intelligence, right? So business BI. So BI is nothing but business intelligence. At the end of the day, I want to know so how my business is going on. Intelligently, I have to track all my transactions, and I have to do some analysis. This is called business intelligence reporting, right? This is called business intelligence. Okay, so nowadays it's not only for business intelligence, right? So all the companies, each and every company is moving towards on the AI side. So then they will ask, even if you ask me, so what is ETL? So what is ETL? ETL is nothing but extract, do the transformation, transform, and load. Okay, so load. So this way we'll do. So extraction, transformation, and loading. So this is nothing but ETL process. Okay, so where the ETL we will do by using the ETL tool. For example, Informatica Power Center, that's on-prem ETL tool, right? So we'll call it as IPC, Informatica Power Center, or IACS, Informatica Intelligent Cloud Services, or Intelligent Data Management Cloud, IDMC, or we can go for SSIS. If you are from SQL Server background, we are the SSIS previously we were using. A lot of tools are there, ODI, right? ODI, then Ab initio. Like this, we'll have. So Ab initio, like this, we'll have multiple tools we have. So by using any one of the tools, we'll perform the transformation logic. Am I correct? We'll perform the transformation logic. Yes, we have the tool. By using that, we'll do the transformation logic. So this particular process, okay, these are the ETL tools are available. So this is extraction, transformation, loading. What kind of tool we'll use? These are the tools. Okay. So this process is called schema on write. So what is the meaning of schema on write? Schema on write means schema is nothing but this is called schema on write. So schema on write means, so what is the meaning? I'll tell you. So schema on write meaning, the schema is nothing but, okay, if you take, this is my table. So what is the table of the schema of this employees file, right? So employee ID, first name, last name. This is the schema. This is a schema. Okay, so we are building the schema and then we are putting the data here. So that's nothing but schema. So schema and write means, okay, while writing the data, so here inside this EDW, we will build a schema. For example, if you are writing any data into customer table, we should have a customer table already. Then we'll be loading the data into the table. So if it is customer table, if it's a dimension table, if it is a fact table, and it should have the dimension modeling concept and everything, star schema, snowflake schema, and everything, right? So that everything will follow the schema, and the schema meaning while we are writing that data into the table, we will build the column names, like everything will have the table and everything. Then while writing itself, we will follow. So after that, everybody wants to move their platform into modernizing it. What kind of tool they might be using it? Because they need to handle not only structured data, right? So that's a need. Not only structured data. So since our everybody is moving towards on the cloud side, and they're looking for other tools. So here we'll handle structured data, semi-structured data. It's nothing but JSON file, XML file, all this file, semi-structured data. And then we have unstructured data, unstructured Okay, so unstructured. So data we have structured data, unstructured data, everything will handle it. We need to handle it. So that's why. So unstructured data also we need to handle it, right? So that's the reason the companies wants to move their platform into modernizing it. They want to modernize it, right? So that's what they want to modernize it. Okay, what kind of the platform they started? So initially they have started with AWS, right? So we are the sorry. So we need to handle this semi-structured data, semi-structured data, unstructured data coming from the source system, right? So then we need to have the platform. So initially companies started with the platforms like AWS, right? We have the AWS here. There is a need for this particular structured data, semi-structured data, and unstructured data, right? So these particular databases cannot handle structured, semi-structured, and unstructured data. So that's why the companies wants to move from this platform to the cloud platforms like AWS, Azure, or GCP, or any other platform. They initially started with these platforms. Then after that, so even they need to have A and ML process. They need to process enormous data. So then they moved their platform into modernizing it into the other platforms. Okay, just I couldn't write it. I'm not sure why. Let me go to the one which I have taken already. So whatever we have in our on-prem databases, then we moved on-prem databases into the cloud platforms. Okay, so cloud platforms. So that's why we have started with the company started with the cloud. For example, if you take this particular architecture, this is what I have explained. So first we have the ETL. We'll do the schema and write. So while writing the data here, we will build a schema. So that will handle only structured data. Business intelligence reporting will do business analytics. So mostly we'll do the data engineer. So ETL, developer, data engineer, data analyst, we will follow here. But they want to modernize their platform. Then we started with Azure, AWS, and GCP. If you take Azure, in Azure environment, we have, if you ask me, so what is the data warehouse environment in Azure? That's nothing but Snaps. Okay, we have the Snaps Analytics. On AWS, we have the Redshift. On GCP, we have the BigQuery. So please remember the same kind of the data warehouse environment only to handle structured data. So in these platforms are Azure, Snaps, AWS, we have the Redshift, GCP, we have the BigQuery. These are the platform. So while explaining these platforms in our session, I will explain it. What is it? Snaps Analytics. Everything's like a cloud data warehouse. That's it. It will store the data like a table. So how we have the Teradata, Netisa, Oracle Exadata, SQL Server, everything. And if you want to store data as a file, okay, I have the file in CSV. So that file I have to send it here. I have to store it. Then I will have in Azure, we have the blob storage, or we will call it as ADLS Gen 2. So ADLS Gen 2 means Azure Data Lake Storage Service Generation 2. So that as well we'll see. I will explain it while seeing in our Azure session. In AWS, we have S3 bucket. So here we'll call it as container. So here we'll call it as S3 bucket. And GCP we have a GCS bucket where we can put the file and then store it there. And then from file to data warehouse, we can move it. Okay, this is what we have. And we have different services here in AWS, Azure, and GCP. We have different services. Like in Azure, a lot of services are there. For ETL services, I will explain it later. We have services by using that we can perform all kind of business intelligence reporting, data science as well. But they do not have much more features than what these companies like a Snowflake, Databricks companies. Snowflake is a separate company. Databricks again, it's a separate company for data processing, Apache Spark. So they have on top of Apache Spark, they created one more framework like for A and ML workloads and BA workloads. So that platform will call it as Databricks and Snowflake. So these two platforms, it's a highly scalable, okay, highly scalable, and it's a fully managed cloud data warehouse. So fully managed meaning the Snowflake will manage everything from A to Z. Snowflake Corporation will manage it. We have to pay for the service whatever we are taking. For example, I'm taking time travel. I'm taking the queries. I want to run it. I want to store more data. Then whatever the services I'm looking for, then I have to pay for that. So like this, the companies wants to move their platform into Snowflake or Databricks to have more data and two different data processing. One is for business intelligence reporting. For example, what is business intelligence reporting? Think about you have one business. At the end of the day, you want to track your business, right? So how your business is going on, how many customers you got it newly today, and what is the sales today? So how much amount we have spent for marketing, and so different forecasting and everything, right? Also all the data, whatever you are seeing. So that's a business intelligence report. If you want to run your business, then if you want to run a business in a profitable way, then definitely you should have a business intelligence analytics reporting, right? So that will have. So nowadays, artificial intelligence, the meaning, the business intelligence, business team from VP side or director or manager, senior manager, from the business end, they'll have the complete business knowledge. If they're adding a new product or new services, they will have the knowledge and then they will say, okay, the data is flowing here. So if you are purchasing one particular product, these many tables, it will make an entry. And if you are canceling it, this is what the data will be flowing. All these days, they knew it already, okay? But AI side, and then they will take a decision. Business intelligence professional, so they will take a decision here, right? Yes. But here, AI side, the machine will take the decision. Okay, we will train the machine and then, okay, will give the instruction. So this is the data. If you are getting it, okay, spend this much. And this is many customers you are getting, send the customers something like notes or reward points, something like that. So you have to engage customers and everything will set up and then AI will take care. So that we have to train the model. So who will use it? Data scientist. And from whom we will get the data? So whoever we have the data from the source system, just what we will do, okay, since many members are there to access our data, so first we are saying that, okay, don't do any transformation logic. You just extract the data as it is from heterogeneous sources. You may have data from Oracle, SQL Server, DB2, files, APIs, and in-house applications, right? Everything or software as a service. So anything if you have, just extract it. Don't do any transformation. Load it into this platform. Okay, just dump it. Whatever we have, just text, batch data or streaming real-time data. So everything you can load it here. That's nothing but raw data. Okay, raw data. Please remember in the data lake side, data lake, enterprise data lake. This is enterprise data warehouse side. So lake is more than that. In the enterprise data lake, so everything mostly like a cloud platform. So whatever the data we are getting from the source system, extract all the data. Okay, extract all the data, load it here, one single format, the Snowflake. Just load it. After that, do the transformation logic. So raw data will be loaded here. On top of that, we will build a schema. So that is the meaning schema on read. While reading the raw data from here, we will build a schema and then we'll create like a staging, QA, intermediate layer, or the different layers we'll create. So project level architecture we'll see later, but we will create a schema on read. While reading the data, we'll build a schema. So that's what we'll have. Data scientist and BI. Okay, if you are from BI team, you take the raw data, do the BI intelligence reporting. If you are from data scientist team, data science team, you take the raw data, do the train the model, and do all the kind of artificial intelligence rules here. So that we will do. So nowadays we have the lake house. Okay, sometimes in interview they'll ask what is the meaning of lake house. So we know what is EDW, enterprise data warehouse, right? So warehouse can handle only structured data, but now we need to handle structured, semi-structured, unstructured data. So if a platform can handle all kind of three types of data, so that's the meaning. It's nothing but data lake, right? We are just loading the data here. We are performing. So now, if you take AWS or Azure or even Snowflake, Databricks, and everything, it's not only doing the EDL or EDW. So both it can perform. Okay, you want to handle only structured data for BI? Yes, you can create structured data. In AWS, we have Snaps Analytics. We have Redshift. In Azure, we have the Snaps Analytics. GCP, we have BigQuery, right? So this way. So you can have EDW as well as data lake. Both we can have in single system. So that is nothing but lake house. From the data warehouse, the word house has been taken. And from the enterprise data lake, the word lake has been taken. So that's why lake house. It's nothing but data lake plus data warehouse. So whatever we have, data lake and data warehouse, that's we have. So delta lake means we have on top of this data lake, we can, if I want to perform only the asset transactions, right? So how we are performing DML operation, DDL operations, sorry, not DDL, DML operations on SQL. Similarly, if you want to, so here we will call it as asset transaction. Okay, ACID, asset transactions. So if you are going to learn this one, Databricks completely, then you will learn this asset transaction completely. So, but think about, okay, Delta Lake, that's a different concept. So these are the platform. This is the architecture. If you go any project, right, this is the architecture you'll have. So what is ELT? Extract, load the data here as it is into the raw layer. Then from raw layer to another different layer, we will perform the data transformation logic. Okay. So any questions here in this architecture? So please feel free to ask your questions. And yeah, please go ahead.
Sir, Synapse and Blob are two different services, or it's the same?
Okay. So for example, you have a AWS. Okay, you have AWS here. Think about you have AWS here. In AWS, we have 100 plus services. Okay, AWS. Think about this is AWS. You are getting some file from the source. So how will you store the file inside the AWS? Just we will stream it and then put the file in the container. This container is called S3 bucket. Okay, this is called S3 bucket. So S3 meaning simple storage service. Okay, this is nothing but simple storage service. This is S3, just to put the file. Then we will have a data warehouse environment, data warehouse. So this in AWS data warehouse environment is called Redshift. Okay, Redshift. So you just load the data here to S3 as a file, and then from S3 to Redshift, we'll perform the transformation logic and do the EDW here, enterprise data warehouse here. It's a cloud enterprise data warehouse. So if you take Teradata, that is on-prem. For example, if it is on-prem, your company has to deploy that server, network, and everything they need to take care, and they have to do. But if it is a EDW, that is nothing but it's a cloud. Everything will be taken care by cloud, right? So this way, so this is nothing but data warehouse, Redshift, S3. So similarly here, if you take, so what I explained, right? So if you take blob storage, it's a bucket container. We can put the file, and Snaps Analytics is a data warehouse. Where? In Azure. In AWS S3 and Redshift here. In GCP, we have the GCS, Google Cloud Storage. It's a file storage. File only you can store. You cannot load the data at the table, and you cannot query it. If you want to query it, this platform you have in S3, we have Athena service, you can query it. And these are the cloud platform, cloud data warehouse. But nowadays it's not a warehouse, it's a lake house. So you can do both warehouse as well as data lake. So both you can do by using Snowflake as well as Databricks. So here we are seeing the Snowflake, right? But yeah, these are two different services available in Azure. Blob storage to store the file, and Snaps Analytics for the data warehouse, like it will have the tables.
Got it.
So any other questions for this particular architecture?
Sir,
Yeah,
I
please
have
go
one
ahead.
question. Sir, in the ETL, we are using ELT process, correct, sir? Like which tool we can use the copy from the source to target or destination?
In ELT?
ELT, we are using like ELT process, correct?
Yeah, correct.
Yeah, we are copy the data from the source
Yeah,
and
exactly.
we are
Yeah, good
storing the,
question. I
yeah.
did not mention here because if you take, yeah, so here we are using Informatica Power Center or SSIS, ODS, ODI, ab initio tool, right? But here, which tool we can use? So if so, for example, ELT, we can use again Informatica Cloud also, because Informatica Cloud, we can use it. We can connect the source system, do without transforming any data. You just move the data from source system to this one. Okay, source to target. Just to move it, raw data, Informatica Cloud. You can use Informatica Cloud just to move it. Okay, this is called Informatica Cloud. So then we can have Python. Okay, so that I will tell you. I will explain it. Python we will take, and we'll go for Matillion. It's another tool. Matillion we can take. Okay, Stitch we can take. Stitch is another tool. So these are the some tools are available. Airbyte is tool we can take. Okay, these are the tools for extracting data. Okay, I don't want to use any other tool. Then you can use inside the Snowflake itself. We have a tool called Snowpipe. So you can create an external stage from external cloud platforms like Snowflake or Databricks. Sorry, not Snowflake, like an external platform like Azure, AWS, GCP. You can put the file, and then you can continuously ingest the file into Snowflake. That is called Snowpipe. Okay, just these are the tools. So here we have these tools, right? Here we have these tools. A lot of other tools are there. Airbyte we have. Okay, these tools we can use it. We can bring the data here. Snowpipe is like one tool from Snowflake itself, right? Like a tool, just we are creating a process to ingest the data from here to here. Raw data will get ingested, micro partition file, micro batches, it will be moved here. After that, we will do the transformations. For that, either you can use Snowflake SQL queries or you can use DBT. Got it? So that's what a DBT will be used. So DBT is only for data transformation. Okay, only for transformation. It's not for data extraction. So extraction is meaning we are extracting the data from the source, right? But transformation is meaning we are, okay, think about the particular company, insurance company or banking. They do have business in Citibank. If you take Citibank, they do have banking in multiple countries, right? They do have operations in multiple countries, and the software, sorry, they have the ODCs in multiple countries, employees multiple countries, business in multiple countries, right? They'll have multiple currencies. All the format will be different. Government policies will be different, right? So if you take China, country policy is completely different. If you take USA, different. India is different. So each and every country will have different currencies, different complaints, security policies, and everything. So everything we have to apply. And so think about how they will go for this at the end of the quarter. They want to go for some quarter end result. So they will convert everything into single format, right? So then only, okay, what is the budget we have spent for this last quarter and what is the forecasting, everything we'll do. right? So that way, whatever you are performing, so that's nothing but data transformation. Where we can do the transformation? For DBT, we should have a data inside the Snowflake or inside the Databricks or inside the Azure platform. Then only we can do. So DBT will not store any data. So it will do only transformations. Then data will get stored in this Snowflake itself. You got it? These are the tools.
Got it. Sir, I have one more question. In Databricks or Snowflake, we have like a specifically dedicated data storage.
No, Databricks also, it cannot store any data. Only some caching data it will get stored. Data caching will get stored, but they will not store any data. What they will do, they will take storage from any one of these platforms, any one of the platform. While creating Snowflake account, you need to define, okay, on top of which platform you want to create the Snowflake. So that we have to do it. Okay, if you take, so think about one business, I will say. It's like we have in India, we have Ola and Uber, right? Ola and Uber. Best example for software as a service. So why? Because whether Ola or Uber, whether they are owning any cars they are owning, no, right? The hardware they are not owning. Whether they are maintaining any drivers, no, only drivers data will be maintained. They're not going to deal with the drivers, right? So they will have like they will say partners. They'll say partners, business partners, right? They'll not say it like a drivers. And then whether they are maintaining any insurance or maintenance or parking or any other thing they are maintaining, no, nothing, right? So what they have done it. So they have built the software, right? They built the software, and then they have integrated the customer. They integrated the drivers. Okay, so we have 100 drivers, and then we have the 100 customers. If the customers wants to go from one place to one place, that is the requirement, right? Yes. Then this particular software will look for the drivers nearer to that. Then they will assign it. So this is nothing but, okay, they created a software, and then it is dealing with the customer and everything, right? So customer and the drivers. So similarly, Snowflake will not own anything. Okay, Snowflake, they created the software where they will store the data. Okay, they already they decided. So we have three different cloud platform, major platform. Why can't we use that platform for our storage? Why we have to build our own data center, right? So we have already Azure, we have AWS, we have GCP. The similar way we have in our IACS also, right? Informatica Cloud. So Informatica Cloud, they will not have any data center. So whatever the data center, AWS or GCP or Azure they had, so that particular data center only, they will use it. So software as a service. So Snowflake also will not own any storage. They will store the data on top of this AWS or GCP or Azure only. Okay, clear? Anyhow, while explaining the Snowflake architecture, I will explain it very clearly because I haven't started any the Snowflake architecture, but this one. So EDL, ELT, ETL, APIs, batch data, real-time data, right? So all this you are clear? Yeah, yes, Akhil, please go ahead. So what is your question?
Yeah. Sir, actually, ELT is a schema on write, and sorry, ETL is a schema on write, and ELT or schema on read. When a data handle avoid the duplicacy, if it is use the ELT, then we use the different transformation to avoid the data duplicacy. When ELT is only load, then after transform it. Please.
Exactly. Because that's the reason for the architectural behavior, Snowflake or Databricks, both environment cannot enforce primary key, unique key, or any other keys, foreign key and all. Okay, whatever the data you are sending, just load it. It will not check for duplicate. It will not check for anything. Just load it, dump it, all the data. While extracting the data, you build a logic to take the deduplication. Okay, build the deduplication logic. For example, you have loaded today one data, we will have the audit columns, like timestamp column. By using the timestamp column, group by the some ID column, key columns, and then take the latest record. So that's what we will do. So all the record, we will maintain it in enterprise data lake. Then the data curation layer or anywhere, just we will build the transformation logic. We will remove the duplication. That is nothing but while creating the SQL queries on top of Snowflake or Databricks. While reading it, we will build the schema. So that's what schema and read. Okay. So how to remove the duplicate? So how we will handle the duplicate, everything we have the session. I will explain it. Okay, later. But yes,
Yes,
whatever you said, it's correct.
yes, sir. And one more, my confusion is that actually, if it is loading a data with the help of schema on read, so how we consider ki faulty tolerance, how to, yeah, that's
Yeah, everything will handle it by using the SQL queries only.
yeah,
Okay.
okay.
So everything. So just load the data, not only structured data, like a three kinds of data we will load. Only structured, semi-structured, unstructured data. So we have session for all these data, but mostly unstructured data, the AI scientist will use it. Data scientist will use it, but I will explain it. Structured for CSV, TXT, all these files, Excel files and everything. Semi-structured data, we have the JSON file, XML file, Avro file, Parquet file, different files. And unstructured data, we have the some PDF files. So that we will see later. Okay, so all these kind of data we have to handle it. And so if you are going to perform the transformation logic on top of the data only, will on whatever the data we have in this platform, then we'll perform the data transformation logic. Okay.
Okay, thank you, sir.
Okay, so this week, so please go through this particular prerequisite learning. Okay, so all of you, please complete this prerequisite learning. So I'm expecting you to complete this prerequisite learning. For example, even if you are from SQL background, okay, so take some SQL complex SQL queries, try to resolve it. So DDL, DML constraints, don't do this. Okay, so constraints the way in Oracle the works, how it works, and Snowflake how it works, it's different. Select statement, single row functions. So except the day 3, so please practice all the sessions in this Snowflake or Oracle itself. So indexes is not there. Index concept is not there in Snowflake, but other concept, please learn it. Performance tuning, merge concept. So definitely merge concept, you should have complete knowledge. Merge, we will use it. Views, we will use it. So different views like normal view, secure view, materialized view, all kind of view. Analytical function, that is nothing but window function. Set operators, subqueries, common table expression, that we will use. And we have the aggregate functions, join, single row functions. So all these concept should have 100% knowledge. Okay. So for example, you take day one, Oracle day one, take 2 days, try to complete. Okay. Then next day two, take 2 days, then complete. So it's up to you. Take one day or complete it to just a 1 hour, right? So 1 hour or 40 minutes only. Just to complete it within 10 days, you can complete all the sessions. You can become master in SQL, but you have to practice it. So have this SQL developer. So go here, please install it, this SQL developer, and start practicing this SQL. Okay, for example, if you this is the SQL here, so you will have the HR schema and start practicing all the SQLs here like this. Okay, so here start practicing all the SQLs day 1, day 2, day 3. So this one, SQL developer. If you have any questions, how can I install this SQL developer? Then either you can go for 11G installation or 12C installation. So this one I have explained. So please go through that. Please try to complete at least SQL completely, because whenever you are going for any client interview or any kind of interview, right? For Snowflake or Databricks, they will ask questions on SQL only. Okay. So that's why whatever SQL for Oracle, just to complete it. For this one, whatever we needed for Snowflake, so that I will explain later. Okay, no worries. That I will explain later. Any questions? for this prerequisite learning? Will you complete, if you are from non-SQL background, will you complete the SQL day 1, day 2, day 3, all these sessions? And if you stuck somewhere, please ask me some questions. Okay, note it down and ask me questions. And data, where goes data lake? Do you have any questions? ETL, ELT, enterprise data, where goes data lake, lake house. So what is lake house? So what is the difference between A and BI? So all this they will ask, right? Questions, something like that. If they are asking, now you should have the complete knowledge. So even you can do some research on this and then you can perform. So please ask me if you have any questions. So this particular first week, okay, before coming to the fourth Saturday, I'm expecting at least you should have completed 5 sessions in SQL. If you stuck somewhere in SQL, so please ask me. I'll be available morning time, like after 9 o'clock. I'll be available up to 11 o'clock. So 9 to 11 I'll be available. So please ask me on weekdays, and so try to complete exercises. Okay, SQL you have to be very strong before going to our Snowflake. So from next week onwards, I'm going to start with Snowflake architecture, and from next week onwards, it will be a 3-hour session each day, like Saturday 3 hours, Sunday 3 hours. Like this will have. Up to 8:15, I will take the session. Then we'll have 15 to 20 minutes question and answer, and then we will have 10 minutes break or 15 minutes break. Then again we'll have one more session. Okay, like that we'll have. So please feel free to ask your questions. So don't hesitate. And even if it is, don't think about, okay, whether this, can I ask this question or not? So I welcome all the questions. Please ask and have it clear answer for that. Okay.
Whatever the Oracle SQL sessions you have showed, right? Can I practice that on SQL Server?
Yeah, you can almost practice it. Okay, so you can 95% it will be there in SQL Server as well. But 5% of the SQL queries, okay, some questions except something like minus, there it will be used as except something like that. Only some few keywords will not be there. So if you are getting any error, so whatever I have explained in Oracle, if you are getting any error in SQL Server, then just leave it. Okay, that's directly it's not available. You can use some Google it to get the details. Okay, what is the equivalent in SQL Server, and then practice it there. But other than that, everything same. But you have to build that HR schema. If not, just create some. You have online Oracle also. You can go to some Oracle online Oracle SQL. There are, you can directly practice it. No need to install anything. So cloud Oracle instance are available. So you can take it, and same thing you can practice there also. HR schema will be available.
Okay, got it. Yeah.
Just to Google it and practice it. Okay.
Okay.
And if you are from completely SQL background, then go for complex SQL. Okay, I have given some exercises also there. Okay, so if you need some exercises on SQL, if it is not there, just please connect with me. I will put some exercises also. So please try to complete those exercises. Okay, so some scenario-based SQLs, then it will be useful for you.
Yeah, thank you, sir.
So this week, like a prerequisite learning, like what is EDL, EDW, all this you have to learn, and you have to go for SQL concept. From next week onwards, we'll have the 3-hour session. Then I will start from, okay, installation, not installation, creating the trial account for Snowflake. Okay, so then I will start with Snowflake architecture. So what is that architecture? 3 different layers and everything will take. Okay, cost management, everything. Next week we'll see. And data loading will start one by one from next week. Okay. Okay, if you don't have any questions, today we'll stop it here. And from next week onwards, we'll have the session starting from Snowflake. Okay. So thanks everyone. I'm stopping here and we will continue our session from next week. So please start learning the prerequisite learnings, okay? Yeah. Yes, complex and scenario-based SQL questions. Sure, I have. So I will put it in the same folder itself. So introduction to SQL, this one, this folder prerequisite learning day one, I will put it here. In the same folder, I will put it some complex SQL queries. So that you can practice it and then share answers. So take it in that way. Okay, I will complete these questions. Then your knowledge will improve. See, nowadays AI is there, but for troubleshooting purpose, if you have knowledge, then you can make use of the AI also, right? So that way it will help you. So I will put it okay there. So thanks for today's session. Thanks for joining, and we will connect next week, 7 p.m. And I will share all the details in the WhatsApp group. I will create a WhatsApp group, and I will share all the details. So today's recording will be available by tomorrow morning. I will put it, and then I will inform you everything. Okay. Tomorrow, like first half of the day, I will give you all the information. Thanks, everyone. So this is the complete architecture of Snowflake. So it has 3 different layers. So we have the storage here and query processing and cloud services, right? Yes. The storage, so it will be stored in any of the cloud platforms which we are selecting. And on top of that, we have the query processing. So query processing will take care in the Snowflake end. So this is the Snowflake end we have, and it is called virtual warehouse. So based on our requirement, we can create the virtual warehouse. So based on the number of transactions, right? So it will have the caching as well as the SSD storage it will have. And we have the metadata. So here we have the metadata storage. It's nothing but it will hold all the metadata. Today I will show you that. So how the query, if I'm going to fire some query in this Snow site, so how it will be executed, I will show you so that you will get clear idea about all these 3 different layers. So authentication and access control, so infrastructure manager, so everything will be taken care by this cloud services, this layer, optimizer, transaction manager, and security. So everything, this will be taken care, this cloud services. Okay. So if you are firing any query, so first it will go to the cloud services. Okay, it will go to the cloud services layer and it will check first. So whether it has all the information. First it will check authentication and access control. So whether you have all access control, you are authorized to execute the query. So once you have authorized, then it will go to the metadata. So here it will have the metadata information, right? It will check whether this query has been executed already or the result, some results. Okay, if you take some count or minimum or maximum, this way of values, it will be stored in this metadata itself. It will check. If it found, then it will give the result. Otherwise, it will go and check in the caching. Okay, the caching will be retained for 24 hours. Okay, so whatever the query you are executing, the caching will be retained for 24 hours. Then it will check this in Snowflake will check query this caching. If it is there in caching, it will automatically give you that result. So still it is not there, then only it will go and check in the storage. So based on the query previously we have executed or so we are firing newly. So based on that, the cost will vary. Okay, so that we will see that. So what are the different editions are there, right? So we have seen yesterday while creating the Snowflake, we have seen different editions, right? So 3 different editions we have seen while creating the trial account. But totally we have 4 different editions. So we'll see one by one. So what are those 4? And so what is how the pricing and everything is calculated. Okay, so there are 4 different editions are there in Snowflake. So what are those 4 editions? So these editions, based on our requirement, we have to choose it. The company has to choose, and usage, the organization usage and specific requirement, they will choose. So if I want to buy a laptop, So based on my requirement, I will go for it, right? So similarly, so here also, so based on our requirement, we can go for these editions. We have 4 different editions. This edition also will get definitely in the certification questions. So about editions and sub features, you'll get question. So first one, standard edition. So it will have the basic features. Okay, it's an introductory editions of Snowflake. So if you don't have much requirement, then you can go for standard edition. But most of the organizations, they'll go for enterprise edition. So it will have additional features than the standard one. Then we have the business critical. The third one is business critical. Then the fourth one is VPS, virtual private Snowflake. So these are the 4 editions are available. So standard edition, enterprise edition, business critical, and virtual private Snowflake. So if you need virtual private Snowflake, then we have to contact Snowflake support team only. So they will contact the sales team. So they will contact us based on the requirement. They will build private cloud platform. On top of that, they will create all the accounts and everything. Okay, so these are the 4 editions we have. So yesterday, while creating the account, we have seen these 3, right? Standard, enterprise, and we have selected enterprise edition. Okay, so what are there in enterprise editions? So as per the organization need, the changes and the growth, the editions, changing the editions also. For example, I have selected first standard edition. After that, I'm thinking, okay, I want to go for enterprise edition. Yes, so we can go for enterprise edition. Changing the editions is very easy. And yeah, so you even if you are in enterprise editions, you are going for more security features you need, then you can go for business critical. So on top of that, you can go for virtual private Snowflake as well. So what are those 4 editions? Here we have standard edition. So it's entry level. So it will give you that entry level. This is a basic introductory level of editions we have, and providing access to core platform. So core Snowflake platform, it will give you the access. And so if you want to go for very cost effective, then you can go for this standard edition. Next one is enterprise edition. So this is what the companies, most of the enterprise will select. So 95% of the enterprise, they will select this edition only. So for large scale organizations, including multi-cluster warehouse. So cluster is nothing but I explained, right? So group of warehouses, the compute engines. So how it will be used in the enterprise edition. And business critical. So if you want to go for data protection, so if the particular company is going for sensitive data is handling, so they have to use the PII information, right? PII means personal identification information. They have to do some encryption, decryption, sensitive information. They have to do all the data protection with a very high level. Here also we can perform, but this is especially for that business critical editions. Okay. And then virtual private Snowflake. This is for, so even isolated Snowflake environment. Isolated means so highest level of security and protection, and it will operate isolated environment. Okay, so based on the customer's need, the company will install that Snowflake on the private cloud, and then they will take it, all the editions, accounts, and everything. Okay, these are the 4 editions we have. Okay, we'll see one by one in detail. So first the standard edition, introductory level. Then this is enterprise editions. So it will have all the features of introductory level, and it will go for the large scale enterprises, right? And business critical, you'll have the higher data protection for sensitive data. So if you are dealing with sensitive data, then you can go for business critical. So then you can go for VPS, the highest level of security. It's a VPS one, virtual private Snowflake. So what are those 4? What are the different features are available? So if you take standard edition, you will get complete data warehouse, right? Yes, you'll get the core platform you will get. In addition to that, customer dedicated virtual warehouse. Yes. So we have different sizing warehouses. So that warehouses we can take. So what are the warehouses are available? So we have 7 different sizes we have, right? So based on that, we can choose. And the customer dedicated virtual warehouse and free data sharing across regions. So multiple regions, the particular regions, across regions, you want to share the data. So you have customers in different places you want to share the data. Yes, across regions you can select, you can send the data, share the data. And data encryption, so it will automatically, it will do the data encryption, and we'll get support, 24/7 support you'll get, and you'll get Snowsite access, right? Snowsite is nothing but the web UI, that web UI we have, right? That access we'll get, and external functions. So we have external functions. So these, what is external function? All this we'll see. What is database replication? Those concepts we'll see in detail. So time travel, so we can go up to 1 day. So here in standard edition, 1 day. For example, I have wrongly deleted data. Last day data I have deleted. Yes, I can go 1 day before what is a snapshot of the table, and I can retrieve it. Okay, so that 1 day before I can go and then I can check. So that is a time travel. So time travel, we have separate session. I will explain that. And disaster recovery, we can go up to 7 days beyond the time travel. So we have disaster recovery and network policies. So everything, these are the standard one. Okay. And authentication, single sign-on. So everything is there. So these are the standard edition. So if you go to enterprise edition, all these features are available. Okay, next level. So it will have the features will be available. So next it will go to the standard features. So all standard features, and here we have the multi-cluster warehouse. So the cluster is nothing but group of the resources, you can use it. And here we have 1 day, right? Time travel, so 1 day. So based on the edition, it will vary. Here we can go up to 90 days. So how we have configured, based on that we can go up to 90 days. So you have dropped the table. If it is Oracle or SQL Server, so we cannot retrieve, right? So if you have truncated the data, if you don't have backup, yes, you cannot retrieve the data. But here in Snowflake, we can retrieve it. And so rekey of all encrypted data. For example, for encryptions, you'll get the key, right? And you want to get rekey, so they will give us the annually, they will give the rekey. It means different key for encryptions for security purpose. And materialized view, we can create a materialized view here. So what is materialized view? The view is normally virtual table, and materialized view, so normally it's look like a physical table. So where we can see that the table, actual table, and it will take the data from there, from the views itself, the materialized views itself. I will explain that later. So search optimization service available, and dynamic data masking. So external data tokenization. So column level security. So each column level you have the security. So 24-hour early access to new release. Okay, so weekly releases. So these options are available in the enterprise edition. And if you go to business critical, so all whatever we have seen here, so all these options are available here. Okay, all enterprise features. It means so both enterprise and standard. So it will have here. And in addition to that, so we have this support. This is for data protection support. This will have some standard. So we have to follow that particular standard, and they will support it. These are for standard data support only. Okay, so additional data security. So customer managed encryptions also, it will be supported, and data specific regulations. Okay, everything will support. So database failover, so failback. So that is disaster recovery. We'll have extra, and AWS private link support is available. Okay. If we go to this one, VPS, it's the highest level of security. You can go for this VPS. Okay. And VPS, we have to contact this Snowflake sales team. Then they will guide us how to create this VPS network, this VPS Snowflake. So dedicated isolated Snowflake environment, especially for that particular enterprise, and it will give you that highest level of security and compliance. Okay, everything. And customer dedicated metadata store. So here, so we can handle it, the metadata store. So that, because it's a private network, the private Snowflake, right? So we can manage it, everything. So these are the different options are available in the editions. Remember these 4 editions. So sometimes in interview they will ask, so what are the 4 editions? It's nothing but standard, enterprise, business critical, and VPS. Okay. So why I'm repeatedly saying, because you should remember all this, okay, here itself. So no need to, again, no need to go through that. So here itself you'll get. So in addition to that, so how the security, governance, and data protection, everything will be there. So that you can check it here. So if you go to Snowflake website, so they have given everything clearly. So if you go to, even if you go to this website, so you can get all the details. So what are the editions are available? So whatever I explained. So here you will have standard editions, okay, and enterprise, business critical, VPS. So what are the options are available? So you can check it here. So which one is not available here? Okay, so for example, standard is available up to here. Enterprise, so these are the options, okay. Extended time travel, so you can go to up to 90 days. So 90 days it's available for remaining editions, right? So like this, you can see, so column level security, row level security, it is not there in standard editions. So this way you can check it. So what options are available? So how the compute resource management be available, SQL support, so what are the functions will be available. So everything you can check in detail here. But this is the overall idea about the Snowflake edition comparison. Okay, if you go to this particular link, okay, this particular link, so we have the different editions and pricing. So pricing will vary. So actually, if you ask me, Snowflake is the cost effective one. Yeah, it's cost effective one if we use correctly. Okay, if you use in an optimized way, if you use this particular system, the Snowflake, then it will be cost effective. If you are not using that, so definitely it may give you more cost also. So these are the the options are available: standard, enterprise, business critical, and virtual private Snowflake, right? So we have, so based on the platform. So if you select the platform here, based on the regions, this will be vary. This will vary. The cost will vary. For example, so this is the Northern Virginia. We have less cost, right? $2 for standard editions. So per credit. So how the credit will be calculated, I will explain. But this is for per credit. Okay. So per credit is for if you are using this Snowflake, this particular standard edition for 1 hour. Okay. So if you are using 1 hour, then this is the cost. So what is the cost? $2 per hour for the computation cost. This is for computation cost and the virtual warehouse we are using, right? So for that, if you use the standard edition, we are using that compute engine for 1 hour, then this is the cost. So minimum is 1 minute. So we have to use minimum 60 seconds. After that, it will be calculated based on the seconds. So not minutes or hours. So minimum is 1 minute. So after that, it will calculate based on the hours, the seconds. Okay. So standard editions, it will go to $2. This is the minimum we have. And we have the enterprise edition, $3 per credit. It's a US dollar and $4 for this business critical. And this is we have to check with the sales team only. And if you take, for example, I have, that is why this one is very important. So selecting the regions, selecting the platform is very important. For example, I have selected AWS, but I'm going for this Singapore regions. Then what could be the cost? So we have the 2.50, right? So 2.50, 3.70, and 5 here. So instead of 4, so it's a 5, right? So it's a 2, 3, 4 previously for that. Now it's we have, and even if I'm going for Australia regions, then it is more 2.75, 4, and then 5.50. So if I'm selecting India, that is Mumbai, then 2.20. So it will vary. So even if I'm going for Azure, then it may vary. For example, Azure, and I'm selecting any other regions here, Canada. So it will be 2.25, 3.50, and then so based on that, I can decide. So which one I have to select, and so what is the cost effective. So you can do the POC first. Okay, proof of concept first. Based on the proof of concept, so you can do that. So this particular, we can choose which editions we need. And if you need, so if you want to check all the features, so you can check it here, all features. And if you go to the storage, it is not, it is a computing, right? So how we are performing, how we are using that compute engines, based on that, it will calculate. But if you go to storage, so storage, it's a flat rate. Okay. It's a flat, it's nothing but if you're using 1 terabyte of data for 1 month, then it's $25. Okay. This is also, it will vary based on the account, which platform we are selecting and which region we are selecting. Okay, it will vary. So if I'm going for any other AWS and US East, it's at $23, right? So based on that, it will vary. That's what we have to select. So if you are storing without any computations, if you are using only for storage, so it will take that particular amount. Okay, so first it will take computation. So computations for minimum, it's a $2 per hour. Okay, so for 1 hour. So if you are using that, so completely the compute engines, it will take 1 hour. 1 hour, $2 for the standard editions. Standard editions. It will vary based on the edition. And storage, so they will ask some questions in the certifications based on this compute and storage and how much we are utilizing. Based on that, they will ask. Storage, if you are using 1 terabyte of data, okay, so 1 terabyte of data for 1 month, okay, so then they will charge so $23 to, so it will vary, $25, it will vary, but it's for 1 terabyte. Okay, so 1 terabyte of data. And then, so we have other cost as well. Okay, so first cost is, this is the compute. Another one is the storage. Another one is data sharing. So data sharing, so it has the cost associated for data sharing as well, based on where we are sharing the data. So you can check this page for complete understanding of how the what are the different features are available for each regions and how it will calculate